Chapter 16, Period 9, Section 3, Miscellaneous Discoveries of Franklin and His Friends, Section 2, Miscellaneous Discoveries of Dr. Franklin and His Friends in America during the same period. Dr. Franklin retaining the common opinion that electrified bodies have real atmospheres of the electric fluid, confining of particles at some distance from the surface of the body, but always going along with it. Observed that these atmospheres in the air did not seem to exclude one another, though he says this be difficult to conceive considering that they are generally supposed to repel one another. An electric atmosphere, he says, raised around a thick wire, inserted into a file, drives out none of the air it contained, nor onward through that atmosphere will any air roof fly in, as he found by a very curious experiment accurately made, whence he also concluded that the elasticity of the air was not affinity by it. The experiment, as the door informs me, was made with a FML glass siphon and zeroinchivgel, the cork into the bottle. The other leg had in it a drop of red ink, which readily moved on the least change of heat, or CPL'd in the air contained in the file, but not at all on the airs being electrified. The Alpho made an experiment which would seem to prove the immobility, as we may say, of these atmospheres by any external force, if they have any existence at all, but others may think it is rather an argument against their existence. He electrified a large cork ball fastened to the end of a silk string 3 feet long, and taking the other end in his hand, he whirled it round like a sling 100 times in the open air with the swiftest motion he could possibly give it, and observed that it still retained its electric atmosphere, though it might all have passed through 800 yards of air. To show that a body, in different circumstances of dilatation and contraction, is capable of receiving or retaining more or less of the electric fluid on its surface, he made the following curious experiment. He electrified a silver can in which there were about 3 yards of brass chain, one end of which he could raise to what height he pleased, by fine ends of a pulley and a ilken cord. He suspended a lock of cotton by a silken string from the ceiling of the room, making it hang near the cup, and observed that every time he drew up the Piankham's letter P97, chain, 'twas for discoveries, T-E-R, the cotton approached nearer to Thelia cup, and as constantly receded from it when the chain was let down. From this experiment, it was evident, he says, that the atmosphere about the cup was diminished by raising the chain and increased by lowering it, and that the atmosphere of the chain must have been drawn from that of the cup when it was raised, and have returned to it again when it was let down. To make electric atmospheres in tone measure, sure visible, TXC Doder used to drop rosin on hot iron plates held under bodies electricist, and in a still room the smoke would ascend, and form viable atmospheres round the bodies, molding them, look very beautiful. In trying what circumstances the repellency between an electrified iron ball and a small cork ball would be altered, he observed that the smoke of rosin did not destroy their repellency, but was attracted both by the iron and the cork F. The door observed that silver exposed to TJ electric VFC would acquire a blue lane, and that iron would be corroded by it, but he could never perceive any impression made a gold, brass, or tin. The spots on the silver or iron were always the same, whether they received the spark from lead, brass, gold, or silver, and the smell of the electric six rubbed the lame through whatever bodies it Y conveyed. IBU P81, 91, 91. Wits, Mr. Kinnersley, 22. While we err attending to what was done by Dr. Franklin at Philadelphia, we tend to by no means overlook what was done by Men Kinnerfly, the daughters Fuend, while at Boston, EPNFU, England. Some of his observations, of which an account is given in the doctor's letters, are very curious, and some later accounts, which he himself has transmitted TP England, seem to famify hat. If he continue his electrical inquiries, his name, after that of his Freefid, will be second to few in the history of electricity. He first gifted himself by covering Mr. Defay's 2 contrary electricity of glass and sulfur, with which both he and T.R. Franklin were at that time wholly unacquainted. But Mr. Kinnerfly had a great advantage over Mr. Defay, for making experiments in a more advanced state of the science, he saw immediately that the two contrary electricities of glass and sulfur were the very same positive and negative electricities, which had just been discovered by Dr. Watson and Dr. Franklin. He for Vici that a cork ballier electrified by a conduor from excited glass would be attracted by excited amber and sulfur and repelled by excited glass and china, that electrifying the ball with the evire of a charged file. K would be repelled by excited glass, but attract B excited sulfur, and that when he electrified it by sulfur or amber till it became repelled by them, it would be attracted by the wire of the file and repelled by its Q coat. 226 discoveries of coding. These experiments were perfect LNL very much, but by analogy he was led to infer a priori the follow paradoxes, as he calls them, which were afterwards verified by Dr. Franklin at his request. If a glass globe be placed at one end of a prime conductor and a sulfur one at the other, both being equally in good order and in equal motion, not a spark of fire can be obtained from the conductor, but one globe will draw out as far as the other gives in. 2. If a file be suspended off the condylator with a chain from its coating to the table, and only one of the globes be made use of at a time, 20 turns of the wheel, for instance, will charge it, after which as many turns of the other wheel will discharge it, and as many more will charge it again. 7. The globes being both in motion, each having a separate conductor with a file suspended on one of them, and the chain fastened to the other, the file will become charged, one globe charging phi lively, and the other negatively. The file being thus charged, hang it in like manner on the other conductor, set both wheels a-going again, and the same number of turns that charged it be sore, will now differge it, and the lame number repeated will charge it again. Brasclioff L. Tears, P99, Geo 5. When Mr. Kinnersley 22JJY2, each globe communicates with the Phi and E-pron conductor, having a chady hanging from it to the table. One of them, when free motion, of which I cannot Phi, will draw fire up through the Calhaio and discharge it through the chain, and if the other will draw it up through the chain and discharge it through the Cephalion. When Mr. Kinnersley was advising his friend to try the experiments with the Fulful globe, he cautions him not to make use of chalk on the Cuftision, telling him that some sign-powdered filfoof would do better. And he expresses his hope that if the DDF door should find the Tyro globes to charge the prime conjugate differently, he would be able to discover a method of determining which it was that charged Fed positively. Indeed, these experimentals and Einjefflers were propophatai to him, had no idea of their having any real foundation, but imagined that the DLF-10 attractions and Fapulfians FTP ferved by Mr. Kinnersley proceeded rostra from the greater or smaller tejuadities of the electric fire, obtained from different bodies and from its being either DFI in different kind, or having a different DITCFian, but ferreting upon trial that the principle of Ami Kinnersley's suppositions were verified by FAD. He had no doubt of the Refit Franklin letters PQQA ICAN G and Java Jit Fivelic 228 DSCOVRI. In answer to the doubt of Mr. Kinnersley whether the glass or the sulfur electrified positively, the doctor gave it at his opinion that the glass globe charged positively the sulfur negatively for the philolog reasons. DF cause, though the sulfur globe seemed to work equally well with the GLAN1, yet it could never occasion so large and so distant a spark between his singer and conductor as when the glass globe was used. But what he adds to confirm this proof does no ADT seem to be fatifattery. He supposes that bodies of a certain bigness cannot FBB E-foolish apart with the quantity of E-evaporate fluid, which they have and hold attracted within their substance, as they can receive an additional quantity upon their surface by way of atmosphere, and that therefore so much could not be drawn out of the conduor as might be thrown on a tree. 3. He observed that the flame or proofy of fire, appearing at the end of T-wire connected with the conductor, was long, large, and much diverging when the glass globe was used, and made a snapping or rattling noise. That when the sulfur globe was used, it was short, small and made a biffio noise. He observed that just the reverse of both TXCFE cases happened when he held the same wire in his hand, and the globes were worked alternately. The brew was large, fratically lit, P104. Long, Mr. Kinnersley, 229 tongue, diverging and snapping or rattling when the sulfur globe was turned. Bowie Horch Jamal, and Heifling when the glass globe was turned. When the brewfly was long, large, and much diverging, it seemed to the doter that the body to which it joined was throwed the fire out, and when the contrary appeared, it seemed to be drinking warm 3, HB observed. That when he held his knuckle before the sulfur globe, while it was turning, the stream of 6 between his knuckle and the globe seemed to spread on its surface, as if it slowed from the singer, but before the glass globe it was otherwise. 4. He observed that the cool willed horror, what was called so, which is felt as coming fraughty and electrified point, was loch more sensible when the glass globe than when the sulfur one was used. But these, though the best arguments which the senses can furnify of the course of the alcharic fluid, DFF Daffod acknowledges WTFE, but hasty thoughts. Indeed, considering that the velocity of the electric fluid has been found, by experiment, TJ be nearly TNF instantaneous in a circuit of many miles, if cannot be supposed that the eye shall be able dift and gifty. Which way it goes in the space of 1 or 2 inches FJ, shall conclude this article with Olaf aimed that the experiments, which the doter made with globes of glass and sulfur arc, through much 30 improvements and much more easily exhibited by the content and insulated rubber of either of them, all CFEDs being the reverse of each other. For the present, take leave of this ingenious writer and his friends, after having bruggled the history of their labors to the year 1754, and must return to see what Vigas doing on the continent of Europe for. Tagu Q, or 3 years preceding this date, while lested to go over to America. Chapter 17, Period X, Section 1, Improvements in the Electrical Apparatus, time that D.B. Franklin made his experiments in America. Till TLCR, 1766. Now, in careering upon the last period into which the history of electricity divides itself, in which the great variety of matter presented to our view must oblige an historian to have recourse to the Furleft method. For, Oscarwife, the narration would be extremely perplexed and difficult. Laying aside, this period contains the events of a later space of time than most of the others, yet without any convenient resting place. As the business of electricity has been considerably multiplied in it, and a greater number of laborers have been employed in gathering in the harvest of discoveries, the seeds of which were sown by Dr. Ichivat Fon, Dr. Franklin, and others in the preceding periods, I am obliged to subdivide this into more distant parts, but I hope they will not be found to be more than were necessary, in order to prevent confusion. However, this circumstance, of the great quantity and variety of materials furnished in TIS period, in proportion as it tends to embarrass an historian, and exercises talent for proper distribution and arrangement, is a striking demonstration of a truth, which will give the greatest pleasure to all the lovers of electricity and natural philosophy. If the progress continue the same in another period of equal length, if the harvest of discoveries continue to be more plentiful, and the laborers proportionably more numerous, what a glorious scene shall we see unfolded! What a fund of entertainment is there in lore for us! And what important benefits may be derived to new light! Improvements in the electrical apparatus, with experiments and observations relating to it, as our electrical apparatus has been much improved in this period. I shall first recite what has occurred to me upon this subject, particularly the methods which have from time to time been communicator of increasing the power of electricity by different circumstances of excitation. So early as the year 1751, upon occasion of trying Mr. Winkler's experiments, notice is taken of Mr. Canton's method of rubbing tubes with silk prepared with linseed oil. He had found, by the experience of some considerable time, to produce the greatest FE upon tubes, but he had not found that they were proportionably useful at nibbing globes. Upon another occasion, Mr. Canton observed that by means of this rubber, a solid cylinder of glass, which had been fet before the fire till it was quite dry, might be excited as easily as a glass tube, so as to add like one in every reft. That even the first Froke tube would make it strongly electrical. But N on the electrical apparatus, 23J. But the greatest IK improvement which Mr. Canton discovered for intricathy, the power of electricity, was by rubbing on the couflion of the globe, or on the oiled silk rubber of the tube, a fatal quantity of an amalgam of mercury and tin, with 3 very little chalk or whitened. By this means a globe or tube may be excited to a very great degree with very little friction, especially if the rubber be made more damp or dry as occasion may require. Mr. Wilke says that a glass tube excited with a woolen cloth, on which some white wax or oil has been put, will put flames with a great noise in the dark FB. These flames, he never knew to be thrown from a globe, except sometimes when they were first used, J. Our electrical apparatus has been much augmented within this period by the discovery of Father Windelinus Amerfin of Switzerland. Woo. In a Latin trodifife, Puhufid at Lucerne, Illi the year 1754, has fly on us that wood properly dried, till it becomes very brown as a non-conducer of electricity. He recommends boiling the wood in linseed oil or covering it over with varnish after being dried to prevent any return of moisture into its pores, and adds that wood, FP treated, seems to afford stronger appearances of electricity than even glass. He himself made use of common wooden measures, such as are usually Gyre 34 improvements, and usually found in granaries. First boiled in oil and afterwards mounted so as to be turned by a wheel. It appears from the Philosophical Transthalians, says Mr. Wilson, so early as the year J747, that Dr. Watson, having occasion to support a long wire in an experiment made near Shooter's Hill, with a view to determine the velocity of electric fluid, used slakes of dry wood which he told him were baked to prevent the electric fluid from escaping into the ground. A more extraordinary method of procuring electricity than by baked wood was one that Signor Beccaria made use of. He put 9 dry and warm cat's eken upon his glass globe, and rubbing it with his hand, excited a very powerful electricity. These wooden cylinder and elephrorphy positively or negatively as the rubber is ilk or flannel, but much more powerfully when negative than when positive, a wool to the roughness which there generally is upon their surfaces, and therefore make an agreeable variety in an electrical apparatus. But the oldest and most usual method of procuring negative electricity was by globes of sulfur. These Mr. Leroy made by putting a coating of sulfur upon a globe of glass, and then mouilling it with an hot iron. But Mr. Nollet preferred melting the fulfif in the indeed of the glass globe, and then breaking the glass from off it, because this method made a much isner pofty. One globe he made of a mixture of sulfur and pounded glass, but he found that it had the same TFAO, as if it had been all of sulfur. He says that when one part of this globe, the light excited, the whole surface became electrical F. But FMCC, Mr. Canton's discovery of the negative power of rough glass, some philosopher 8A, made use of glass globes made rough by emery. And the usual method of taking off their pole L was by rubbing them as they turned upon their axis. But Mr. Speedier, mathematical instrument maker at Copenhagen, observes, in his letters upon the subject of electricity, that glass globes, made rough by drilled the stone or emery from pole to pole, have a much greater virtue. The method of taking off the polyfly, giving them a greater roughness with refka to the rubber, but a better and a readier method than all these of producing negative electricity is by insulating the rubber of a smooth globe and coating it with an insulated prime count duffler, while the common conductor hath a communication with the ground. The rubber, if well insulated, is sure to produce a negative alphoricity equal in power to the positive the same globe. Mr. Dalabar Dureffels Anodit's Letters, Volume EI, PLI, Great Yabba 36 Improvements, in great number of precautions, in order to electrify well at the Shuberry, and to prevent it from receiving any electric fire in its state of inflation. Mr. Birdman of Upful says that very often, when his glass globes could not be excited to a sufficient degree of F-tank, he lined them with a thin coating of Idelfer, and that then they gave a much stronger positive electricity than before F in Italy and ether places. Mr. Nala informs us it is the custom of electricians to put a coating of pitch or other resinous matter on the inside of their globes, which they pretend makes them always work well. We are obliged to the Abbé Nollet for some obviouses on the alcizrical powers of different kinds of glass. In the 6th volume of his Herons de Physique, printed in the year 1764, it is not every sort of glass feuille that is equally L5 risable. There are some sorts which are not so at all, or hardly at all. Such, for example, is that of which they make plates of glass at St. Goban in Picardy. I have tried it, says he, 100 times in the form of plates, tubes, and globes, and in all kinds of weather, but have scarce been ever able to draw from it the least sensible sign of decrissity. Dalibert's Priestley 110, one allocation volume it, PLY TBS TSJ, glass of which pains for will does he made, and which is also used for drink glaffles. When it is newly manufactured, is excited with great difficulty, often JC. Repeatedly rub tubes and other pieces, even in the glass house where they wamadi, but without success. And at Ugia and Opie delightful after some months and 4 months, times years, that I could bring them TP. It is certain. And he says he has Kalun if obnerad that glass beacon needs more fit for FS-lycal experiments by force of rubbing and 9 net. Sometimes it has required BME to bring globe and tube to 801. He did not think that these fads could be accognited for either by the different degrees of transparency or the different colors of glass. This, indeed, was evident from Fourier GEE's acquiring electricity from use why he had it not originally. The glass of which bottles are made at Severs served him very well, where he has globes of white glass. It not become tolerable till altar having been used a certain time. H.B. could not tell positively why certain kinds of glass were risable or not by ubbing, but he forfeited that it was principally owing to the degree of its hardness and vitrification. He was induced topwinkle because he fucked not at that the glass at the Frendi Manufactore at St. Goban and at Cherbourg the hardest, the most compayoft, and the bell tilrified of all the kinds of glass in France. Was Jetta 38 improvements, RRF was the most difficult to be laserized, wherefore as the crystal glass of England, that of Bohemia, and of which are much foster, were the best of all for experiments in electricity. He says, moreover, that he had procured imperfect glaffles, which had not been long enough in the furnace to be clear, and that, though they were of the same composition as plates of glass, which H and B before were not easily electrized, yet that THC were excited very sensibly. He says that a globe of 10 or 12 inches diameter, and which mates about 4 revolutions in a second of time, will receive a convenient rubbing. But that we must not expect that if the globe be 1/2 or onto a 4th part, greater or less, the effects will he increase it or diminish it in proportion upon the subjecta of insulating bodies. He observes that when the cakes of sulfate resin, healing wax, and beeswax are made use of for this purpose, they ought to be well cooled before they are used. For he says he has confidently observed that when they are newly made, they are not so proper to infuriate bodies, as they generally are at the end of some months. It will be proper under this head to add quaint young electricians that globes have been several times known to burst during the akika of excitation, and that the arragments have been thrown with great violence in every die region, electrificaliapatatis, 239 reflying, so as to be wide dangerous for the bystanders. This accident happened to Mr. Savatelli in Italy, Mr. Nala in France, Mr. Eraud at Lyons, Mr. Bose at Wittenberg B, Mr. Lecat at Rouen, and Mr. Robin at Arcy. The air in the inside of Mr. Savatelli's globe had no communication with the external air, but that of the Abbé Nala had. This last, which was of English flint, which had been used 2 years, and was more than a line thick, burst like a bomb in the hands of a servant who was rabbing HED, the fragmi ensiadies, the largest of which were riot more than an t-shirt in diameter, were dispersed on all sides into a confidentable tank. That all the globes which were burst in that manner exploded after 5 or 6 turns of TXTC wheel, and he ascribed this CFCC to the action of the electric matter, making the particles of the glass vibrate in a man he could not conceive. When Mr. Baroy had globe beyond our field, and he was the Yurft to whom this accident was every hour known to happen, he was making some experiments in the dark on the 8th of February 75. DFCN followed the exploit, and when the lights were brought in, it was observed that those places of the floor which were opposite to the equatorial diameter of the globe were strewed with F. Mailer of Furo Improvements IW F. Mailer pieces, as D in greater numbers that those which err or poet to Athea parts of it. This globe had been cracked, but it had been in constant use in that state above a year, and the CFAC had extended itself from the pole to the equator. The proprietor ascribed the accident to the vibration and the particles of the glafa, and thought that the crack before some way impeded those vibrations. When Mr. Bow's globe broke, he says that the whole of it appeared in the aeon of breaking, like a flaming coal, a circumnihilance which we fly see accounted for hereinafter by Mr. Voot C.F. Mr. Bott. Lansixer says that glass globes have fumatime at bureau like bombs, and have wounded many persons, and that their fragments have even penetrated several inches into a wall X. He also lays that if globes bursten whirling by the gun barrels touching them, they burl with the same violence, the splinters often entering into the wall section. The Abbé Nolet had a globe of sulfur which also Burfy, as he was rubbing it with his naked hands, after 2 or 3 turns of the wheel, having first cracked inwardly. It broke into very small pieces, which slew to a great diflance, and into a senile dull, of which part slew again for his naked briefle, where it entered the felsen so deep that it could not be got off without the edge of a knife. IMRP. 87. T. Vilka P. 114. B. Nocti letter VDI it PSOO. Chapter 18. Period X. Section 2. Conducting power of various substances. SECT, near. Observations on the concuting power of various substances, and particularly Mr. Canton's experiments on air. Re is on air and water. On B of the principle diffiterant in the phenome of electricity is to ascertain, wherein consists the different flame between those bodies which are conductors and those which are non-conductors, cue the electric fluid. All that has been done relating to this briefly and till the present time amounts to nothing more than observations. How near these two classes of bodies approach one another, J, and before the period of which I am now treating, these observations were few, general, and superficial. But one I'll now present my reader with several very curious and accurate experiments, which, though they do not give us entire satisfaction with reference to the great defteritum above mentioned, yet throw some light upon the subject. They show that substances which had been considered as perf conductors, or non-conductors, are so only to a certain degree, and that probably all the known parts of nature have, in some measure, the properties of both. These experiments were made by 2 persons whom, in the style of Biftery, I-22 SBC areas may justly call 2 of the greatest heroes of this part of my work, viz. Mr. Canton, whose discoveries in electricity are far more numerous and more considerable than those of any other person within this period in England, and Signor B. Ticaria, one of the most eminent of all the electricians abroad. That air was capable of receiving electricity by communication, and of retaining it when received had not been difficult for any person before Mr. Canton. But by the help of one of his exquisite contrivances, he was able to ascertain that delicate circumstance, and even measure the degree of it. If it was IA the least considerable, he got a pair of balls, turned in a lathe out of the dry pith of eider. These he put into a narrow box with a aiding cover so disposed that the threads, which were of the fine linen, were kept straight in the box. Holding this box by the extremity of the cover, the balls would hang freely from a pin in the inside. These balls hung at a sufficient distance from buildings, trees, and sea, easily flee off the electricity of the atmosphere. They also determine whether the electricity of the clouds and the air be positive by the decrease, or negative by the increase of their repulsion, at the approach of excited amber or feeling wax. D.V. the help of this instrument, he observed, that it was possible to elify the air of a room near the apparatus, and even the fex perlowensinal 243, the air of the whole room in which it was, to a coefiderable degree, and he was able to do it both positively and negatively. In a paper read at the Royal Society, December the 6th, 1753, he observes that the isomansur of a room might be electrified to considerable degree, so as not to part with its electricity for some time. Having Refelder ed the air of his room very dry, by means sea of fire, he alibified a tin tea-bay, nithipated bias suspended at one of its extremities, to a great degree when it appeared that the neighboring lure was ukawife electrified. For, having touched that tubey with his singer, or any other conductor, the balls, notwithstanding, continued to eifipple one another, though not at so great a distance as before. But he observes that their RC pulfion would decafaith as they were moved towards the floor, wainscot, or any of the furniture, and that they would touch each other when brought within a small distance of any condifluent. Some degree of this eleric power he has known to continue in the air above an hour after the rubbing of the tube, when the weather had been very dry, to elerify die air or the moifler contained in it negatively. Mr. Canton support ed by Phil C. stretched between two chairs, black ed back to back at the difle ants of about 3 feet, a tin tube with a signed sewelled needle at R31 244 S. Becarian di one ended, and rubbed sulfur feeling wax, or a rough glass tube as near $1 B could to the other end for 3 or 4 moon newts. After which he found the air to be negatively electrical, and that it would continue IO a considerable time after the apparatus was removed into another room. In a paper dated November, the IIBB 1754, he says, that dry air at a great difting from the earth, if in an elaphaxic state, will continue so till it meets with fumi condifluent, is probable from the following experiment. An excited glass tube with its natural pulley B, and placed upright in the middle of a rooney by putting one end of it into an hole, made for that purpose in a block OGFA would generally lose its electricity in less than 5 minutes, by attraying to it a sufficient quantity of moisture to conduct the ELA and RLC fluid from all parts of its surface to the floor. But if, immediately after it was excited, it was placed in the same manner before a good fire, at the distance of about 2 feet, where no moisture would adhere to its surface, it would continue electrical a whole day, and how much longer he knew not F since the publication of the edition of this work. Mr. Canton has hit upon another, much readier, and more powerful method of communicating electricity to the air than that described above. This he give, leave to Publifa, and it appears to me to be of such a nature as that it may or possibly lead to farther discoveries concerning the life here and the phenomena depending upon it. Take, says he, a charged file in one hand and an unlighted candle insulated in the other, and going into any room, bring the wire of the file very near to the flame of the candle, and HDD'd it there about half a minute. Then carry the file and candle out of the room and return with the pith balls, suspended and held at arm's length. The balls will, begin to separate on entering, and will stand 1.5 inches or 2 inches apart. When brought and the in the middle of it, Signor Beccaria, who had no knowledge of what Mr. Canton had done, made the same discovery of the communication of electricity to the air, and diversified the experiment in a much more pleefemjing and fatifjaftery manner. He proves that the air which is contiguous to an electrified body acquires by degrees the same electricity, that this electricity of the air counteraffles that of the body and leftlens its FFBs, and that as the air acquires, so it also parts with this electricity very slowly. He began his experiments by hanging linen threads upon an electrified chain, and observing that they diverged the most after a few turns of his globe. After that, they came nearer together, notwithstanding he 3 TPEP 246 SF. The carriers kept turning the globe, and the excitation was as powerful as ever. When he had kept the chain elerified a considerable time, and then discontinued the frioi, the threads coalesced by degrees till they hung parallel. After this, they began to diverge again without any further eleflerification, and if the air was still, this second divergence would continue an hour or more. This divergence was lessened by the electrification of the chain, for if the globe was turned again, the threads would become parallel and then begin to diverge again as before. Thus, the second divergence of the threads took place when the chain was deprived of its electricity and when that which the air had acquired began to move over itself. While the threads are beginning to diverge at the electricity of the air, if H touch fed the chain, and thereby took off what remained of its electricity, the threads would separate farther. Thus, the more the electricity of the chain was lessened, the more did electricity of the air appear. While the threads were in their second divergence, he hung two other threads, shorter than the former, by another silk thread to the chain. And when all the electricity of the chain was taken quite away, they would separate like the former threads. Let us see del electricifino, PS7F, if he prefici four other threads to the former, in their second divergence, they would all avoid one another. In this complete and elegant manner did Sicture Beccaria demonstrate that air actually receives electricity by communication, and lofiate it by degrees, and that the electricity of the air counter-rattles that of the body which conveys diversity to it. Gicnipier Piscarialfo made a variety of other experiments, which demonstrate other mutual affions of the air and the electric fluid, particularly thimae, that prove their mutual repulsion, and that the diphivric fluid, in passing through any portion of air, makes a temporary vacuum. He brought the ends of two wires within a small distance of one another in a glass tube, one end of which was closed, and the other immersed in water, and observed that the water sunk in the tube every time that a fjark passed from the one to the other, the electric fluid having repelled the air of eft. He made the electric exploilon a great number of times in the same air enclosed in a glass tube, in order to obtain whether the elasticity of the air was affected by it. But he could not find any alteration. After the operation, he broke the tube under water, but neither did any air make its escape, nor any crater force its way into the tube. The XBL Hector del Elitercerm, P90, R4 Riment, 2014 Estes. That carry-off remit was made with all the precaution, with lex respect to heat and cold, that the nature of the case required. S. G. Kior, BF carries experiments on what T. Terhio willed, its imperfectly as a condufleur, are more surprising than those he made a poire show its imperfection in the contrary respect. They prove that water can do to electricity according to its quantity, and that a F milli quantity of water amninicus. A very great resistance to the passage of the electricity fluid. He made tubes full of water particles, electric circuit, and observed that when they were very small they would not transmit a shock, but that the fidiac increased as wider tubes were used. But what aftonises us most in Signor Beccaria's experiments with water is his making the electric spark visible in it, notwithstanding its being a real condufleur of electricity. Nothing, however, can prove more clearly how imperfect a conductor it is. G. efferted wires FPS nearly to mit in small tubes filled with water, and discharging hawks through them, the electric spark was euphibic between their points, as if no water had been in the place. The tubes were generally broken to pieces, and the fragments driven to a considerable diphtonach. This was evidently occasioned by the repulsion of the water, and its incompressibility, it not et etrusifmo artificial eo curale, PSI. Being able to give way far enough within IDFLF, and the force with which it was repelled had been very great. The force with which small quantities of water are thus repelled by the electric fluid, he says, is prodigious. By means of a charge PF 400 square inches, he broke a glass tube 2 lines thick, when the pieces were driven to the distance of 20 feet. Nay, he sometimes broke tubes 8 or 10 lines thick, and the fragments were driven to greater diphlances in proportion. He found the effect of the electric farfi upon water greater than the FE of a spark PF common fire on gunpowder, and says he does not doubt, but that if a method could be found of managing them equally well, a cannon charged with water would be more dreadful than one charged with gunpowder. He ably charged a glass tub with water, and he put a immoll ball into it when it was discharged with great force, so as to bury off in some clay which he placed to receive it, X is reference which small quantities of water make to the electric matter, he imagined, was greater than the resistance made to it by air section, and yet he thought it was electrodrino utificially natural at P. One greater effete than there, by making the electric spark visible ID till inlaid a voice it. Oil being IDB worse conductor, the spark in it would be larger. Diflenatio Fichafica, P16. It carries possible that in this case the electric matter might not aidle upon the water immediate IV, but upon the fixed air that was in it. For when the tubes were not broken, he observed that a great number of air bubbles were let loose through the whole mass of the water, rose to the top, and mixed with the common atmosphere. He also imagined that the electric fluid added upon the fixed air in all bodies, though no experiment could make it sensible effort. On the contrary, he supposed that the action of the electric matter tended to 6 elastic air, Hj, exciting a sulphurous matter, which Dr. Hales shows to have that property, J, but the experiment above mentioned of the tri-spark taken in a closed tube doth not favor this supposition. Ethan, a small drop of water was put between the points of 2 wires, and a large fiat pasted through them. The water was equally dispersed on the inside of a glass eye-sphere, which they were all enclosed. In the same manner, he conjectures that the aotion of the electric matter promotes the evaporation of water section, discharging a shock through a quantity of water poured on a flat surface, where former parts of the circuit were purposely left almost dry. Those parts became quite dry, sooner than they would have been if AO shock had passeroed through them HTL bid. Section Pel bid DPLI nibid P easy upon this principle, he account for the supposed bursting of the blood vessels in small birds, killed by the electric shocking, and for when a mufsic contrast by the shock. He supposes it is owilgal to the dilatation of the fluids their fibers contain, as the F leafric matter pull T through them. So imperfect a CQ inductor of electricity, mere water, that, he thought, a green lias can do to oyak better than an R equal thickness of water. If this be true, and vegetable fluids can do electricity better than water, it will confirm a conjecture which Dr. Franklin told me he had drawn from some experiments that he had not properly pursued. 'Tis that animal fluids can do it electricity better than water. He tried milk many years ago, and Mr. Kinnerfleet and others, America, FIA since tried blood and urinilla and alpha, the fell news of animals newly killed. And they were all found to be exceedingly good conjurers, remarkably better than water. Sionier Beccaria also found that even metal is not a perfect conductor of electricity, but made some resistance to the passage of the electric fluid. This he ascertained by measuring the time that it was retarded in its pulling through long and small wires, notwithstanding the experiments which had been made before that seemed to prove the contrary. HS, he suspended a wire of 500 Paris feet in a large building jana by means of a pendulum which vibrated half seconds of it that light bodies placed under a ball P of gilt paper at one end did not move till one vibration of this pendulum after he had applied the wire of a charged file to the other. Trying the lame with a hempen cord, he could count 6 or more vibrations before they would stir, but when he had wetted the cord, they were moved after 2 or 3 vibrations. He does not, however, absolutely say that the electric fluid must have taken up all this time in its progress, as it might require a certain quantity of the fluid before it could rife the light bodies. But he did imagine that it moved with more velocity in proportion as the bodies into which it passed had more or less of the fluid before F, and he was confirmed in this opinion by several phenomena of the atmosphere, which will be related in their proper place, particularly by seeing, very evidently, the progress of a quantity of dendritic matter in the air as it advanced to strike his kite. To these experiments of Signor Beccaria on the conducing powers of air and water, I shall subjoin another curious fet of the same author, showed the manner in which TAKP smoke of rosin and of California is a fill, and by the approach of an electrified body, OSMOK 253 body, repeating Dr. Franklin's experiments to make electric atmospheres visible with the limeme of California, which he preferred for this purpose to rosin. He fear of several curious circumstances, which had escaped the notice of that ingenious philosopher. He heated the California on a coal, which he held in a spoon under an LRFI cube of metal, and observed that when part of the smoke ascended to the cube, another part covered the handle of the FD pan and FPCAD to his hand. The smoke lay higher on the slat parts of the cube than on the edges and corners. If a spark was taken and on the conductor, the smoke was thrown into an agitation, but presently resumed its former situation. The cube with its atmosphere gave larger and longer sparks. Then a cube not surrounded with DUI, a larger spark might be taken from it by the spoon than by any other body. Avino insulated the spoon, he observed, that hardly any OYDF smoke went to the cube, and that what happened to go near it was not a feed by it, any more than it would have been by any other body. He put his finger to the FPOP bien, and the FW Ormer phenomena returned, taking it off again. Acted Quino Earl Fischal P7s. The smoke that had settled, the cube and II dispersed. Under this head of RFI Elioticity of various substances, it will not be improper to mention an experiment made by Mr. Henry Eales of Lifemore in Reeland, which he thought proved that steam and exhalations of all kinds are illyrical. The paper containing this account was read at the Royal Society April the 23rd, 1755. He electrified a piece of downy suspended on the middle of a long silk string, and made steam and smoke of several kinds passed he under it, and through it, and observed that its electricity was not in the least diminished, as he thought it would have been if the vapor had been non-electric, and consequently had taken away with it part of the electric matter with which the down was loaded. He observed that the SQ was the same, whether the down was electrified with glass or wax, which he thought was not easy to be accounted for. To this experiment, Dr. Darwin Field, in a letter addressed to the Royal Society and read May the 5th, 1757, and he feared that many electrified bodies, and particularly all light, dry animal and vegetable substances, will not carefully part with their electricity, though they be touched. For a considerable time with Condu and Orez, he touched Electricirmo Anicial, PYJ 74, a feathered 0 and RR, 25 a feather, electrified like that of Mr. Eales 9 times with his finger, and Ale found it dendrified. A cork beetle was touched 7 times in 10 fecons before it was exhausted. Mr. Kinnersels to Philadelphia, in a letter dated March Lacey, informs his friend and correspondent Dr. Franklin, then in England, that he could not electrify anything by means of OFEM from electrified boiling water, from whence he concluded that, contrary to what had been before supposed by himself and his friend, steam was so far from rising electrified that it left its flasher of common alidi behind Fe. To try the effects of electricity upon Arion, Mr. Kinnerfleet contrived an excellent instrument, which he calls an Uerkel air thermometer. It can fill of a glass tube about 11 inches long and 1 inch in diameter, made airtight, closed with brass caps at each end and a small tube open at both ends, let down clear of the upper plate into some water at the bottom of the wider tube. Within this VCFL he placed 2 wires, one descending from the brass cap at the upper end, and the other ascending from the brass cap at the lower end, through which he could discharge a jar, or transmit a spark and see, and at the meantime see the expelsion of the air in the vessel by the rise of the water in the F-Molly tube. With this instrument he made the FBL experiments related EO Akiti I-VI-4. Turno Dr. Franklin, dated March the 12th, 1761. He set the thermometer on an electric stand, with the chain fixed to the prime conductor, and kept it well electrified a considerable time. But this produced no considerable FFC, from whence he inferred that the electric fire, when in a state of rest, bade no more beat than the air and other matter wherein it resides. When the two wires within the vessel were in contact, a large charge of electricity from above 30 square feet of coated glass produced no rarefaction in the air, which I howed that the wires were not heated by the fire passing through them. When the wires were about 2 inches asunder, the charge of a 3-pint bottle darting from one to the other rarefied the air very evidently, which shewed that the electric fire produced heat in itself, as Mr. Kinnerly lays, as well as in the air by its rapid motion. The charge of a jar which contained about 5 gallons and a half, darting from wire to wire to wire, would cause a prodigious expansion in the energy, and the charge of his battery of 30 square feet of coated glass would raise the water in the small tube quite to the top. Upon the coalescing of the air, the column of water, by its gravity, instantly fubied, till it was in equilibrio with the rarefied air. It then gradually descended as the air cooled by and settled where it stood before. By carefully onisilo 257 efflui observing at what height the descending water first stopped, the degree of rarefaction, he says, might be discovered, which in great expiofians was very fiderable. It is obvious to remark that the fearful sudden rise of the water of Mr. Kinnerly's thermometer upon an explosion being made in the vessel which contained it is not to be of crib to the rarefaction of the air by heat, but to the quantity of air actually diffels by the LL fluoride, it is only when that first sudden rise is subsided, as Mr. Kinnerly himself observes, that the degree of its rarefaction by the heat can be estimated, viz. by the height at which the water then stands above the common level. Dr. Franklin had said that ice sailed to conduct a shock of electricity, and Mr. Bergman, in a letter to Mr. Wilson, read at the Royal Society, November the 20th, 1760, I house what Signor Beccaria had done before, that a small quantity of water sailed much as the ice had done with Dr. Franklin, who seems to have made use of an icicle, which Mr. Bergman thought was not large enough for the purpose. From hence he forfeit that large quantities of ice would traff mid a hawk of a liquidity as perfectly as a large quantity of water. However, he seems afterwards to have changed his sentiments with reference to ice, for in a subsequent paper, read at the Royal PWL, TRTNF volume, HPTUP Jot, Society, March the 18th, 1762. When he had remarked that snow would not conduce the clephytetric shock, he believes if he could procure plates of ice of a proper thickness, he could charge them in the same manner as glass. Johannes Franciscus Signa was to Sully persuaded of the non-dufting power of ice, that he made use it in an experiment to find to ascertain whether electric substances did, according to Dr. Franklin's hypothesis, contain more of the electric matter than other bodies. He enclosed a quantity of ice in a glass vessel, and when he thought he had converted it from an electric to a non-electric by melting, he tried whether it was electrified, but though he found no appearance of its having acquired any more of the fluid than it ought to have in its new state, he does not seem to have given up his opinion as that. In the law part of this work, the reader will find some experiments, which T.T. has imagined, will ascertain the class of bodies in which ice ought to be ranked, by proving its conducting power to be at nearly equal to that of water. F47, section 259. Chapter 19. Period X, section 3, Mr. Canton's experiments on surfaces. Canton's experiments and discoveries relating to the surfaces of electric bodies and others made in pursuance of them, or relating to the same subject, all tending to ascertain the distinction. B2 had been the two elect and ICDB till this last period of the history. The phantom electricity had always been produced by the same electric. The friction of glass had always produced a positive, and the fusion of feeling wax and C had always produced a negative electricity. These were thought to be essential and unchangeable properties of those substances, and hence the one was by many called the vitreous, and the other the ref mouse electricity, and to electrify negatively, that is, produce a refurious electricity by means of glass, or to electrify porphine, Tively, that is, produce a vitreous electricity by means of feeling wax and C, would have been thought as great a paradox as to electrify at all by the friction of brass or iron. For though it was not known why the electric matter should slow from the rubber to the excited glass, or to the rubber from elicited feeling wax, the sale had been invariable, and nothing is even mentioned to have happened. The Curie, and of any experas immensi, 26q Mr. Canton the Mentz, that could lead a PC font to fuffpeth the possibility of the contrary. What then must have been the Ferpenother of electric tales, to find that these different powers of glass and sulfur were so far from being invariable, that they were even interchangeable, and that the same glass tube could be made to assume the powers of both. What Moreau have been their phase fashion to find the circumstancy on which the convertibility of those apophycy powers depended, completely ascertained. This surprise and pleasure was given them by Mr. Canton, who had that it depended only on the rubber and the surface of the GAVFEs, whether it electrified positively or negatively. In what manner, by what train of thought, or by what accident he was led to this discovery, this excellent philosopher has not been plucked to inform us. But it is certainly a discovery which, in an eminent manner, distinguishes this period of my history. It throws great light upon the doctrine of positive and negative electricity, and led the way to offer discoveries which throw all more light upon it. This subject of the TVJO electricities seems to have engaged the attention of LA and Isidens in a more particular manner in the whole turf of this period, and ever since the discovery of Dr. Franklin, that the electricity of the two surfaces of charged glass are always contrary to one another. Accordingly, the reader will find several FCDIs in this period. D of two electricities, 261 of the history relating to it. But he will be helpful, though much has been done, much yet remains to be done, and that we are still far from thoroughly understanding the nature of the two electricities, with their dependence upon and relation to one another. Previous to the communication of the diff CQFRE itself, Mr. Canton observes that F. kaling wax might have positive electricity superinduit upon it. He excited a stick of feeling wax about 2.5 feet in length and 1 inch in diameter, and holding it by the middle, he drew an excited glass tube several times over one part of it without touch. The consequence was that half which had been exposed to the action of the excited GLLs was positive, and the other half negative, for the former half destroyed the repelling power of balls electrified by glass, while the other half increased it. The experiments which prove that the appearances of positive and negative electricity depend upon the surface of the electrochate and that of the rubber were made in the latter end of December 1753. Having rubbed a glass tube with piece of thin, heat-lean flour of emery mixed with water, till its transparency was entirely DCF-troyed, he excited it when it was made perfectly, clean and dry, with new flannel, and found it add in all refits tyke excited 3 JMP percent 6 MRF Canton. Oath K or F Kaling wax, the Alaric Ferreira, J feed to I zero from the knuckle, or end of the singer, and to spread itself on the surface of the tube in a very beautiful manner. If this rough or unpolyide tube was excited by a piece of dry oiled silk, especially when rubbed over with a little chalk or whitering, it would thrill and like a glass tube with its patural polchki. In this case, the E-Life Bic Fire Apia appeared only at the knuckle, or the end of the singer, where it seems to be very much caught and fed before it entered, Boti if the rough tube was greased all over with tallow from a candle. And as much as possible of it wiped with a napkin, then the oiled silk would receive a kind of pooch by rubbing it, and after a few strokes would make the tubia the same manner as Weki F excited at first by flannel. The oiled silk, when covered with chalk or whiting, would make the greased rough tube and I again like a polyflied one. But if the friction was continued till the rubber became finused, the electric power would be changed to that of sulfur, feeling wax, and C. Thus, says he, may the positive C in the GLTVA powers of electricity be produced at pleasure by altering the surfaces of the tube and rubber according as the one or the other is most affected by the friction between them. or if the poachy be taken off one half of a tube, TFB different powers may be excited with the same rubber at a single stroke. And he adds, the rubber is found to move much easier. Two electricities. 263 kHz over the rough than over the pohide part of it. That polyflied glass electrified positively, and rough glass rude with flannel negatively seemed plain from the appearance of the light between the knuckle, or end of the singer, and the refadive tubes. But this, Mr. Canton thought, was farther confirmed by observing that a polished glass tube, when excited by smooth oiled lilt, if the hand was kept 3 inches, at least from the top of the rubber, would, at every stroke, appear to throw out a great number of diverging pencils, electric fire J, but that none were ever seen to accompany the rubbing of sulfur, fiefing wax, and or was he ever able to make any sensible alteration in the air of a room merely by the friction of those bodies, whereas the glass UB, when excited so as to emit pencils, would in a few minutes electrify the air to such a degree that after the tube was carried away, a pair of balls about the size of the F peas turned out IOF cork, or the pith of elder, and hung to a wive by linear threads of 6 inches long, would repel each other to the distance of 1.5 inches, when held at arm's length in the middle of the room. Apt LTH experiments of Mr. Canton, Mr. Wilson made several, which throw a little more light upon this curious subject. But it ID difficult to draw any general conclusion. I think I was 264. Mr. Wilson fion from them, and his OP is not sufficient JI determinate. It is that two electrics being rubbed together, the body whose substance is hardest and electric power strongest, will always be plus, and the softest and weakest minus rubbing the tourmaline and amber together. He produced a plus electricity on both sides of the stone and a minus on the amber, but rubbing the tourmaline and dia mon together, both sides of the tourmaline were clarified minus, and the diamond plus. These experiments, which he thought proved this proposition, encouraged him to try what would be the effect of rubbing or coursing air against different electrics, and the CFFs were very considerable. In Tatey CFA experiments, he only met of C of a common pair of hellos, and his first experiment was upon the tourmaline. This Fuvtinchi brought near the end of the piche, and found that after it had received about 20 blayfuls, it was electrified pious on both sides. Air, therefore, seemed to be less electric than the tourmaline. Into the place of the tourmaline he brought a pan of glass, and blew against it the same number of times as in the former experiment. And when he had examined both sides, he found that they were electrified plus also, but less than the tourmaline. Amber, treated in the same manner, was electrified less than the glass. HBNJHVD0 glass on electrics. 265 HR next had recourse to AF Myth's bellows. The difference which these occasioned was only a much stronger electricity in the tourmaline. Amber was ill weaker than the glass, and the glass weaker than the Nolan, having in view the medium, which Thiel observed. He laid great stress upon as constituting the difference BFCT elegies and non-electrics. He considered that heat would rarefy it on the surfaces of the particles of air, by which means air, having its rarefactance laseroned, would more readily part with the electric fluid and of consequence electrify more powerfully. The pipe of the bellows being made red hot, he blew again off the tourmaline 12 times only, which was 8 times less than in the former experiment with cold air. In this experiment, the tourmaline was electrified pectinus on both sides, but to a considerable degree more than was done in the former experiments. The hot air had the same effect upon glass, but elarified it less than the tourmaline, and amber, though like the other bodies, it received an increase of power by the same treatment, was eel and ribed the least of all, from the air clarifying more powerfully when it was hot, then when it was cold, and the tourmaline being elarified more than glass, and glass more than amber, as appeared by the last experiments. We seem lays Mr. Wilson to have obuin a proof that the Oric plus or minus 66 Mr. Wilson. Oh, TXB asks, whole atmosphere is confidential proholding, a slow of the electric fluid by the alternate changes of heat and cold J and farther. Cad air is not only less caloric than the tourmaline, but less than glass or even amber. In another paper, re at the Royal Society, November the T3rd, 1760, Mr. Wilson recites Feemy curious experiments, which, he says, that a plus electricity may be produced by means of a minus electricity. Having electrified the inside of a large Leyden bottle, plus by means of a conducing wire from an excited glass globe. He fed it away a stand of prepared wood and took away the conducing wire. After which the mouth of the bottle was closed with a phiapple of glass. Then the pointed end of an ivory condifleur was brought opposite to the middle of the bottle and about 2 inches from it. Upon doing this, the balls were electrified minus, and the more so as the ivory was moved nearer the bottle in an horizontal direction. But on removing the ivory to a greater distance, the thickness electricity decreased, and at a certain distance there was not any sign of it remaining. But when the distance was decreased to about 18 inches from the bowl, a plus electricity appeared, which continued even after the ivory was removed. On TTT away with a cylinder of baked wood, he electrified the balls hanging to the ivory minus Ninix, PLT, NFF volt, 331 and EIA. The two electricities, 267. The diflance of 4 feet or more by holding the cylinder over the middle of the ivory, and continuing it there, and on moving it nearer, they were more strongly electrified minus and in, but the lame cylinder, on removing it back again to the distance of 2 or 3 feet, or snore else asserted the balls plus. When another conductic, or a metal conductics, or metal without edges or point, was used instead of the ivory, and without anything banging frunks it, the same cylinder held over the metal, as was done in the last experiment, or the ivory. At the distance of 2 feet and a fustens to pious electricity J, and this was rendered weaker Iowa, the cylinder was moved nearer. But by leveling the distance to about 1 foot, the clifticity took place. In these cases, Mr. Whitford thought that the plus appearance arose from the earth, air, or other neighboring bodies. When the preceding experiments were first made, he was a little embarrassed by the uncertain appearances of a plus electricity at one time and anomalous at another in the phamic pertinent, but by repeated trials and observations he found that a pious or minus electricity may be produced at Plefor by Cark and Lie attending to the 3 following circumferences, viz. The form of the bodies, their sudden or gradual removal, and the degrees of electrifying. Mr. Wilson, after this, proceeds to motion some other circumstances of a very nice nature, where the slighted and almost imperceptible UA68, Mr. Bergman owned TSB perceptible differences in the proflotion or in percent course of the effect adhesion of 2 bodies produce, in either of them, the FQS electricity at one time, and the minus at another. CCB, says he, are the effects of this subtle and active fluid, when the experiments are carefully made, and therefore they require the most scrupulous attention to trace out the causa which occasion them. Sealing wax and silver were the bodies used in the 2 farful experiments, but many other fubances seemed to perform as well. The feeling wax was clean and undefleured by any frisson whatever, but that of the air FB rounding it, and had been so for some hours. The silver was fixed to a piece of prepared wood, which was also preferred from frisson for the same length of time. Then, taking one of those flances in each hand, the silver being at the end of the wood the farthest from the hand, he laid the fenuthi part of the silver upon the feeling wax, and moved it along the furfacci gently, once only, and with a very slight proofer, after which the silver was electrified .pu and the wax minus. On repeating the experiment with equal care, and in the same manner, except that the smooth side of the silver was a little inclined, so that the edge of it profiled against the wax. The silver, after moving it as before, was electrified minus, and the wax ppux, contrary to what was observed in the Laffey experiment. These 2 electricities, 69, these appliquity cephalefla, occasioned by the different applications of the flatted part or edge of the silver, D and the D, to arise from an alteration made in the furfac of the wax. by destroying the polyfly in one case, and not in the other, J, and in this respect, RC femmeled the P blyflight and rough glass I mentioned before. Upon making use of prepared wood RNFT of wax, and employing different degrees of pressure in the friffion, with the same edge of the kniver, be produced the like appearances, the least pressure conga ux, and the greatest prefure, a minus appearance in the silver. A slat piece of flessel well poflied, and the edges rounded off, afforded the same appearances by only applying the slat surface to reed. But it required more pressing to produce the minus FE in this case than it did in the former, where the edge was concern fixed. Whether the reason offered above for explaining these last curious appearances be true or not, Mr. Wilson did not venture to affirm, for want of farther experiments, but thus much he thought might be safely advanced, that we have learned to produce at pleasure a plus or minus electricity from the same bodies, by attending to the manner of their application and friction. Mr. Bergman, in a letter to Mr. Wildean, read at the Royal Society, February the 23rd, Phil. Tram. Fall KPU. Piece 99 and C. Kai Miss Friedman on the 1764 gives an account of some curious experiments of his which, in conjunction in those Mr. Canton above mentioned, concerning surfaces, may throw considerable light upon the doctrine of positive and negative claricity. The experiments were made with 2 ribbons of silk, one of which was extended in a frame, while Mr. Bergman held the other in HB hand. He observed that if the 2 ribbons were the same with reference to texture, color, superficies, and in everything else, as far as could be judged, and if he drew the whole length of the ribbon which he held in 5% hand over one part at which was extended in the frame, that in his hand conveyed the positive electricity, and that in the frame a negative. If he drew one part of that which he held in his hand over the whole length of the other, the threads were RC verlulled. If the ribbon in his hand divided, for example, that, the event was the same. If the ribbon in his band was black, it was always negative, whichever way it was rubbed, except that in the frame was black too. In endeavoring to account for the end, he observes that the ribbon which was most rubbed was smoother and warmer than the other, and was of opinion that though smoothness did dispose bodies to be excited positively to electricity, 271 PCT-tively, yet that other circumstances were also to be taken into consideration, having found that when he held in his hand a ribbon which, by much friction, was made very smooth, and drew it over one part of another ribbon, which was rough and had never been used before, that the rough ribbon was nevertheless positive. From US experiment, he concluded that this effect was in some measure a will to the color, and in pursuing this thought farther, he was led to the following experiments. If the ribbon in his hand was well warmed, though it was drawn over one part of that in the frame, it became a left threes negatively, and that in the frame positively Ho made these experiments with the same success upon ribbons of silk of various colors, blue, green, red, white, and C. If the ribbon in the frame was black, it never controlled a positive electricity, though. That in his hand had been much heated, except this were black too. From these experiments, he thought he might safely conclude Theaga disposed some 5/10 at least TQ a negative state. And he thought that the want of attention to this circumstance might have occasioned mistakes in the event of some expia, especially those concerning Eiflod Kreifel. From the whole, he concludes that their gift assert, in fixed order with reference to EGIDC, and positive claricity, in which all bodies may be placed, while other circumstances, 27 Mr. Wilkes 6 and tight stances, remain the. Let A, B, C, D, be certain substances, each of which, when tubbed with one which is antecedent to it, is negative, but with a subsequent positive. In this case, the less distance there is between the bodies that are rubbed, the weaker cat par will be T the electricity, where C for ours, it will be stronger between A and E. Then it will be between A and B. He is disposes bodies to a negative electricity, but if the distance above mentioned be considerable, it may not be able to overcome, though it may weaken that electricity as is evident from the ribbon of black silk. When a glass globe grows warm and whirling, we are sensible that its electric power is diminished. Is it not owilga, says he, to this circumstance, that by heat it is more disposed to negative electricity, by which means the diflance above mentioned. CD between the glass and the rubber is Eichflint. Upon the subject of this section, I must introduce to the acquaintance or me reader two eminent Laotians, whose discoveries will give him the greatest satisfaction. I mean Mr. Wilsel and Mr. Pinus, the former of Rofiach in Lower Saxony, and the latter of PCT Arfel a circumambence which gives me an occasion of congratulating all the lovers of the sciences, and particularly of electricity, on the extensive spread of their flutties. What by joy would it have given Mr. Root TNFolium live P6? How could he, two electricities, 273 Hawksby, or Mr. Gray, to have foreseen that two such admirable treatises on the subject full of electricity, as those of the persons above mentioned, would come from countries so remote from the place of its rise? Mr. Wilker relates many curious experiments concerning the generation of what he called spontaneous electricity, produced by the liquefaction of electric substances, which, compared with those of Mr. Canton, throw great light upon the doctrine of positive and negative electricity. He melted sulfur in an earthen vessel, which he placed upon tondutors. Then, letting them cool, he took out the sulfur and found it strongly electrical, but it was not FQ when it had stood to cool upon electric substances. He melted sulfur in glass VC fells, whereby I both acquired a strong electricity in the circumstances above mentioned, whether they were placed upon electrics or not, but a stronger in the former case than in the latter. And they acquired a stronger virtue still, if the glass vetfel into which they were poured was coated with metal. In these cases, the glass was always positive and the sulfur negative. It was particularly remarkable that the sulfur acquired no electricity till it began to cool in contrast, and was the strongest when in the state of a greatest contradion, whereas the electricity of the glass was at the same time the weakful, and was the strongest of all when the sulfur was hacken T out a 74 Mr. Wilcott TFI out, before it began to contract and acquired any negatiolarity. Pursuing these experiments, he found that melted sealing wax poured into glass acquired a negative electricity, but poured into sulfur, it acquired a positive electricity, and less the sulfur negative. Sulfur poured into baked wood became negative. Sealing wax also poured into wood was negative, and the wood consequently positive, but sulfur poured into sulfur or into rough glass acquired no electricity at all. Experiments similar to these were made by Mr. Japinus. He poured melted sulfur into metal cups and observed that when the sulfur was cold, the cup and the sulfur together I had no signs of electricity, but he had very strong ugnia of it the moment they were separated. The electricity always appeared when the sulfur replaced in the cup and revived upon being taken out again. The cup had acquired a negative and the sulfur a positive electricity. But if the electricity of either of them had been taken off while they were separate, they would both, when united, have signs of that electricity which had not been taken off. This electricity, he observes, was only on the surface of the sulfur Fe. Mr. Wilke has likewise recited several curious experiments which he made on the phrygiation of various substances, which, like W-Jica PP4, ICF P9 Tentanin, P66, O wise two electricities, 275 wise throw considerably light on the same subjecta. Saddlefoot and glass rubbed together produced a electricity, positive in the glass and negative in the sulfur. Sulfur and feeling wick being rubbed together, the wax became pontire, and the sulfur negative. Wood rubbed with cloth was always negative. Wood rubbed against all smooth glass became negative, but against rough glass positive. Sulfur rubbed against metals was always perfidia, and this was the only case in which it was so. But being rubbed against lead, it became negative, and the metal positive, lead appearing thereby to be not so good a conductor as the other metals. After these experiments, Mr. Wilkie gives the following catalog of the principal substances with which electrical experiments are made. in the order in which they are disposed to acquire positive or negative electricity. Any of the substances becoming positively electrical when rubbed with any that follow it in the list, and negative when rubbed for with any that precede it. Smooth glass, white wax, woolen cloth, rough glass, inkwells, lead, wood, sulfur paper. Other annuals wax, Wilka, PSV and C, 2 out of 276, Mr. Wilka on ESB in all experiments. Made to determine the order of these five terraces, Mr. Wilka says that great care is necessary to distinguish the original electricity from that which is communicated, or the consequence of friction. Mr. Wilka says that smooth glass is all cases positive, and thence infers that it attracts the electric fluid, the leoful of all known substances. But Mr. Canton tells me he has found that dye as smooth as glass will acquire a negative electricity by being drawn with the back of a cat. Of the same nature with these experiments of Mr. Wilka are the follow-will of Pinus. He pressed close together two pieces of looking glass, each containing femma square inches, and observed that when they were separated and not suffered to communicate with any conduler, they each acquired a strong electricity, the one positive and the other negative. When they were put together again, the electricity of both disappeared, but not if either of them had been deprived, or their electricity when they were asunder. For in that case, the two when united had the electricity of the other. The same experiment, he says, may be made with glass and sulfur, or with any other electrics, or with any electric and a piece of metal F. Wilka, P69, T-IPOI, CNTN, J, section FLO, electricities, 277. Chapter 20, period X, section 4, Mr. Delaval's experiments to the two electric currents, and his controversy with Mr. Canton upon that subject, Mr. Canton, in the quiff of experiments related in the preceding section, clearly proved that the production of either of the two electricities depends entirely upon the surface of the excited electric with respect to the rubber, and showed that the very same glass tube would produce either of them at pleasure. Yet, notwithstanding this demon Freischurch, Mr. Delaval, several years afterwards, proposed another theory of the two deciphericities, which seems to be more ingenious than solid, as it goes upon the old fuppy fission of the different powers depending entirely upon the different fubflances themselves. The account of this theory was read at the Royal Society, March the 22d. It necessarily occasioned some controversy with Mr. Canton, in the course of which some new experiments were made, and some new fads discovered, on account of which I shall, with the utmost impartiality, report all that was advanced on both sides. Mr. de Claval observed that there are two of the pure chemical principles of bodies, vigilfer, which are each POFTI theft, AL 478 MFTI, Delaval Essentia Feffold, of a different kind of LA and icity, one of which we might call a plus elicity, the other a minutia in thought, that it ought be expelled, that in a body compounded of both, the opposite powers of those ingredients would counterbalance and destroy the escast of each other, and therefore that bodies in which the negative and positive powers were equal would be neutral or non-electrics. Such a substance he took metal to be Confiungoff calcinfulfur, metals not being calcinable without a degree of heat sufficient to dissipate all their ulfur, as is evident from their not being reducible again to their metallic form without the admixture of some unguous master. The same dissipation of sulfur, he says, must take place in animal and vegetable substances before they become white out. Transparent elones he considered as little more than pure earth, free from the lethal mixture of, judging of others, by the chemical revolution of crystal. To confirm this theory, Mr. Delaval made experiments with dry powders of calcined metals, viz. cerufs, leadaflies, minium calx of antimony and C, enclosing them in long glass tubes, and endeavoring to transmute the electric virtue through the PI, and always finding it impossible. Animal and vegetable substances, when reduced to ashes, were alike impermeable to electricity, as alio, the rust of metals, to electricities. 279, he was first led to these experiments, and to this hypertrophy, by finding that dry mold would not conduce to hydricity. This be also tried with dry portion F-tone, Va, of which he had cut into plates, nearly as theory as Wildo glass. These he heated to a proper degree and coated them centimeter both sides with metal in order to make the light in experiment. When the stone was hot enough to FOGPG puffer, it conducted as perfectly as when cold, but on cooling a little, it began not to conduct and afforded Immel shocks, which gradually gel increased in strength for about 10 minutes, at which time it was about its moil perfi state, and remained so near a quarter of an hour. After that time, the anox gradually decreased as the stone grew cooler, till at last they ceased, and the stone returned. Oh, its undudging state again, when at this state appeared before the AU was quite cold. Experiments of this kind succeeded with all bodies abounding with calx, or earth, as stones, earth, dry day, wood when rotten, or burned in the fire till the surface becomes tilac. Among other substances, he tried a common tobacco pipe, part of which, near the middle, he heated to a proper degree, and then apply one end of it to an electrical bar, while the other was held in the hand. And he observed that the elyric fluid passed no farther along the pipe than to that heated part. T4 from 20 AO map. Canton O. From these experiments, Mr. Delaval inferred that flones and other earthy substances were convertible by several methods, and particularly by different degrees of heat, from non-electrics to electrics. But finding afterwards that it was the opinion of some persons that Mr. Canton was the P.C.R. Fawn chiefly hinted at, that this change did not immediately, but only consequentially depend on heat by evaporating the moisture, which would return again when the substance cooled. Hopfers, in a paper read at the Royal Society, December the 17th, 1761, that the tobacco took its electricity before it was cold, and therefore before it could have imbibed moisture sufficient to destroy its electricity, and, besides, that the fuelants employed in the experiment was not of FD8 kind of bodies, which is apt suddenly to draw moisture from the air. To account for Mr. Delaval's experiments, Mr. Canton supposes, in a paper read to the Royal Society, February 4th, 1762, that stone tobacco pipe would say, will condude when cold by the moisture they contain that state, that when their moisture is evaporated by heat, they become non-condu and aura, and that when they are made very hot, the hot air at or near their surfaces will conduce, and the bodies will appear to be conductors again. Hot air, he says, may easily prove to be a conductor of electricity by bringing a red-hot iron poker, but for a moment within 3 or 4 inches of an Immel electric fit HOTAI or 281 fight body, when it would be perceived that its electric power would be off, if not entirely destroyed. And by bringing excited amber within an inch of the flame of a candle when it won't lose its electricity before it had acquired any sensible degree of heat. To confirm this, he mentions his having observed that the tourmaline brophile topaz and brawl emerald would give much stronger signs of electricity when cooling after they had been held about a minute within 2 inches of an almost surrounding fire, where the air is a conductor, than they ever will after heating them in boiling water. He adds that if both sides of those stones be equally heated, in a less degree than will make TLK surrounding air a conductor, the electricity off each side, whether plus or WW, would continue so all the time the flone was both heating and cooling, but would increase while it was heating and decrease while it was cool. Whereas, if the heat was sufficient to make the surrounding air convol the electric fluid from the positive side of the stone to the negative side of it while it was heating, the deuteriety of each side would increase while the stone was cooling and be contrary to what it was while the stone was heating. As to the tobacco pipe, Mr. Canton says that it not only aftercools the moisture of the air, but absorbs it. Hence, a tobacco pipe, after it begins to cool, will become a conductor again sooner than wood, and that it imbibes moistler faffler than wood, he says, is evident. Yeah, states Mr. Delaval, okay, evident. because when wetted, it will not continue wet so long as wood imbibing the moisture presently. That tobacco pipe does not become a conductor tie a particular degree of heat without evaporating its moisture is evident, he says, from the following experiments. If 3 or 4 inches of one end of a tobacco pipe of more than a foot in length be made red hot without fancifully heating the other end, this pipe will prove a ready conductor through the hot air surrounding one part of it, and the moisture contained in the other, although some part of it will have the degree of heat of a non-conductor. But if the whole pipe be made red hot and suffered to cool till it has only superficial moisture enough to make it a good conductor, and then 3 or 4 inches of one end be again made hot, it will become a non-rat conductor if a nail be placed at, or near each end of a longish solid piece of any of the absorbent bodies above mentioned, so as the point of each nail may be about half the thickness of the body within its surface. This body, by heat, may be made a non-conductor externally or superficially, while it remains a good conductor internally. For the alphalric fluid will readily pass from one nail to the other, through the middle of the body, when it will not pass of its surface. And even when the internal parts of the body are in an equal degree of heat with the external, as they must soon be after it begins to cool. But if the enmeis lancristat 183 same body be exposed for a short time to a greater degree of heat than bore, or if it be kept longer in the same heat, it will become a noacondylar injury. Mr. Delaval, in confirmation of particular bodies requiring particular degrees of heat, to render them electric or non-electric, independent of moisture, mentions effluents which he ionizes a feed by heat ia, an opposite manner to the former instances. Finally, the degrees of heat necessary to render the other substances electric makes this Noelis flirt de substance was Te-ion crystal, which is well known for its singular property of a double re-and action, on a piece of which be made the following operations. After this piece of trifle had been rubbed, when the heat of the air was moderate, it showed figos of electricity, though not very wrong ones. 2. If the heat was increased so as Txe be a little greater than that of the hand, it destroyed its electric power entirely. 3. By cooling the stone again, the electric power was restored. He immersed this piece of crystal into UAVFL filled with quecksilver and surrounded with ice, where it remained near 2 hours. When the weather was very cold, and observed that, upon taking it out with a pair of tongs, that it might not be altered by the heel 284 K Delaval on heat of his hands, and rubbing it again, it was more strongly electric than he had at any other time experienced, but that, on placing it a few minutes upon the hearth, at some half-tance from the fire, its electric property was again destroyed, for that rubbing would not occasion any signs of it. Thus, says he, we see 2 different kinds of tixed bodies, the one of which acquires endeary properly with the same heat with which another loses it, while a third fed of substances, as glass and sea, retain their electricity through both the degrees of heat necessary to the other 2. Some pieces of island crystal, which he had procured from different places, had not the property of losing their electricity by a moderate beat. He had, in particular, a piece of that crystal, one part of which, when greatly heated, became non-electric, while the other part, with the same heat, or even with a much greater one, remained perfectly electric. He found several other earthy substances, whose electricity was destroyed by different degrees of heat, from considering that the degree of heat at which the island crystal first mentioned was in its most perfect eleuteric state, was less than the usual heat of the air, and that a small in WCAPF that heat rendered it non-electric. He did not think it improbable that many substances which are not known to be electric, 285 tri might prove so if XXP fed to a greater degree of cold than they have been hitherto examined in. To these observations, Mr. Kenton replies, that having formerly observed that the friction between mercury and glass in vacuo would not only produce the light of electricity, as in the luminous barometer or within an evacuated glass ball, but would also electrify the glass on the outside. He emerged a piece of dry glass in a baffon of mercury and found that by taking it out, the mercury was electrified minus, and the glass A, to a considerable degree. He also found that amber, sealing wax, and ullin crystal, when taken out of mercury, were all electrified positively. How then, says he, does it appear that the electricity which was observed in rubbing the last mentioned Favteus, after it was taken out of mercury surrounded by ice, was a will to cold, and not to the frightfully in between it and the mercury in taking it out? Ullin crystal, when warm, is a non-conductor, and all non-conductors may be excited with proper rubbers. F. Max B. Erg Upful, in a letter to Mr. Wilson. Read at the Royal Society, April the 14th, 1761, says that he had tried the experiments of Mr. de Laval with ullin crystal, but that the event had always been very contrary to what 286 Mr. Canton OK, what Mr. de Laval had reported. Trying different pieces of crystal, he found one which, instead of having its virtue increased by cooling, was sensibly increased by heating. Afterwards, trying all the rest which he had by him, whether sweeterfly crystal or island, he found the FEQ to be the same. From this he inferred that the crystals which he had were of a quite different kind from that of Mr. de Laval. Chapter 21, Period X, Section 5. Bodies immersed in electric atmospheres, coveries relating to bodies immersed in electric atmospheres, with ESVV dispoberized, up other side made BV poursoint them. In this section I shall present my reader with the finest ferrex of experiments that the whole history of electricity can exhibit, and in which we shall see DEFEF played genii, to an address of four of the moa eminent electricianae in this whole period, viz. Mr. Canton, Dr. Franklin, and Gliffman, and Meffers, Wilke, and Iepinus foreigners. Mr. Canton had the honor to take the lead, and he made all the essential experiments. Dr. Franklin professedly pursued them, and though al hijrinth he put not yo on TBA this occasion, he diversified the experiments ninth made FB me improvement in, the Meffers accounting for them. But Meffers, Wilke, and Pinus and Cogenlan carried the experiments vastly farther, and Ceoan depleted the discovery, which is certainly one of the greatest that has been made since the time of Dr. Franklin. I fay the time of Dr. Frank, H.D., though he himself be one of the persons concerned, J., for by the time of Dr. Franklin White shall always be understood the time in which he made high capital discoveries in America. This will always be a difting Wi-Fi C pocha in the leaflory of electricity, from which all Bizone future discoveries will be dated. The original experiments in this section, when Mr. Canton first pupil-fed them, in his usual concise, though perspicuous manner, without any preamble to inform NS how he was led to them, exhibit such a variety of attractions and repulsions of electric bed by dyes in different circumstance, as looked like the power of man. And were they condifulged with a little art, I do not know any detrical experiments made without light or noise, more proper for a deception of this kind. But when they are attentively considered, they demonstrate a remarkable property of all electrified bodies, which has often been referred to in the course of this history, which had not been attended to before, nor indeed do I apprehend that it was solely understood, till it was explained in all its extent by Mr. Wilke and Pinus. It is 7-288 MCAG Canton, that the electric fluid, when there is a redundancy of it in any body, repels the electric fluid in any other body. When they are brought within the sphere of each other, it in zeroance, and drives it into the remote parts of the body, or quite but of it, if there be any outlet for it. In other words, bodies emerged in electric atmospheres always become puff left of the electricity, contrary to that of the BPD, in whose atmosphere they are emerged. This principle pursued led them to the method of charging a plate of air like a plate of glass, and to make the most perfect imitation of the phenomena of thunder and lightning. The paper, containing an account of Mr. Cantonite experiments, was read at the Royal Society, December the 6th, 175. Mr. Canton suspended cork balls, one pair by linen threads, and another pair by silk, then holding the excited tube at a considerable distance from the balls with the linen thread, and upon drawing it away they immediately came together. But he was obliged to bring the excited tube much nearer to the balls hanging by silk threads before they would separate. though when the tube was withdrawn, they continued separate for some time. As the balls in the former of THTSEF experiments were not insulated, Mr. Canton observes that they could not properly be laid to be electrified, but that when they hung within the atmosphere of the excited tube, they might might attract and condense the electric fluid round about them and be separated by the repulsion of its particles. He conjectured also that the balls at this time contained less than their common share of the electric fluid, on account of the repelling power of that which surrounded them, though some may be continually entering and passing through the threads. And if that be the case, he says, the reason is plain why the balls hung by Phil C in the second experiment must be in a much more dense part of the atmosphere of the tube before they will repel each other. He adds that at the approach of an excited slick of wax to the balls in the first experiment, the electric fire is supposed to come through the threads into the balls and to be condensed there in its passage towards the wax. According to Dr. Franklin, excited glass emits the electric fluid and excited wax receives it when two balls suspended by linen threads upon an insulated tin tube were electrified positively and had separated. He observed that the approach of the excited tube would make them come nearer together. If brought to a certain distance, they would touch, and if brought nearer, they would separate again. In the return of the tube, they would approach each other till they touched, and then repel as at first, if the tin tube was electrified by wax, or the wire of a charged file J, the balls would be affeated in the same manner. Tigio. Canton on at the approach of excited wax or the wire of the file. If the cork balls were electrified by glass, their repulsion would be increased at the approach of an excited slick of wax. And the FC would be the same if the excited glass was brought towards them when they had been electrified by wax. The bringing the excited glass to the end or edge of the tin tube in the former of these experiments is by Mr. Canton supposed to electrify it positively or to add to the electric fire it before contained, and therefore some will be sunning oif through the balls and they will repel each other. But at the approach of excited glass, which likewise emits the electric fluid, the discharge of it from the balls will be diminished, or part will be driven back by a force acting in a contrary direction, and they will come nearer together. If the tube be held at such a distance from the balls that the excess of the density of the fluid round about them above the common quantity in air be equal to the excess of the density of that within them above the common quantity contained in cork, their repulsion will be quite destroyed. But if the tube be brought nearer the fluid without being more dense than that within the balls, it will be attracted by them, and they will recede from each other again. Mr. Cantos farther observes that when the apparatus has lawful part of its natural store of this fluid, by the approach of excited wax to one end of it, or is electrified negative electric at 0 years, HDF, the electric fire is attracted and imbibed by the balls to supply the deficiency, and that more plentifully at the approach of XUS-sided glass or a body positively electrified than before, whence the distance between the balls will be increased, as the fluid surrounding them is augmented, and in general, whether by the approach or recess of any body, if the difference between the density of the internal and external fluid be increased or diminished, the repulsion of the balls will be increased or diminished accordingly. He observed that when the insulated tin tube was not electrified, if the excited glass was brought towards the middle of it, the balls hanging at the end would repel each other, and UA more so as the excited tube was brought nearer. When it had been held a few seconds at the distance of about 6 inches and withdrawn, the balls would approach each other till they touched, and separating again, as the tube was removed farther, would continue to vapor when the tube was taken quite away. This last repulsion would be increased by the approach of excited glass and diminished by that of excited wax, just as if the apparatus had been electrified by wax, after the manner described in the Laffy TFXBI. He insulated 2 tin tubes, which may be distinguished by calling them A and B, so AI to be in a line with each other and half an inch asunder, and at the remote end of each five-bended a pair of cork balls. Then, upon U2 bring 292, Mr. Canton bringing the excited glass tube towards the middle of A, and holding it a short time at the distance of a few inches, he observed each pair of balls to separate. Upon withdrawal of the tube, the balla of A would come together, and then repel each other again, but those of B would hardly be effeabled. By the approach of excited glass, the repulsion of the balls of A would be increased, and those of B diminished. In the former of these experiments, Mr. Canton supposes the common stock of electric matter in the tin tube to be attenuated about the middle and to be condensed at the ends by the repelling power of the atmosphere of the excited glass tube when held near it. And perhaps, he says, the tin tube may lose some of its natural quantity of the electric fluid before it receives any from the glass, as that fluid will more readily run off from the ends or edges of it than enter at the middle. And accordingly, when the glass tube is withdrawn and the fluid is again equally diffused through the apparatus, it is found to be electrocuted negatively. FMSC excited glass brought under the balls will increase their repulsion. In the latter of the experiments, Mr. Canton supposes that part of the fluid driven out of one tin tube enters the other, which is found to be orified positively by the decreasing of the repulsion of its balls at the approach of excited glass. It will readily be seen that at the time these experiments were made, Mr. Canton retained the common idea of electric atmospheres, whereas it will appear by the experiments of Meffers, Wilke, and Pinus, which in fact contain nothing more than those HEF Mr. Canton, that they tend to refute the common opinion and are much easier explained upon the supposition that the portion of fluid belonging to any electrified body is constantly held in contact or very nearly in contact with the body, but adds upon the electricity of other bodies at a certain distance, Dr. Franklin pursued. Or rather diversified the experiments of Mr. Canton, but retaining likewise the common opinion of electric atmospheres, he put that the phenomena were more easily explained upon the supposition that these atmospheres, being brought near each other, did not easily mix and unite into one atmosphere, but remained separate and repelled each other. And moreover, that an electric atmosphere would not only repel another electric atmosphere, but also the electric fluid contained in the fuvtano of a body approaching it, and, without joining or mixing with it, force it into the other parts of the body that contained it. Though it must be difficult to assign a reason why the particles of one atmosphere should repel the particles of another atmosphere, or of the fluid contained in another body with more force than they repel one another. Or the particles of the fluid contained in 94, Dr. Franklin. In the body to whiff they belong. Finks say the matter is the same in both. Yet this idea of the mutual repulsion of electric atmosphere could at once be supposed, will certainly and clearly account for all the fads, and though theory pia on account of its fimplicity, but the same appearances will be account for in planner as I impel and intelligible upon the supposition that vast portion of electric fluid belonging to each body, being strongly attracted by the body, is held in close jaw contact with it, but that it as by repulsion upon the electric fluid belonging to other bodies, at a distance from them, in that the electric fluid does gradually pass out of one body into another, till it have turf repelled the fluid put of the other body, and then be more strongly attracted by the other body than by its own, which has already got more theory, its natural hair. The paper containing an account of these experiments of Dr. Frank Cleary was read at the Royal Society, December the 8th, 17. His apparatus was different from that of Mr. Canton, but still he exhibited the same effects proceeding from the same cause. He fixed a tassel of 15 or 20 threads, each 3 inches long, at one end of his prime conductor, which was 5 feet long and 4 inches in diameter, supported by silk lines. The threads were a little damp, but not wet. In these circumstances, an excited tube brought near the end of the prime conduct oft opposite to he threads, so as, give it to some electric atmospheres. 295 Femi sparks made the threads diverge, each arid having thereby acquired its febrifull electric atmosphere. In this state, the approach of the excited tube without giving any sparks made the threads diverge more. But being withdrawn, they closed as much. The atmosphere of the conduit and or being driven by that of the tube into the threads, and returning again upon withdrawal of the tube, which had then left no part of its atmosphere behind it. The excited tube brought under the dividing threads made them close a tittle, having driven part of their atmospheres into the conduit. Upon being withdrawn, they diverged as much, that portion of thalar atmospheres which they had lost returning again from the conduit, and the tube having less due part of its own. The excited tube, held at the distance of 5 or 6 inches from the end of the conductor opposite to the threads, made them separate, and, upon being withdrawn, they came together again. But if, in their state of reparation, a spark was taken from the conduit near them, they would close, and, upon removing the tube, would separate. The tube in both cases left no part of its atmosphere behind it. It only drove the natural quantity of electricity contained in the conduit towards the threads, and part of that being taken away by the spark, the tube would leave the conduit and threads negative. In U4, which 296 Dr. Franklin, on which case they would repel one another, AI if they had been elysium positively. In this situation, if the excited tube was brought near the conductor, they would close again. The atrophier of the tube forcing that of the conductor into the threads to supply the place of what they had lost. But upon withdrawal of the tube, they would open again, the tube, as before, taking its whole atmosphere away with it. When the excited tube was brought under the threads diverging with negative electricity, they diverged more, the atmosphere of the tube driving away more of the atmospheres, cf. The threckles, and giving them none in its place. Lastly, the doctor brought the excited tube near the prime conduit when it was not electrified, and when the threads were thereby made to diverge, he brought his finger near them and observed that they receded from it. This appearance had been taken notice of by Mr. Hawksby and others. Dr. Franklin accounts for it by foopooing that when his finger was plunged into the atmosphere of the glass tube, part of its natural electricity was driven back through his hand and body so as to leave the singer negatively electrified, as well as the threads, in which case they must necessarily repel one another. To confirm this hypothesis, he held a slender lock of cotton, 2 or 3 inches long, near the prime conductor, electrified by excited glass, which made the cotton FDTTLF towards the conductor, and observed that in this state it would recede from the singer of his other hand, at the same time that it was attraced by a wire of a bottle charged positively. These experiments of Dr. Franklin, made in pursuance of those of Mr. Canton, were confirmed, as I observed before, and carried much farther by Meffers, Wilke, and Pinus. Mr. Wilke observes that a FM all-body emerged in any electric atmosphere if it be touched by no other body, and be withdrawn before it be repelled. Curie ever shows any sign of electricity. If any, it is of the same kind with that of the body into whose atmosphere it was plunged after. If any body, communicating with the ground, he brought to this light body, while it remains immersed in the atmosphere of the electrified body, it is fearful, attracted, and then repelled by it. If a point be presented to this light body and afterwards withdrawn, it will be found to have acquired an electricity opposite to that of the electrified body. From this, he concludes that parts of non-electric bodies plunged in electric atmospheres acquire an electricity opposite to that of the atmosphere, in which they are PMJ. He placed 2 large insulated conduits with their ends opposite to one another, and a cork ball suspended on silk between them, and observed that, upon the application of 298, Vienalake and Ipinus, the excited glass tube, to one end of either of them, the cork ball would play between them very sail, and if the tube were held a while at the same distance, would be at rest. Upon withdrawal of the tube, the motion of the cork ball began again, and at length ceased gradually as before. If the conduits were removed from one another, while they were within the atmosphere of the tube, they would, upon being brought together again, give a spark. This experiment confirmed the demonstration that the part of a body which is immersed in the atmosphere of an electrified body acquires the contrary electricity. But the most complete demonstration of this general maxim is an experiment of Mr. Priestley. He placed a small weight upon one end of a large metallic conductor, and, by means of a silk string, removed it from the conductor. While the end on which it rested was immersed in the atmosphere of an electric body, and found that it had actually acquired a different electricity from that of the atmosphere. If the end of the conduit and or opposite to that on which the movable weight was placed was made to communicate with the earth, all that part of it which was near the excited electric was affected with the opposite electricity. Placing the movable weight on the opposite end of the conductor when it was insulated, he found that it had few times V78 acquired electric atmospheres, Tg at Tc acquired an ELA and icity cutary to that of the excited electric, sometimes the same electricity, though weak, and sometimes no electricity at all. The same ingenious philosopher considered that the same principle must extend to glass and all other electrics, since they, as well as conductors, contain a certain quantity of the etheric fluid in their natural state. To verify this, he took a glass tube and electrified one end of it positively. The consequence was that 4 or 5 inches of that end were positive. But beyond that, there were 2 inches negative, and beyond that, the tube was again positive, though weakly so. This experiment he repeated very often with the same success, as also when, instead of glass, he used a solid stick of sulfur. To account for this fad, he supposed that the electricity communicated to the end of the tube repelled the natural quantity of the fluid in the glass to some distance. This natural quantity retiring from its former situation, he supposes to become condensed and consequently to repel another quantity of the fluid natural to the glass from its place, and that thus the whole rod would be alternately positive and negative. The author affords that it was from theory only that he was led to this curious experiment, the fatal exactly corresponding to what he bad before deduced, as a necessary consequence of Dr. Franklin's. Epius Newman, p. 129, Principles 30 Wilke and I. Penis on principles of negative and positive electricity. The hint of these experiments Mr. Irpinus received from those above mentioned of Mr. Will C.C. And these gentlemen, residing at the same time at Berlin, pursued these curious experiments jointly, till they were led by them to discover a method of charging a plate of air in the same manner as plates of glass had usually been charged, and to throw still more light upon the theory of the famous Leyden experiment. In the above-mentioned experiments, these gentlemen observed that the negative state of one of the bodies depended on the opposite state of the other, which was known to be exactly the case of the 2 sides of a charged pane of glass, and the reason of the non-communication of the same electricity was evidently the impermeability of the glass to the electric fluid in the one case, and the impermeability of the air in the other. Upon this hint they made several attempts to give the electric shock by means of air J, and at length succeeded by fupenging large boards of wood covered with tin, with the slat sides parallel to one another and at some inches asunder. Or they found that upon electrifying one of the boards positively, the other was always negative, agreeable to the former experiment. But the discovery was made complete and indisputable by a person's touch. Penitis Kuchinen, p. 192, and electric atmospheres, I-owing joint of the plates with one hand and bringing his other hand to the other plate. For he then received a fiac through his body, exactly like that of the Leyden experiment. With this plate of air, as we may call it, they made a variety of curious experiments. The 2 metal plates being in opposite elates strongly attrayed one another, and would have rushed together if they had not been kept asunder by strings. Sometimes the electricity of both would be discharged by a strong spark between them, as when a pane of glass bursts with too great a charge. A singer put between them promoted the discharge and felt the shock. If an eminence was made on either of the plates, the self-discharge would always be made through it, and a pointed body fixed upon either of them prevented their being charged at all. The state of these 2 plates, they excellently observe, justly represents the flail of the clouds and the earth during a thunderstorm, the clouds being always in one state and the earth in the opposite. while the body of air between them answers the same purpose as the small plate of air between the boards, or the plate of glass between the two metallic coatings in the Leyden experiment. The phenomenon of lightning is the bursting of the plate of air by a spontaneous discharge, which is always made through Mi weak P97, 302 Wilke, and Pinus Oenensis, and the bodies through which the discharge is made are violently oionic. This principle, they likewise thought, would explain an observation of the Abinolit, that electricity was often observed to be peculiarly strong when the room was full of company, and more particularly when numbers of them drew near together to see the experiments. The conjuror was then in one elate, and the company in another, so that, constituting a large surface, when any of them took a G part, as be thereby discharged the electricity of all the company, he would feel it more sensibly than the Thukid. This discovery of the method of guiding the electric shock by means of a plate of air may be reckoned one of the greatest discoteries in the science of electricity, finci, those of Dr. Franklin. It is beautiful to observe how this Sinai discovery took its rise from the experiments of Mr. Canton. Mr. Canton's experiments were pursued by Dr. Franklin, and those of Dr. Franklin pursued by these gentlemen produced the discovery. It is one and the same principle that, in different circumstances, accounts for this beautiful series of experiments. This experiment of charging a plate of air is likewise related by Mr. Pinus, who says that he was led to the discovery by RGDI. From these experiments, he was also led to form a more distant idea of the impermeability of glass to the electric fluid. For since a plate of air might be charged as well as a plate of glass, that property, whatever it be, must be common to them both, and could not, as Dr. Franklin once supposed, be anything peculiar to the internal ebure of glass, impermeability. He, therefore, infers, might be common to all electrics, and since they cause all receive electricity by communication to a certain degree, it more consists in the difficulty and slowness with which the electric fluid moves in their pores. In perfect conductors, it meets with no refin at all. It was chiefly this course of experiments also that led Mr. Pinus to deny the existence of electric atmospheres, confining of effluvia from electrified bodies. He seems, however, to consider this as a bold opinion. Hence he herein differs, as he says, from all the electricians who had written before him, and even from Dr. Franklin himself, though the common opinion, he says, is by no means countenanced by the general principles of this theory, which suppose the electric fluid to move with difficulty through every electric substance like the air. To those who might lay that an electric atmosphere is a thing obvious to the senses, P-Nitiotaicti, P93, and 304 Japinus's experiments, and no matter of theory. Since it may be felt like a spider's web upon the hands or face, he replies, that this feeling, together with the sulphurous smell of electrified bodies, are only sensations excited by the action of the fluid in the electrified bodies upon the electric fluid in the nostrils, or the hand, or upon those parts of the body themselves in an unelectrified state, and that they are not felt by a PCR phron who is not left of the same kind and degree of electricity. He therefore thinks there never was any sufficient reason to admit those atmospheres, and declares that whenever he uses the word, he means no more by it than I fear skiing of the electricity belonging to any body. Or he says, the neighboring air, which is elethriere, I by it, may be so called, but that these atmospheres have little efflelled in electrical experiments, he says, is evident first this circumstance, that if it be blown upon with a pair of bellows, the electricity of the body which it surrounds is not sensibly diminished. The electric fluid he supposes to reside wholly in the electrified body, and from thence to exert its attraction or repulsion to a certain distance. The subject of electric atmospheres had not escaped the attention of the accurate Signios Beccaria, who was probably prior to Mr. Pinuel in supposing that electrified bodies have no other atmosphere than the electricity commugtp miscms p 157 indicated Fellicurl TFC ATM des Piers 305 indicated to the neighboring air, and which goes with the air and not with the illusory such bodies, agreeable to that curious diphthery of his mentioned above. He also mentions an experiment which he thinks directly proves that all the electricity communicated to any body adheres to its surface and does not spread into the air. He electrified a large conductoff of gilt paper in which the gilding was, in vertical places, taken off quite round, and observed that whenever he discharged it, by taking a spark at the end, other sparks were visible at all the interruptions, the charge of the more remote parts having come off through the substance of the metal, and not along the air. As the greatest part of it Lethal might have done if it had lodged there, it is now also Mr. Cantonjay opiniori, that electric atmospheres are not made of effluvia from excited or electrified bodies, but that they are only an alteration of the state of the electric fluid contained in or belonging to the air surrounding them. To a certain distance, J, that excited glass, for instance, repels the electric fluid from it, and consequently beyond that difflans makes it more dense, whereas excited wax attracts the electric fluid existing in the air nearer to it, making it rare as before. This will be best understood by a figure. It PII, the figure, represent unexcited glass electricity inertia P54 LC306 Mr. Canton or wax. B excited glass and C excited wax. And let the dots on each side represent a line of particles of the electric fluid at their proper distance in a natural state. Let B and C be carried about where you will in the air. B will make an atmosphere equally dense, and C an atmosphere equally rare, while the quantity of the electric fluid each of them contains is the same as at first. When any part of a condular comes within the atmosphere of B, the electric fluid it naturally contains will be repelled by the dense atmosphere, and will recede from it. But if any part of a conductor be brought within the atmosphere of C, the electric fluid it naturally contains will be attrended by the rare atmosphere, and move towards it. And thus may the electric fluid contained in any body be condensed or rarefied. And if the body be a conductor, it may be condensed or rarefied in any part of it, and some may be easily drawn out of, or an additional quantity put into it. It was observed before that an experiment of Dr. Franklin, which he thought proves that electric atmospheres did not exclude the air, might justly make us FUFP the existence of those atmospheres, since the electric matter is known to repel the air. Another experiment of the same nature was made by Dr. Darwell of Lichfield, who sent an account of it to the Royal Society, which was read May the 5th, 1757. He got a glass tube open at one end and having a ball at the other. This ball and half of the tube he coated, and when he had inverted to electrical atmosphere, 507 averted it, and dipped a considerable part out it into a vessel containing oil of turpentine. HD introduced a wire into it and charged it, and observed, flight the oil did not at all appear to subside. From this he concluded that the electric atmosphere, slow round the wire and the coating the tubula above the OU, did not displace the air but existed in its pores. An experiment similar to that of Dr. Franklin and that of Dr. Darwell was made by C. Gia Beccaria. He took a coated file, and when he had inserted into it a small glass tube, bent horizontally when it came out of the file, he closed it with cement and presented light ashes to the extremity of the tube, the orifice of which was very side, and always found that the ashes were blown off when a spark was taken into the file, but they returned towards the end of the tube afterwards. It is probable that the metal not being sufficient in CP entail with the inside coating, a spark was made in the inside, which expelled the air and caused the motion in the ashes. The fairest method of trying it would be with a file in which the metal that received the fire from the conductor should be a produdiac of the inward coating. Sectal each 308, Mr. Simmer on the Chapter 22, Period X, Section 6, Mr. Simmer's experiments on the two electricities, SECTIRNIB. Mr. Simmer experiments relating to the two electricities and those made by Johannes Formascus Signa in pursuance of them. It had hitherto been universally supposed that all the phenomena of electricity were produced by the action of one electric fluid. Even Mr. Dufay, at the time that he imagined he had discovered another electric fluid, different from that of glass, and peculiar to Rosen and C. thought, however, that it was quite independent of the other and that their operations were never combined. Dr. Watson and Dr. Franklin thought it was very evident that the difference between the two elicities confined in the one being a redundancy and the other a deficiency of the same matter. And all the experiments that had been made concerning the two electricities seemed to confirm this hypothesis. At length, however, Mr. Cinnamer produces a great number of curious experiments relating to the same subject, and infers from them the probable existence of two elaborate not independent, but always co-existent and counteracting one another. The first set of his experiments are very remarkable, but he does little more than reQAFANS. They were diversified, and two pursued two electricities. 309 pursued much farther by Mr. Signa of Turin, who has also explained them upon the principles of Dr. Franklin's theory, though he was of opinion that no experiments that had yet been made were decisive, i.e. savor of either of the two hypotheses. Few histories of experiments are more entertaining than the first of these of Mr. Simmer. The frequent experiments are less satisfactory. The papers relating to them all were read to the Royal Society in the year 1759. This gentleman had for some time observed that upon putting Ophiel his stockings in an evening, they made a crackling or snapping noise, and that in the dark he could perceive them to emit sparks of fire. He had no doubt but that this proceeded from the principle of electricity, and after a great number of observations, to determine on what circumstances those strong electrical appearances depended, he found at length that it was the combination of white and black that produced the electricity, and that the appearances were the strongest when he wore a white and black silk flocking upon the same legs. These, however, discovered no sign of electricity while they were upon the fill. Trans. Volume HPTIP 140 plus the Abbé Nui. In repealing the appendamenti of Mr. Simmer, found it was not absolutely necessarger. DI1 of the Fitaking Diet 2 be black. For if one of them woo only I id a dicocaine of gall gnats, which doth not die to them black, but you only a preparative to it. In Ajair Gazerlachio, Mr. Simmer thought, the leg or hand, for he found that his hand was sufficient, though they were drawn backwards and forwards upon it several times, nor when taken from the hand, and prevent our ed to an illidrometer. Mr. Canton's balls, did they appear to have acquired any more than a very small degree of electricity, but the moment they were separated, they were found, both of them, to be highly elarified ed, the white positively, and the black negatively. Both the Aakings, when held at a distance from one another, appeared inflated to such a degree that when highly elarified, they exhibited the entire fiapy of the leg, and when two black or two white stockings were held together, they would repel one another so as to form an angle, seemingly GF 30 or 35 degrees. When a white and black flocking were presented to each other, they would be mutually attracted, and, if permitted, would earnfare together with fervent violence. Their approach, their inflation gradually subsided, and their attraction of foreign objects diminished, but their attraction of one another increased. When they absolutely met, they grew slat, and joined as close together as if they had been so many folds of silk. When they were separated, their electricity did not seem to have been in the least impaired by the feftiac of meeting, for they will be again inflated, attract, repel, and rui together as before. Whereby two electricities, 311 when these experimentias performed with two G-shot Hawkings in one hand, and two white ones in the other, it exhibited a curious vehicle. The repulsion of those of the IMA color and the atron of those of different colors threw them into an agitation which was not unentertaining, and made them catch each at the apple-light color at a greater distance than could have been expected. When the stockings were separated from one another, they would lose their power very soon, much like the excited tube, but while they were together, they would retain it an hour or two or longer if the air was favorable to electricity. The Farptal Malley point could not deprive them of it, and when they were one within the other, no means he could think of could procure the least perceivable discharge of the electricity. In this RCFPF, Mr. Simmer thought there was a considerable relief semblance between the black and the white flocking, when put within one another, and the light and file DL. What was still more remarkable in these experiments with the white and black stockings was the power of electrical cohesion which they exhibited. Mr. Simmer perceived that the white and black stockings, when electrified and allowed to come together, not only joined extremely close, but actually stuck to each other. By means of a balance, he found that in order to separate them, it required from 1 to 12 ounces. Another X4 time, 3 IMH. Simmer the time they raised 17 ounces, which were 20 times the weight of that flocking which supported them. And this in a direct tion parallel to its surface. When one of the feedstock jings was turned light out and put within the other, it required at 20 ounces to separate them though. Getting the black stockings new dyed in the white one lolhead and whitened in the fumes of sulfur, and then putting them one within the other with their rough fidka together, it required 3 pounds 3 ounces to separate them. And he had reason to think that the sulfur contributed nothing to the experiment. Trying this experiment with stockings of a more substantial make, he found the FedQ more considerable. When the white flocking was put within the black one, so that the outside of the white was contiguous to the infold of the black, they raised 9 pounds wanting a few ounces, which was 50 times the weight of the flocking. When the white flocking was turned in fewy out and put within the black one, so that their rough surfaces were contiguous, they raised 15 pounds 1 pennyweight and a half, which was 92 times the weight of the flocking. Having cut off the ends of the thread and the tufts of silk, which had been lest to the infancy of the stockings, the cohesion was felt durably diminished, preferring them to gather 2 electricities, AIG gather between his hands, contributed much to strengthen it on. When the white and black flocking were in cohesion and another pair, more highly electrified, were separated from one another, PND presented to the former. Their cohesion would be diphlobioed, and each flocking of the second pair would catch hold of, and carry away with it, that of its opposite color. If the degree of electricity of both pairs were equal, the cohesion of the former pair would be weakened, but not diphlobed, and all the 4 jubiobold cohere, forming one mast. If the second pair were but weakly electrified, the suahafian of the first pair would be but little impaired, and the cohesion of the whole mass would be small in proportion. Simmer also observed that white and black filth C, when electrified, not only cohered with each other, but would also adhere to bodies with broad and even with polyflied surfaces, though those bodies were not electrified. This he discovered accidentally, having, without the line, thrown a flocking out of his hand, which flucked to the paper hangings of the room. He repeated the experiment and found it would continue hanging pair an hour. Having flucked up the black and white stockings in this manner, he came with another pair of stockings highly electrified, and applying the white to the black and the black 314 Mr. Simmer on the black to the white. He carried them off from the wall, each of them hanging to that which had been brought to it. The same experiments held with the painted boards of the room, and likewise with the looking glass to the smooth surface, of which both the white and the black silk appeared to adhere more tenaciously than to either of the former. A few observations, similar to some of these of Mr. Simmer, were made by Signor Alessandro Amadeo Fadonio, a friend of Signor Beccaria. He put a beaver shirt between 2 others, which he wore in extreme cold weather, and whenever he put off the uppermost shirt, which he did every day, he found it adhered to the beaver flirt, and, away the reparation, electric sparks were visible between these. Whenever he put off the beaver flirt, it adhered still more to the undershirt, and when held at a considerable distance from it, would rush to it. These attractions would be repeated many times, but they grew more languid by degrees, till they entirely ceased. Signor Beccaria, upon hearing of this experiment, repeated it with some variation, and found it to answer on HAM-FELF. DF cohesion of the 2 stockings induced Mr. Simmer to try the force of electrical cohesion in electrified pans of glass. For this purpose, he got 2 panes of common Wildo glass, the thinnest APD, the smoothest that he could 2 electricities, 315 Zerum find F and coated one of the tides of each with tinfoil, leaving a space uncovered near the edges. He then put the uncovered tides together, and charging them both as one pane, he found, as he expected, that their cohesion was considerably strong, but he had apparatus to measure the strength of it. He then turned the plates upside down, and found that the same operation which had before charged them did now uncharge them according to the analogy of THC light and file. Placing two panes of glass, each of them J-coated on both sides, one upon the other, he found that they were both charged separately, and that there was no cohelium between them. In pursuance of these last mentioned explorers of Mr. Simmer, and another may at Pekin, which will be recited presently, Signor Basiria made the following, which are very curious, but which, after the example of the author, I shall relate without attempting an explanation. Having charged a coated plate of glass, he slipped the coating from off the negative lide, and applied another uncoated, uncharged plate of glass cloy to it. After this, putting a coating upon the uncharged glass, so that the whole re-enabled one coated plate, constituting of two lamina J, he formed a communication between the coatings. The consequence was an explosion and a cohesion of the plates. 36 MB, simmer on the if he separated the plates before the explosion. After they had been in Onjundin some time, the charged plate was positive on both sides and the uncharged plate negative on both sides. But if he separated them after the explosion, the charged plate was negative on both sides and the uncharged plate positive on both sides. If after the explosion he separated and joined them again alternately, a small circle of paper placed under the uncharged plate adhered to it upon every separation, and was thrown off again upon every confluence. This he could repeat even 500 times with once charging the plate. This was the experiment that he says was made by some Jesuits at Pevsen in the year 1755, and being sent to the Academy of Sciences at Petersburg, was published in their memoirs. All 276. If, in these experiments, the charged plate was inverted, and the positive side applied to the uncharged plate, all the FCA were exactly the reverse of the former. If it was inverted ever so often, after remaining some time in central with the uncharged glass, it would produce a change in the electricity. In the dark, a light was always seen upon the separation of these plates, laying the two plates together. Like one plate encoding the outsides of them, he charged them both together, and at the distance of about 4 feet, he distinguished 6 of the colored rings, which Newton describes in his Book of Optics. All parallel to PNC, another Alcott IC2 electricities, 217 OCTI, as did nearly parallel to the edge of the coating. At the angles of the coatings, that ring spread to a greater distance. Where the coatings did not quite touch the glass, the rings bent inwards, and where the coatings adhered very close, they retired farther from them. Upon discharging these two plates, the colored rings vanillhead and the each recohesion, which Mr. Simmer had observed this case, caved with them. Upon separating these plates before hit exploften, that which had received the positive electricity was positive on both sides, and the other negative on both sides. If they were separated after the explosion, each of them, as in the former experiment, was affected in a manner just the reverse of this. Upon inverting these plates, that which was the thinner appeared to be portelted of the stronger electricity, and, like the charged plate in the former experiment, brought the other to correspond to it. Charging the two plates separately, and taking off two of the coatings so as to place the two positive or the two negative sides together, there was no cohesion or explosion. But joining a positive and a negative side, they cohered, and a communication being formed zero the outside, there was an explosion which increased the cohesion, making the above-mentioned experiment. With these plates, he says, they ailed just as the two that were charged at the same time. Mr. 138, Mr. Simmer, on IHMJTS Simmer, concludes his account of TKCFC experiment with declaring it be his opinion, that there are two electric fluidaba, or emanations of two different lyric powersi, essentially different from each other. that electricity does not consist in the abux and efflux of that fluids, but in the accumulation of the one or the other of them in bodies electrified. Or in other words, it consists in the paphon of a larger portion of one or the other power. Then is requisite to maintain an even balance within the body. And lastly that, according as the one or the other power prevails, the body is electrified in the one or the other man. Nor will this principle, says he, of two different electrical powers be found upon due confederation to disagree with the general system of nature. It is one of the fundamental laws of nature that action and reaction are inseparable and equal. And when we look round, we find that every power of each is exerted in the material world meets with a counteracting power, which controls and regulates its effects, so as to answer the wise purposes of providence. Mr. Simmer also alleges, in proof of his two different powers of electricity, the experiment which Dr. Franklin has related, of piercing a quadrille of paper with an electric hook. He thought that the burr which Wapea raised on both sides of the paper was produced by two fluids, moving in two different directions, and on Joglet, two electricities, 319 tians. To eye how the manner in which this stroke was made more evidently, he mentions two other similar experiments in which the circumstances of the eroke were a little varied. A piece of paper, covered on one side with Dutch gilding and which had been left accidentally between two leaves, in a quire of paper in which the former experiment had been made, was found to have the imperfection of two strokes upon it, about a quarter of an inch from each other, the gilding being dripped and the paper less bare for a little space in both places. In the CNTR RRFR, one of these places was a little round hole, in the other only an indenture or imperfection, such as might have been made with the point of a bodkin. These observations Mr. Simmer communicated to Dr. Franklin, who, notwithstanding, Mr. Simmer was endeavoring to establish a theory of electricity contrary to his own, with the generosity natural to him, afflicted him with his apparatus in making another experiment in pursuance of that mentioned above. J.N., the middle of a paper book, of the thickness of a quire, Mr. Simmer put a slip of tinfoil, and I.O. another of the same thick seed nafs. He put two slips of the same sort of soil, including the two middle leaves of the book between them. Upon striking the two different books, the fields were answerable ta what he xbst. Jane the first, the leaves on each 320 Mr. Simmer, on the each side of the soil, were pierced, while 6 soil itself remained unperked. But at the same time, he could perceive an imperfio had been made on each of its surfaces at a little distance from one another. And such impressions were still more visible on the paper, and might be traced as pointing different ways. In the second, all the leaves of the book were pierced, excepting the 2 that were between the slips of soil, and in these 2, in fled of holes, the 2 imperflians in contrary directions were visible. Mr. Simmer afterwards got an L9 Rickle apparatus of his own, formed on the model of that of Dr. Franklin, with which he frequently repeated the experiments above mentioned, the result of all which he comprises in the Tiet follow-up observations. A quire of paper, without anything between the leaves, is pierced with a ferric of electricity. The 2 different powers keep in the same track, and make but one hole in their passage through the paper, not but that the power from above or that from below sometimes darts into the paper at 2 pi more different points, making so many holes, which, however, generally unite so they go through the paper. They seem to pass each other about the middle of the quire, for there the edges are most vertically bent different ways, whereas in the leaves near the octite, the holes very often carry more the appearance of the passage of a power if fringe out, and exploding 2 electricities, 321 plotting into the air, then BF1 darting into the paper, 21 when already thin tereitalic substance, such as gilt liaz or tinfoil, is put between the leaves of the quire, and the whole is fucked. In that ease, the counteragent power is deviate from its direct track, and leaving the path which they would in common have taken through the paper, only make their way in different lines to the metallic body, and strike it in 2 different points, die flank from one another, about 1/4 of an inch, more or less. The distance appearing to be the leal when the power is greatest, and whether they pierce it or only make imperforia upon it. In either case, they leave evident marks of 2 different parts, and in 2 contrary directions. It is this deviation from a common curl, and the febrillion of the lines of Dursich's chin consequent upon it, I.e., that affords a proof of the exertion of 2 different and counteracing powers. When 2 slips of tinfoil are put into the middle of the quire, including 2 or more leaves between them, if the electricity be moderately strong, the counteracting powers only strike against the slips and leave their emphion there. When it is eftifonger, one of the slips is generally pierced, but seldom both. And from what he had observed in such cases, he says it should ium, as if the power which effluated from the outside of the file aided more strongly than that which proceeded from within, for the lower slip was mafcom, wymony 3 tooth simmer, on the monly pierced. But this, he add, may be owilled to the greater space which the power from within has to move through before it eftrica the paper. In the same paper, Mr. Simmer furnifly a remarkable instance of the power of an hypothesis in drawilk fads to itself in making proofs out of fads, which are very ambiguous AOD in making a person overlook those circumstances in an experiment, which are unfavorable to his views. When a file is electrified but a little, Mr. Simmerfees, if we touch the coating of it with a singer of one hand, and, at the same time, bring a singer of the other hand to the wire, we shall receive a pretty finer blow upon the tip of each of the singers, the fiofacion of which reaches no farther. If the field be electrified a degree higher, we shall feel a stronger blow, reaching to the wrists, but no farther. When, again, it is tetrified to a still higher degree, a severer blow will be recited, but will not be felt beyond the elbows. Lastly, when the file is strongly charged, the stroke may be perceived in the rifles and elbows, but the principal shock is felt in the breast, as if a blow from each side met there. This plain and simple experiment, says Mr. Simmer, aims obviously to suggest to observation the existence of different powers, aiding in contrary directions, J, and I believe, says he, it would be held as a S fafadia, N on Jaj Vechiji Joglet 2 electricities. 323. Sufficient proof by any person who should try the experiment, who have viewed to determine the question furply from his own perceptions. It is a sufficient answer to this remark of Mr. Simmerfier that if 20 people join Hanzua, they may all be made to feel the hock in their wrists or their elbows without having their beteefs affettled in the least. And can it be supposed that the 2 currents of electric fire could come at all their wrists or elbows without passing through their briefles? If, according to Mr. Simmer's hypothesis, it would seem that in a large circle, those persons only who stood near the fire on either hand should feel a small jock, that a few persons more at each extremity of the circle should feel one something stronger, and that it could only be a very strong shock, which could at all feel the person who stood in the middle, and that then he should be affected the least of any person in the company. But all these consequences are contrary to fact. This hypothesis of Mr. Simmer notwithstanding, he assailed in his application of it to the experiments above mentioned, has attracted the notice of several electricians, both at home and abroad, and some persons seem inclined to adopt it in preference to Dr. Franklin's theory. I shall therefore consider it more at large when I come to treat only theories, Y2 profeffled. 324 JAF Signa, on the profeffedly, till which timchi I take leave of this ingenious philosopher, and biz 2 electric fluids. The experiments of Amar Simmer excited the attention of Amar Signa, and led him to Ecrifor experiments, which throw still more light, both upon the doctrine of the 2 electricities and the Leyden file. They are also a farther illustration of the discovery of Mr. Canton, improved by Mefters, Wilke, and Opiens of the mutual repellency of similar electric atmospheres. He took 2 white silk ribbons, just dried at the tire, and having extended them upon a smooth plane, either a conductor or a non-conductor, he drew over them the harp edge of an ivory ruler, and found that both the ribbons had acquired electricity enough to adhere to the plane, though while they remained upon the plane, they showed no other sign of it. If they were both taken off from the plane together, they attracted one another, the upper having acquired the rhythmus and more powerful, and the lower the vitreous and weaker electricity. If they were taken up separately, they repelled one another, having both acquired the reionous electricity. In this separation of both the ribbons from the plane, as also in their separation afterwards from one another, electric sparks were visible between them, J, but if they were memoirs of the Academy at Tarii for the year 1716-51, PJ Agaya, 2 electricities. 325 again put upon the plane or joined together. No sight appeared upon their second reparation, without another fruition of the ruler. Also, when by being taken off separately, they had been made to repel one another. If they were laid on the plane again and taken off together, they would not attract. And if by being taken off together, they had first been made to attract one another, and were laid on the plane a second time, and then taken off separately, they would not repel without another fruition, when by the operation above mentioned, they had acquired the same electricity if they were placed, not upon the ephempoth body on which they had been rubbed, but on a rough one, and a conductor, as hemp or cotton, not very dry, they would, upon being separated, how contrary electricities, which, when they were joined together, would disappear as before. If they had been made to repel one another, and were afterwards placed one upon the other on the rough surface above mentioned, they would in a few minutes attract one ambullier, the lower of the 2 ribbons, having changed its resonance into a vitreous electricity. If the 2 white ribbons received their Friedlian upon the rough surface, they always acquired contrary electricities. The upper of the 2 having the resonance, and the lower memoirs of the Academy at Tianjin for the year P33, Y3, the N, J. Gerard, 326, J.F. Signa, on TFB. The titrius, in whatever manner they were taken off, the same thing that was done by a rough surface was done by any pointed conductor. If 2 ribbons for tiftants were made to repel and hang parallel to one another, and the point of a needle were drawn opposite to one of them along its whole length, they would presently roughly together, the electricity of that ribbon to which the needle was presented, being changed into the contrary. In the same manner in which one of the ribbons changed its electricity, a ribbon not else electrified would acquire electricity visda, by putting it upon a rough surface and laying an electrified ribbon upon it, or by holding it parallel to an electrified ribbon and presenting a pointed conductor to it. He placed a ribbon not quite dry under another that was well dried at the fire upon a smooth plane, and when Fourier had given them the usual Fricklian with his ruler, he found that in what manner forever they were removed CD from the plane. The upper of them had acquired the rhythmus, and the lower the vitreous electricity F. If both the ribbons were black, all the ABP mentioned experiments succeeded in the same manner as if they had been white. J. Memoir of TBE Academy at Turin for the year 1765, if in J and in case of up to 3 electricities, 4 electricities. But if he made use of a stick of sulfur, the dialectics were, in all cases, the reverse of what they've reared before. The ribbon which was rubbed having always acquired the vitricity electricity. When he made use of paper, either gilt or not gilt, the results were uncertain. When the ribbons were wrapped in paper, gilt or not gilt, and the friaua was made upon the paper, laid upon the plane, above mentioned, the ribbons acquired, both of them, the relenous electricity. If the ribbons were one black and the other white, whichever of them was laid uppermost, and in whatever manner the friction was made, the black generally acquired the rhythmus, and the white the vitreous electricity, he observed. However, the follow-up constant event, that whenever the textura of the upper piece of the kilk was loose, yielding, and retiform, like that of a flocking, so that it could move, and be rubbed against the lower yaw, and the rubber was of such a nature as to impart but little electricity to glass. The electricity which the upper piece of ilk acquired did not depend upon the rubber, but upon the body it was laid upon, in which case the black was always resinous, and the white Visi minori of the Acciamgitoria Fof the Dreer 1761 P36 TI 38.43. Signa aptiat B treos, but when the silk was of a close texture, hard and rigid, and when the rubber was such as imparted a great degree of electricity to glass, the electricity of the upper piece did not depend upon the lower, but upon the rubber. Thus a white silk fiefdoxine, rubbed with gilt paper upon glass, became arsi finis, and the glass vitreous J. But if a piece of silk of a firmer texture was laid upon a plate of glass, it always acquired the vitreous electricity, and the glass, the resinous, if it was rubbed with sulfur J, and for the most part, if it was rubbed with gilt paper, so that the silk that was rubbed received its electricity sometimes from the rubber, and sometimes from the substance placed under it, according as it received greater friction from the one or the other, or in proportion as one or the other was more proper to give electricity to glass. And Othker fed of experiments, which the same Mr. Signa made, illustrate the adhesion of Mr. Simmer's electrical stockings to bodies with smooth surfaces. He infuriated a plate of lead, and bringing an alarified ribbon near it, observed that it was atrafled very feebly. Bringing his singer to the lead, a spark iltude out of it, upon which it attracted the ribbon Jägerofly, and both together hewed no signs of electricity. Upon the separation of the ribbon, they again both ap memoin of the Academy at Turin, for the Dreer Ejig plus 0 peered two electricities. 229 peered to be electrified, and a spark was perceived between the plate and the singer. Laying two plates of glass upon a smooth conduor communicating with the groundy, and rubbing them in the same manner as the ribbons had been rubbed, they two quife acquired electricity, and adhered firmly both to one another and to the ondutter. If it were a plate of lead, not very thick, it would be supported by the attraction. When they were together, they showed no other signs of electricity. When the two plates of glass were separated from the conductor and kept together, they had on both sides a vitreous electricity, and the conductor, if it had been insulated, was seen to have contracted a raffinuia's electricity. The two plates of glass themselves, when F's Priestley were possessed of the two electricities, the upper of the vitreous and stronger, and the lower of the rectinous and weaker, with a rough conductor, whether they were originally rubbed upon it, or brought to it after they had been rubbed upon a smooth one, they scarce contravled any electricity, though when they were separated from one another, they were effeated as before. Upon this principle, Mr. Signa endeavors to account for the non-excitation of a globe memoyu of the Academy at Turin. FCR, the Jager 1765 P43, TIWD PSJ 230JF. Signa on the or two from which the air is exhausted or which is lined with conducing fugences. In this case, he says, the vitreous elicity on the external surface of the glass is balanced by the resinous in the inward coating, or in the vacuum which serves instead of a coating, and therefore it is in the situation of the plates of glass while they lie upon the conductor above mentioned. But when the inward coating is taken away, the electricity appears on the outside, without any fresh excitation, as when the plates were removed from the conductor. When he laid a number of ribbons of the same color upon the smooth conduor, and drew his ruler over them, he found that when he took them up ingly, they all gave sparks at the place where they were separated, as the Lale ribbon did with the smooth plate, and had all acquired the resinous electricity II. If they were all taken from the plate together, they cohered in one mass, which on both sides appeared to be resinous. If they were laid upon the rough conductor, in the same order, whereby the opposite electricities were brought to an equilibrium, and they were all separated cugdi, beginning with the lo-fi, sparks appeared as before. But all the ribbons had acquired the vitricity, except the uppermost, which retained memoirs of the Academies at Turin for the year 176, the two electricities. 331, TB Rignua, electrically bad received from the Frioa. If they received the Freon upon the rough conduor, and were all taken up at once, in order to have a hundle in which the two people fight electricities were balanced, all the intermediate ribbons acquired the electricity. Either the highest or the lowest ribbon, according as the reparation was begun with the highest or the lowest. If two ribbons were separate from the bundle at the same time, they clung together, and in that state, he had no sign of electricity, and one of them alone would have done, when they were separated and the different electricities were manifest. The electricity was observed to reside in the outermost, and was opposite to that by which they had both adhered to the bundle, but much weaker if he placed a number of ribbons upon a plate of metal, which received electricity from the globe, while he held a pointed body to the other side of the ribbons. The consequence was that all the ribbons became puffed of the electricity opposite to that of the plate, or of the same, according as they were taken ophi, except the most remote, which always kept an electricity opposite to that of the plate. From these experiments he infers that as electricity is propagated from the outermost McMinn of the Academy at Turin, for TK year 1761 P61, signa O, the ribbon to those underneath it, or elec from the plate, below to those next above, iua, when they are separate. So likewise, when the coating is separated from a charged pane of glass, it likewise deposits its electricity upon the superficies of the glass, the phenomena being the same in both. For when he put metal coatings on the side of a plate of glass without any cement, they adhered firmly to the glass when it was charged, and a light appeared upon their being separated from it, as in the case of the ribbons. When he coated a number of ribbons in the same manner and charged them, the O-80s adhered firmly to the ribbons, but he could never separate one of them. But, in consequence of the loose texture of the silk, a spark would go to the opposite coating, which immediately fell off, the whole being then discharged F, but he thought the coatings did not deepify all their electricity on the plate. When they were taken off, for though when both were taken off, the electricities of the two sides still balanced one another, because each retained the same diminutive quantities, yet, when one superficies of the glass, or of the ribbons, received its electricity from Friedeon, and the other only from the opposite coating, he observed that the electricity which balanced one another while the coating was on, were no longer balanced when it was taken off. Memoir of the NM7 at Ton Q, for the G176, P6JTT, and PS6040NJ, JR. The electricity of the surface which was rubbed then prevailing, because the conducing coating had upon its reparation taken part of its electricity along with it. To confirm this, he adds another experiment. He charged a pane of cataphes, coated on one side, while the other received electricity by a pointed conduit from the machine. He likewise inverted the plate and made the coated side communicate with the pre-conduit, while a painted piece of metal was presented to the opposite side, and in both cases found that while the coating remained, the two electricities balanced one another, but that when the coating was slipped off, the electricity of the opposite side prevailed, IBS to be apparent, on both sides of the plate. Memoir CFIDC Academy, St. Turin, for the UIZ section. Chapter 23. Period X, Section 7. The history of the Leyden file continued great, as were the discoveries of Dr. Franklin concerning the Leyden file. He left made curious particulars for this period of the Healy electricity. And the subjectus is by no means exhausted. Many of the properties of this wonderful bottle, as the Doeffler calls it, are still unexplained. But as more and more light is perpetually thrown upon it, let us hope that, at length, we shall thoroughly understand this great experiment. The greatest discovery concerning the properties of the Leyden file in this period hath already been related in the account of melters. Wilke's and Pinwake's method of giving the shock by means of a plate of air, and other observations have likewise been occasionally mentioned in places where their connection required them to be inserted. This Fettflian, however, will contain several experiments of a miscellaneous nature which are well worth notice. Immediately upon the discovery of the Fliofc given by glass, all electricians attempted to charge other electric substances, but none of them succeeded before Signor Beccaria. He found that a very smooth plate of sealing wax made by pouring that substance, when melted upon an oiled marble table, would receive a considerable charge. After trying several other electrics in the same manner, He found that a mixture of pitch and colifornia was charged less than sealing wax, but more than sulfur, and a great deal more than pitch alone. Theft. But the most curious experiment of this Philip Faber relating to this subjective pivot was made with a view to ascertain the real direction of the electric six-swid in a discharge. He signed a coated plate of glass by a silk thread and Havgin charged it, and kept it perfectly still. He observed that no motion was given to it when the discharge was made by a crooked wire approaching both the sides at the same time. The experiment, in fact, proved the R6 reason of the glass upon the electric matter, whereby the plate were kept still, notwithstanding the fluid roughed with great violence from one side to the other. He compares the glass to an ivory ball placed between two oathes, which keeps its place when, by an NT impulse given to one of them, the opposite ball flies off. Mr. Hartmann of Hanover has published an account of curious experiment, which seems to how the progressive motion of the electrical sea explosion. He passes a shock through a great number of cannonballs, sometimes to the number of 40, placed near one another upon small drinking glassels, when all the each are seen at the same moment of time, and all the snappings make but one report. But when he substitutes eggs in out of the balls of metal, the progress d of the explosion is visible c, every two giving a snap and a fall separately. This experiment requires weather very favorable to electricity, and he says has generally succeeded the best with only 10 or 12 eggs. This author has not expressly said in which direction the sparks land, but as he adopts Dr. Franklin's hypothesis, it may presume that he imagined them to go from the positive to the negative side of the charged glass. A very ingenious experiment has also been made by Mr. Amadeus Lullin of Geneva in order to ascertain the direction of the electric fluid in explosions, and which methinks comes nearer to the experiment of Pruitt's than any other. He placed a common card in the circuit of the LA and equal explosion, while the wire which communicated with the positive side of the jar lay on one side of it, and that which communicated with the negative side lay on the other, their extremities not being placed opposite to one another, but at some distance. Things being thus circumstanced, he observed that upon making the discharge, the card was constantly pierced to the extremity of the wire, which communicated with the negative side of the jar. Ableon P, S, and C, as if the electric fluid rushing from the positive side of the jar into the wire which communicated with Igua, and I flowing from the extremity of it, was driven by its own impulse along the surface of the card, and did not pierce it, till it came opposite to the extremity of the other wire, which communicated with the negative side, by which it was strongly attracted. A very curious and elegant experiment on the Leyden file was made by Professor Richmond of Edinburgh, whose unfortunate death will be related in this history. He coated both sides of a pane of glass within 2 or 3 inches of the edge, and fastened linen threads to the upper part of the coating on both sides, which, when the plate was not charged, hung down in contact with the coating. But setting the ply upright and charging it, he observed that when neither of the faillas was touched by one is or any other conductor communicating with the earth, both the threads were repelled from the coating and fell at an equal distance from it. But when he brought Big Finger or any other conductor to one of the sides, the thread hanging to that ID cell nearer to the coating, while the thread on the opposite side receded as much, and that when his finger was brought into contact with one of the sides, the thread on that side fell into contact with it like with while TAQ oritatio filica P14. The thread on the opposite side receded to twice the distance at which it hung originally, so that the two threads always hung so as to make the same angle with one another. Pinus shows that it is not frightfully true that an insulated person discharging the Leyden file through his own body contrails no electricity, electrifying a large plate of air, H, and observed that if the nearer plate, by which I suppose he means that which he first touched, was electrified perpetually, he acquired a positive electricity by the discharge. But if it were negative, he acquired a negative electricity. He supposes that the reason why the experiment did not succeed with Dr. Franklin was that the surfaces with which he tried the experiment were not large enough to make the fettle sensible, and that the distance of the metal plates was, likewise, too small, as it necessarily must be in charging of glass. Mr. Signa has invented a new method of charging a file, upon the principle discovered by Mr. Cannon and Mr. Wilke, viz., that the electricity of one body repels that of another, especially if it have a slat surface, and gives it the contrary electricity. He insulates a smooth plate of lead, zincide, while he brings an electrified body as a flocking to it. He takes a farce with the wire of a file from the opposite side, and removing the flocking, he uses an upper spark with penetrated diamond P335. Its singer or any cadoodler communicating with the grant. Bringing the flocking nearer the plate a second time, he takes a second farce with the wire of the file as before, and femovaling it again takes another, in the same manner with his singer. This operation AT continues till the file is charged, which in favorable weather may be done with very little diminution of the density of the flocking. If, instead of taking a second spark with his singer, he had taken it with the wire of another file, that would have been charged likewise with no additional labor and with an electricity depopate to that of the other J-hile. If the second spark were taken with the coating of the same file, the charging would be accelerated, but the operation would be troublesome to manage. The theory of this new method of charging a file is very easy upon the principle referred to above. The approach of the electricity in the flocking, not being able to enter the broad smooth surface of the metal, drives the electric fluid out of that part of the plate which is opposite to it to the other side, which, being thereby overcharged, will part with its superfluity to the wire of the file. The flocking being taken away, the plate will have less than its natural share of the electric fluid, and will therefore readily take memory of the Academy at Tahi for the year 1765, P9. Z2, a spark, 346. The history of a spark either from the singer or the wire of another file. The same ingenious philosopher makes a considerable difference between the electric fluid which gives the shock, and that on which some other phenomena of coated glass depend. The former, which is far the greatest quantity, he supposes to reside either in the coating itself or on the surface of the glass, whereas the other he imagines to have entered the pores and defeated the substance of the glass itself. He laid 2 plates of glass, well dried one upon the other as one piece, the lower of them being coated on the outside, and when they were insulated, he alternately rubbed the uppermost plate with one hand, and took a spark from the coating of the lower with the other till they were charged, when the coating and both the plates adhered firmly together, giving a coating to the other side and making a communication between that and the other coating. The usual explosion was made, but the plates, though thus discharged, elucohered. And though, while they were in this state, they showed no other sign of electricity, yet when they were separated, they were each of them found to be possessed of an electricity opposite to that of the other. If the 2 plates were separated before, they were discharged. In the coating of memoirs of the Ayedeti at Tutla for die year ICV 65, each were touched, a spark came from each, and when put together, they would cohere as before, but were incapacitated for giving a shock. He therefore compares the ulcericity, which gives the shock to the electricity of the metal plate in the former experiment, which is lawful with taking 1 spark, as the silk is removed from it, and is different from the electricity by which the 2 plates of glass cohere. The one is dispersed at once, but the other slowly, the one existing, as he supposes, in the conductors or upon the surfaces of the electrics, and the other in the substance it felt. Among experiments relating to the electric EGHOC, we ought to mention what has been observed within this period of its Amazon-Mouston force in melting wires, and producing other surprising effects, that even artificial electricity, says Dr. Watson. In a paper read at the Royal Society, June 60th, 1764, when in too great a quantity and hurried on too fact, through a seen iron wire, has a remarkable effect upon the weary, appears from a very curious experiment of Mr. Kinnerfleet. This gentleman, in the presence of Dr. Franklin, made a large case of bottles, explode at once through a seen iron wire. The wire at first appeared red, light, and then fell into drops, which burned Memoir of the Academy at Turin for the year 1765. PST ibid P6Z 7 of fuse into the surface of its table or floor. These drops cooled in a Faraday figure like very small shot, of which Dr. Franklin transmitted some to Mr. Canton, who repeated the experiment. This proves the fusion to have been very complete, as nothing less than the most pure fluidity could give this figure in melted iron. Mr. Canton, in a note subscribed to the same paper, observes that the diameter of a piece of Mr. Kinnerflee's wire, which he received from Dr. Franklin, was 1 part in 182 of an inch. He adds that artificial lightning from a case of 35 bottles would entirely destroy brass wire of 1 part in 30 of an inch. At the time of theft throws, he says a great number of sparks, like those from a flitted and steel, would fly upwards and laterally from the place where the wire was laid and lose their light in the daytime at the distance of about 2 or 3 inches. After the explosion, a mark appeared on the table. The whole length of the wire and some very round particles of brass were discovered by a magnifier near the mark, but no part of the wire itself could be found. Sigmund Beccaria was able to melt small slips of metal without enclosing or covering them with pieces of glass. But he thought that the same color was impressed upon glass by all the metals, and imagined that this circumstance was a trace of the fundamental principles being the same in them all. Mr. Dalibard observed that when a large pane of glass discharged itself, the polish was taken off at the place of the dischargia, and that the track it left behind it was usually, as he expresses it, in the zigzag form. With the piece of glass with which he made these discharges, he pierced 160 leaves of paper. It contained 1,200 square inches. Mr. Wilke says that if a small piece of metal be yijung in a small silken siring, appuye to a part of a dust jar made thin for the purpose, upon the spontaneous discharge through DI place, the piece of metal will be driven off to the distance of 5 or 6 inches. Mr. Winter sired the seeds of club moths, Lycopodium, by discharging a file through a quantity of them. He also sired the aurum fulminani placed upon a piece of parchment, which was torn to pieces by the explosive section. By the electric shock, Sigmund Beccaria could melt borax and glass, but the most remarkable of his experiments with the electric shock are those by which he revived all D metals. This he did by making the explosion between 2 pieces of the calces. In this manner, he electricissimo artificiis XGP 134 EJX remarks on Franklin's LLCTTRTP 100 and several of the metals. And among others, zinc. He even produced real quicksilver from cinnabar. In this case of revivification, he always observed fleeks of black beyond the colored metallic stains, a woog, as he imagined, to the flagelton driven thither from the parts that were vitrified. When the other part revivified, the cal SF. Another curious experiment he made with the Elsa's fetiac by discharging it through some brass dust, sprinkled between 2 plates of feeling wax. The whole was perfectly luminous and transparent. An experiment which throws some light upon one of Mr. Hawksby's 8 dot. With the electric shock, he also made that capital experiment, on which he lays so much stress in his theory of thunderstorms, and by which he proves that the electric matter forces into its passage all light-conducting substances by means of which it is enabled to pass through a quantity of resisting medium which it could not otherwise do. He put a narrow piece of Lee's silver between 2 plates of wax, laying it across the plates, but so as not quite to reach one of the sides, the discharge being made through this strip of metal by bringing a wire opposite to the silver at the place where it was discontinued. The silver was found melted, and part of it dispersed all along the track that the electric matter took. Between the plate lecture del elatiricumo PSTF, it bid PZ of wax from the silver to the wire. An accident gave him occasion to observe another fact of an amolar nature. He once inadvertently received the charge of a small jar. Through some smoke of spirit of nitre, when a hole was made in his thumb, where the fire entered, and which he thought could only have been made by the nitre which was carried along with the electric fluid violently, as the electric explosion generally affects the human body, We have accounts of some persons who could not be made to feel it, particularly 3 or 4 mentioned by Mr. Muffchenbreck, among whom was a young woman. I have also been told that this was the case with a person near Leeds who was at the same time a little paralytic. I shall close the history of the Leyden file for this period with the accounts of some extremely curious fads, which Mr. Canton gives me leave to publish relating to this subject. They certainly deserve the utmost attention of philosophers, and may probably throw some light upon the electricity of the tourmaline. He procured some thin glass balls of about 1.5 inches in diameter, with stems or tubes of 8 or 9 inches in length, and electrified them, some positively on the inside, and others negatively after the manner of charging the Leyden file. I Math Tie Review of Flober 77, Cezanne, hash 346, the history essay, and then sealed them hermetically. Soon after, he applied the naked balls to his electrometer and could not discover the least sign of their being electrical, but holding them to the fire, at the distance of 5 or 6 inches, they became just strongly electrical in a very short time, and more so when they were cooling. These balls would, every time they were heated, give the electric fire to or take it from other bodies, according to the state of it within them. Heating them frequently, he found, would sensibly diminish their power, but keeping one of them under water a week did not appear in the least to impair it. That which he kept under water was charged the 22 of September, 1760. Was several times heated before it was kept in water, and had bang heated freer quickly afterwards, and yet it still retained its virtue to a CPN federal degree on the 31 neft of a sober follow-wheel, when he sent an account of it to Dr. Franklin. The breaking 2 of his balls accidentally gave him an opportunity of measuring their thickness, which he found to be between 5 and 8 parts in 1,000 of an inch. The balls mentioned in the account above, which was written 6 years ago, still retain their virtue, but in a less degree. Mr. Lullen also found that a glass tube charged and hermetically sealed would show signs of electricity when it was heated F in 1769. T. Dilterurio Pfeiffica, P3 at SAO 347. 347. Chapter 24. Period X, Section 8, Experiments and Observations concerning electric light experiments and observations concerning electric light. My reader has been informed of the necessity I was under of dividing the Busonias of this period of my HGFtery into several parts. He has already seen titles which he could not have expected from the divisions of the preceding periods. But he would perhaps least of all expert a Difton Fedlian upon electric light, and yet the experiments and PB Fervations Urich have been Medell immediately relating to this subject, are so many that they deserve a place by themselves. And I would rather err by making too many subdivisions than too few, because above all things I would wife like to preserve perspicuity, which is chiefly injured by crowding together things dissimilar. Many experiments have been made very early, by Mr. Hawksby and others on electricity and particularly electric light in vacuo. But so little was at that time known of the nature of electricity in general that comparatively little use could be made of those experiments. Very fortunately, Dr. Watson happened to turn his thoughts that way after the great discovery of the accumulation of electricity in the Leyden file, and by this means he discovered that our atmosphere, when 348, Dr. Watson, on when dry, is the agent by which, with the assistance of other electric S perfect, we were enabled to accumulate electricity upon non-electrics. He might have added electrics too. That is, to communicate to them a greater quantity of electricity than those bodies natural phi have. That, upon the removal of the air, the electric fluid pervaded the vacuum to a considerable distance and manifested its effects upon any non-euleric substances by which it was terminated. This he demonstrated by one of the beautiful experiments which the whole compass of electricity yet exhibits. He exhausted a glass cylinder 3 feet in length and 3 inches in diameter, with a contrivance to let down a brass plate as far as he pleased into it, in order to make it approach another plate fixed near the bottom of the vessel. This cylinder thus prepared, he investigated and observed that when the upper plate was electrified, the electric matter would pass from one plate to another at the greatest distance to which the brass plates could be drawn. and that the brass plate at the bottom of the cylinder was strongly electrified as if a wire had connected it with the prime conductor. It was a most delightful spectacle, he says, when the room was darkened, to see the electric matter in its passage through this vacuum, to observe, not as in the open air, small, bruised or pencils of rays, an inch or two in length, but coruscations of the whole length F81 electric light, 349 of the tube, and of a bright silver-hued up. FC did not immediately diverge, as in the open air, but frequently from a base apparently slat, divided themselves into less and less ramifications, and resembled very much the eye-puffed, lively coruscations of the aurora borealis. Sometimes he observed that when the tube had been exhausted in the most perfect manner, the electric fluid was seen to pass between the brass plates in one continued ilium of the same dimensions throughout its whole length, which he thought demonstrated that the cause of that very powerful mutual repulsion of the particles of electric fire, which is seen in the open air, is Maccaidi owilled to the resistance of the air, than to any natural tendency of the electricity itself. For in the open air we observe that these bruits, when the electricity is strong, diverge so much as to form almost a spherical figure. He made this vacuum part of a circuit necessary to make the discharge of a file, and at the instant of the explosion there was seen a mass of very bright embodied fire, jumping from one of the brass plates in the tube to the other. But this did not take place. When one of the plates was farther distant from the other than 10 inches, if the distance was greater, the fire began to diverge and lose part of its force, and this force diminished in proportion to its divergency, 7 which 350 Dr. Watson, on which he draws nearly as the distance of the two plates. To find a more perfect vacuum for the passage of the electric fluid, he had recurred to an excellent invention of Lord Charles Cavendish, who, by means of a long bent tube of glass filled with mercury, and inverted, made all the bended part of it, which was above the mercury, the most perfect vacuum that can be made. This vacuum Dr. Watson insulated, and one of the buffons of the mercury being made to communicate with the conduit. When female non-electric substance touched the other, the electric matter pervaded the vacuum in a continued arch of lambent flame, and as far as the eye could follow it without the least divergency, connecting one of the buffons with the inachine, which was insulated, the 6 rai was seen pervading the vacuum in a contrary direction. And this he considered as the experimentum crucis of 2 principles which he had advanced before, viz., that electricity is furnified to the conductory not by the excited electric, but from the non-electrics in contact with the rubber, and that we are able to take from or add to that quantity of electricity which is naturally inherent in bodies. He also observed that if, in the aforementioned circumstances, the hand of a person landing upon the floor was brought near the side of the glass, the coruscations would dart themselves that way in a great variety of forms. Extremely curious to behold. But electric light, 351, but the door found that even this vacuum did not conduct so perfectly as metals or water, because a person standing upon the floor and applying his finger to teology upper brass plate received a smart stroke. This he conceived to arise from the electricity of the brass being so much more rarefied than that of the body of the man who applied his finger. Mr. Wilson engaged Mr. Smeaton, the inventor of a new and more perfect kind of air pump, to make FBME electrical experiments in vacua. The following is the account of them that he transmitted to Mr. Wilson. They are, in several respects, similar to those made by Dr. Watson, and yet are attended with a considerable variety of new circumstances. And 8 inches in its greatest diameter, open at both ends, had one of its ends closed by a brass ferrule, which constituted one of the centers on which it turned. The other end was closed with a metal plate. In the center of this plate was a square FLM, which was applied to the arbor of a lath by which the glass was turned round. On one side of this lathal plate was fixed a cork, by means of which the glass was screwed upon the air pump. Upon rarefying the air within the glass about 500 times, and afterwards turning the glass in on YGVQD Glass 352, Mr. Smeaton O glass in the lath, while full at the same time, it was nipped with his hand. A considerable quantity of lambent flame, variated with all the colors of the rainbow, appeared within the glass under the hand. This light was pretty steady in every respect, except that every part of it was perpetually changing color. When a little air was let into the glass, the light appeared more vivid, and in a greater quantity, but was not so steady, for it would frequently break out into a kind of coruscations, like lightning, and fly all about within the glass. When a little more air was let in, the flashing was continual, and streams of bluified light seemed to effulge from under his hands, with eke the glass in 1,000 forms, with great rapidity, and appeared like a cascade of fire. Sometimes it seemed to fly out into the forms of trees, moss, and sea. When more air was let in, the quantity of light was diminished, and the streams composing the flafties narrowed. The glass now required a greater velocity and harder friction. These circumstances increased as more air was let in, so that by such time as the glass was 1/3 full of air, these coruscations quite vanished, and a much smaller quantity of light appeared partly within and partly without the glass. And when all the air was let in, the light appeared wholly without the glass, and much less in quantity than when the glass was in part exhausted. Wuran sifli epi tn jan etchergochigal. Electric light, 353 MK. Canton, in repeating Dr. Watson, experiment with the Torricellian vacuum, observed one circumstance attending it, which throws great light upon the Leyden phial. He observed that when the excited tube was brought near one of the buffons of this machine, insulated, a light was seen through more than half of the vacuum, which soon vanified if the tube was not brought nearer, but which appeared again as it moved farther off, and that this appearance might be repeated several times without exciting the tube afresh. This experiment he considered as a kind of ocular demonstration of the truth of Dr. Franklin's hypothesis, that when the electric fluid was condensed on one side of the glass, it was repelled from the other if it met with no resistance. Thus, at the approach of the excited tube, he supposed the fire to be repelled from the inside of the glass, surrounding the vacuum, and to be carried off through the columns of mercury, but to return again as the tube was withdrawn. This curious experiment Mr. Canton, as he informed me, showed and explained to Mr. Wilson, who afterwards expatiated upon it in a book published by him and Dr. Hodley in conjunction, entitled Observations p. 95, that this observation of the return of the electric light in vacui was noide before the discovery of the Leyden phial by Mr. Nimmerk of Biala. In Poland, I bet, Ehef was all known, both to Dr. Watfoa and Mr. Canton. 354 Mr. Wilson. On a series of ubrical experiments, note of which, P28, he says, Mr. Canton has taken notice of this vanifulging and returning of the HDT. Mr. Canton has since diversified this beautiful experiment by bringing the excited tube to another glass tube, exhausted and hermetically sealed, by which means he exhibits the perfect appearance of an aurora borealis. The flame from one of its extremities, which is in a manner coated by the hand which holds it, will dart to the other extremity at uncertain intervals of time, for near a quarter of an hour together, without repeating the application of the excited tube, when it was generally agreed among electricians that what had been called vitreous and resinous electricity were in reality a redundancy of the electric fluid in one case and a deficiency in the other, and when, in consequence of this supposition, the one was called positive and the other negative electricity, there still remained some doubt which of the two was positive and which negative. Mr. Wilson, in a paper read at the Royal Society, December the 6th, 1759, recites an experiment which, he thought, put the matter beyond all dispute and absolutely determined that what had been called vitreous was really positive and what had been called resinous was negative J, as indeed had generally been supposed, though. As Mr. Wilson thought, without fuflicient reason, notwithstanding what had been advanced by Dr. Franklin, electric light, 35 Franklin, and Mr. Canton upon that tube she had, repeating the beautiful experiment mentioned before, as first contrived by Lord Charles Caverdil, He says he attended to a circumstance which seemed to have been overlooked by Dr. Watson, who publicad the account of it. This was a FN Gala appearance of light upon one of the surfaces of the quicksilver, to observe TBJ's remarkable appearance to more advantage. Mr. Wilson let a small quantity of air into the tube, by which means 4 columns of quicksilver were obtained, and coefficiently 6 visible furfisa in one of the fegs of the inverted tuhil. He then electrophysics the mercury in the other leg, while the M.A. Kufi on the Ojibwaphite side had K communication with the earth, when, the Rooney being dark, the stream of electric light was visible through the whole length of the technol, and its general appearance was of ephemerid uniform density, J, except at the VP parfuffuses of each column, where about 1/10 of an inch above the surface, the light was always considerably bright, whereas the underfufuses exhibited no such appearance, the light being rather less bright in those places than in the general appearance of the whole illuminated vacuum. This luminous appearance Mr. Wilson ascribed to the resistance the fluid met with at the upper surface of the quicksilver in endeavoring to get into it. He therefore inferred that excited glass electrified bodies positively. 356 Mr. Wilson are fittively or gave them a greater quantity of the electric fluid than they had, electrifying in the same place with a cylinder of rollon instead of glass. The luminous appearances were all on the under surfaces of the columns of quicksilver, from which he inferred that rosin electrified bodies negatively, depriving them of part of the electric fluid which they naturally had, or as he extrapolated it, occasioning a current of electric fluid to fet the contrary way. These luminous appearances Mr. Wilson also considered as a strong confirmation of the exifluence of a medium at or near the surfaces of bodies, which hindered the entrance 6 or exit of the electric fluid, a doctrine which Mr. Wilson had advanced and laid great stress upon on several other occasions, the arguments which to Mr. Wilson appeared conclusive, in proof of what is commonly supposed, that glass electrifies plus in sulfur, and C- did not appear so to Mr. Iapinus, though he acknowledges that the knobs of light in the vacuum did, in common with many other appearances, prove a real difference between the two electricals, and thought that it was very easy to conceive that when an electric fluid issues from a body, it should be denser nearer the surface from whence it effulges, then where it finds more liberty to expand itself. He might have added that this might have been expected from the electric light. 357, the mutual attraction which is supposed to subsist between the electric fluid and other bodies, but Pinus did not expressly mention this circumstance. Mr. Wilson, therefore, makes light of the observation and adds that when he related the experiment with the bent tube in his letter to Dr. Heberden, he omitted some phenorphena attending the faflor, which greatly savored the doctrine he advanced. If, says he, when glass is electrified and applied to the first column, we suffer the electric fluid to pass along the tube in small quantities only, and at short intervals, little luminous stream will be seen to move from the first to the second column of quicksilver, and consequently from the glass. The like appearances happen, but in a contrary direction, when rosin or amber is made use of and applied to the same column. Glass, therefore, he concludes, electrifies plus 6 uracils bodies with more of this fluid than belongs to them naturally, and rosin and C-. This controversy took its rise in some measure from a deception. For Mr. Canton informs me, and gives me leave to inform the public, that the light which Mr. Wilson takes notice of as appearing on one surface of the mercury in the double barometer of Lord Charles Cavendish, and which Mr. Wilson takes to be a proof of the existence of a medium on the surface of bodies, which hinders the entrance or exit of the electric fluid to a sum 358, Mr. Wilk, some degree, be found to be caused by nothing but common air, for if the Torricellian vacuum be properly made, no difference of light can be seen on the surfaces of the columns of mercury J. But if as much air be let into the vacuum, as will make each column of mercury 1/4 of an inch shorter than that of a good barometer, the light will appear as Mr. Wilson has described it. When Mr. Wilson supposed that Dr. Watson, when he made the experiment of the Torricellian vacuum, did not attend to the singular appearance of light on one of the surfaces of the Mercury. He udfafeted that if the vacuum Dr. Watson made was free from air, there was no such singular appearance of light to be attended to. Air, Mr. Canton adds, must be condensed near the surface of all bodies that attract it, and will therefore be some hindrance to the exit or entrance of the electric fluid, except the bodies be very sharply pointed. Some curious observations relating to electri-light were made by Mr. Wilke. Rubbing two pieces of glass together in the dark, he obfered a vivid phosphoril light, which, however, threw out no rays, but adhered to the place where it was excited. It was attended with a strong phosphorial smell, but with no attraction or repulsion. From this experiment, he inferred, Schadt friction alone would not excite electricity so as to be accumulated upon any body, and that to produce thuisk and tetatides rubbed together must a tetric light. 359 must be of different natures, with refsal to their attracting the electric fluid. He, moreover, imagined that all examples of phosphoril light without attraction were owed to the same excitation of elephal, ricity without the accumulation of it. Such he imagined to be the case of light emitted by the Bolognian, alone cadmia fornicum, rotten wood, pounded sugar, and glass of all kinds. A tube excited with a woolen cloth, on which white wax-on oil had been put, he says, threw out flames, each of which, when examined, appeared to rise out of a little protuberance of fire. The flame was one and very narrow at the bottom, but farther from the tube it divided into several ramifications, which always leaned to cleof parts of the FBD, which were the least excite, or to confurlors in the neighborhood. Fe says that apoe prelenting a linger or other nofitherigieric to an excited negative electric. Upon QF light is formed, the base of which is at the singer or other non-refluric, and the pex at the alaric, on the surface of which it F-preds to a considerable distance all round J. Sometimes the HESF send fiery particles thrown laterally FOQM, an irregular Elst-Dietrich spark, which Fiona like FLRs, odd were very like those which are produced by the Kuifian PF flint. Suspend 360 TVLB, Wilke on suspending various balls from Wisconductor, and PRC fending others to them, which were omitons of glass and fontamia of metal, and varying them in every manner possible. He always found, except when two metal balls were used, that the light between them formed a cone, the base of which was always on the body which was positive, and the apex on that which was negative. He says that this criterion is sufficient to distinguish the two electricities from one another. He observes that at the apex of a cone issuing from pointed bodies, electrified positively, there is a cylindrical spark out of which lucid rays, like a river, are darted. TXEphi rays, he says, form a lucid cone, the apex of which is turned towards a point from which the fire proceeds. Sometimes from the apex or at some distance from it, there's a lucid point, which he says. How Phineas ca each year, of the second kindi out of which slew streams of fire, the streams never thui from the eladirified body itself, but always from this lucid point. He says, moreover, that this lucid point at the extremity of an electrified body, and which throws out lucid rays, forms the Diphtenfly of Sharafir, of the positive cone. A negative cone, he says, is small, consisting of very slender filaments, which immediately adhere to the point at which the light we see P132, electric light. 361 enters or to its sides, and if accurately examined, seems to form little cones, the bases of which rest upon the body. When he afterwards comes Tokon fighter, the cause of negative cones of light, he owns himself to be at a great loss how to do it. Mr. Wilke put Englifly phosphorus up on a pointed body, which in the dark rendered the whole visible. And when he fuffen see this pointed body perpendicularly, the phosphorial vapors were seen to ascend, but upon electrifying it, as it hung in the same direfleon, the vapors were carried downwards, and formed a very long cone. Extending out of the middle of the cone of electric light, which was seen perf, and ei diftindle from it. When the electrification was discontinued, the phosphorial vapor ascended AF first. From this depression of the phosphoryle effluvia, Mr. Wilke infers the efflux of the electric fluid from the point, and upon the surface, and not only through the subflance of the pointed body. It is pity that he did not try this curious experiment with pointed bodies electrified negatively. He would certainly have found the same depression of the phosphoryle effluvia, and would probably have retracted his conclusion concerning this proof of the efflux. Mr. Wilke also thought it to be a proof that the electric matter did not only slow out of the substance of electrified bodies, but up Wilke P134, 364s becquerel on the surface of that a metallic ring, projected ever so little beyond the point of a wire on which it had been put, prevents the appearance of the lucid point. The last observation which I shall recite of Mr. Wilke concerning electric light is that if a point not electrified be opposed to a point cleflarified povidivegi, the cones of light, which in other circumstances inuld appear upon both of them, disappear, but that if percent positive cone be opposed to a negative cone, they both preserve TFPR, PPLP, and charadertic properties. Steiner Becquerel was of opinion that the direction of the electric fluid pi be determined from the phenomena of pointed bodies. The pencil, by which he means the electric fire at a point electrified positively. HP says, contrafe as it approaches a fiat piece of metal not electrified, whereas the guitar, by which he means the electric fire at a point electrified negatively, expands in the same circumferences, and has a small cavity near the point towards the large superficies. The pencil is attended with a snapping noise. The figure makes little or no noise. He hardly gives any reason for the first of these phenomena. He only says that such is the necessary consequence of a fluid feeding out of or entering into a point. But the greater noise made by the pencil he thought was made by the impulse given by the electric matter to the air, Wilke CP 140, causing electric light, 363 using it to vibrate, and this mole be greater urea TBE fluid is thrown from the point into the air. Then when it comes through different portions of the air and meets in one point, W and at 2 points are opposed to one another. Highlights. Geomina 1 are much the same in both. TIS Signor Becquerel observed that hollow glass VCFAs of a certain thinifo exhausted of air gave a light when they were broken in the dark. By a beautiful train of experiments, he found at length that the luminous appearance was not occasioned by the breaking of the glass, but by the deflaying of the external air against the inside when it was broke. He covered one of these exhausted vessels with a receiver, and letting the air suddenly on the outside of it, observed the very same liku. This he calls his new invented phosphorus J. This excellent philosopher produced a most beautiful appearance of electric light in the following manner. He conveyed positive claricity to a brass ball, suspended by a wire, within an exhausted receiver, when, upon presenting to it another ball in vacuoy, the lower hemisphere of the former was most beautifully illuminated with a visible electric atmosphere. When he conveyed negative electricity to the ball, the fanny beautiful illumination was observed on the ball presented to it. This experiment, he says, is a very delicate DTLTL queermo. 56. TCK 3064 Mr. Lane on K1R, requiring great patience and dexterity in adjusting the distances and C in order to make it succeed perfectly. Till one Elric light is more fuddle can be netratirig. If one may say so, then light produced in any other way is manifest from several experiments, particularly the remarkable one of Mr. Hawksby. But none prove it so clearly as FOMO made by the ingenious Mr. Lane, who gives me leave to mention these. When he had, for some different purpose, made the electric fetiac pass over the surface, ETFA a piece of marble in the dark, he observed that the part over which the fire had passed, CD was luminous and retained that appearance for some time. No such effect of the electric shock having ever been occurred occurred before, he repeated the experiment with a great variety of circumstances, and found it always I with all calcareous substances, whether animal, and especially if they had been burnt into lime, and as far as he had tried, many more substances would retain this light than would not do it. Among others, several vegetable fuftans would do it, particularly white paper. Tiles and brick were lummus, but not tobacco pipe clay, though well burnt. That gicvious substances, when calcined, were luminous, appeared from bits of images vijuglook electric light. 395 images made of plaster of Paris. And of this dafts, he says, is the famous Bolognian stone dia. But many bodies, he found, were luminous after the electric light, which were not apparently so when exposed to the rays of the sun. He made THC curious experiments by placing the chains, or wires that led from the conductor to the outward coating of his jar within 1, 2, or 3 inches, according to the strength of the charge, from one another on the surface of the body to be tried, and discharging a shock through them. If the phloem was thin, he sounds that if one kaya was placed at the top and the other at the BFDM, it would appear luminous on both sides after de-explosion. XBFE experiments were communicated. Clearly proved that it was the light only that the substances retained, and nothing peculiar to electricity. And moreover, after frequent trials, discovered a composition which retains both common light and that of electricity, much more strongly than either the Bolognian stone or any other known substance whatever. With this new phosphorus, he makes a great number of most beautiful experiments. The slash made by the discharge of a common jar, within an inch of a circular piece of it, of about 2.5 inches in diameter, will illuminate it so much that the figures on a watch plate may be easily distinguished by it. 366 Mr. Hartman, and C. Ortson in a darkened room, and it will retain the light half an hour. I shall close this fedition of C. Expafnites and observations on electric light with an account of a remarkable appearance which occurred to Mr. Yertman when he had been making experiments 4 or 5 hours together in a small room, and after going out of it, returned soon with a HDE candle in his hand. Walking pretty swifty, he perceived a small flame to follow him. At the distance of about a pan and a half viewed a venal head when he slopped to examine it. He was a good deal alarmed at the appearance at first, but afterwards imagined it to be occasioned by the ascension of the fulfur, which had been thrown into the air by the violent continued electrification Fe. Sebu particor eucata this compafidon and experiment new with it, I my FEIIF decumrit relaya Fijiani Light and Shuri Piece 71, Section 36, Chapter 25, Period X, Section 9, The Electricity of the Tourmaline. This period of my history fumethia an entirely new subject of electrical inquiries, which, if properly pursued, may throw great light upon the most general properties of electricity. This is the T-Tourmaline. Though, it must be acknowledged, the experiments which have hitherto been made upon this volatile island, like exceptions to all that was before known of the subjective. D.F. Tourmaline, as Dr. Watson supposes, was known to the Antiquants under the name of the Lincurium. All that Theophrastus says concerning the Lincurium agrees with the Tourmaline, and with no other forefoil we are acquainted with. He says that it was yide for seals, that it was very hard, that it was endued with an attracting power like amber, and that it was laid, particularly by Diocles, to attract not only straws and small pieces of wood, but apho, copper, and iron. If beaten very thin, that it was pellucid of a deep red color, and required no small labor to pouf it. The account which passed current among the ancients concerning the origin of this stone was fabulous, which made Pliny think that all that was said of it was fabulous too. Tins no Giro Glock 368 G Pioneros on this stone? Though not much attended to by European philosophers till very lately, i.e. common in several parts of the Eifel, Indies, and more particularly in the island of Ceylon, where it is called by the natives Tourmaline. In this island the Dutch became acquainted with it, and by them it is called Ikentrikir ear, from its property of attraying aches when it is thrown into the fire. The first account we have had of late years concerning this extraordinary stone is in the history of the Royal Academy of Sciences at Paris for the year 1717, where we are told that Mr. Lemery exhibited a stone which was not common and came from Ceylon. This stone, he said, attracted and repelled small light bodies, such as alhes, filings of iron, bits of paper, and see, Linus, in his Flora Zeylanica, mentions this stone under the name of lapis exiriqui and takes notice of Mr. Lemurien's experiments. Notwithstanding this, no farther mention was made of this stone, and its effect still some years after. When the Duc de Noia, in his letter to Mr. Buffon presented to the Royal Society, informed us that when he was at Naples in the year 1743, Count Pichetti, secretary to the king, assured him that during his stay at Constantinople, he had seen a small stone called tourmaline which attracted and repelled ashes. This account the Duc de Noia had quite forgotten, but being in Holland in the year 1758, he fought and purchased 2 of those stones, with these in company with Meffers, Daubenton and Adamfon. He made a great number of experiments, of which he savored the public with a particular account, Botti prior to the Duc de Noia's experiments. Mr. Lechman had acquainted Mr. Pinus with the attractive power of the tourmaline, and Fernal had him on which he made many experiments, the result of which he published in the History of the Academy of Sciences and Belk's Letters at Berlin for the year 1756. The substance of the memoir is as follows. The tourmaline has always at the same time a positive and a negative electricity, one of its sides being in one state and the other in the opposite, and this does not depend on the external form of the stone. These electricities he could excite in the strongest degree by plunging the stone boiling water, if one side of the tourmaline be heated, more than the other, as if it be laid upon a hot cake of metal. Each of the sides acquire an electricity opposite to that which is natural to it. But if less to itself, it will return to its natural state. If one of the sides of the tourmaline be rubbed, while the other is in contact with IBM conductor communicating with the ground, BB the 370 min, Wilson Oju the rubbed side is always positive and the other negative. If neither side be in contact with a CP ender, both become positive. If in the former of these cases the tourmaline be rubbed, so as to acquire a fiendful heat, and the side which is naturally positive be made negative, it will upon landing to cool, return to its natural heat, but if it have acquired no sensible heat, it will not return to its natural state while any kind of electricity remains. If it be heated, even when it is rubbed and insulated, in which case both sides become positive, it will still return to its natural state upon cooling. The Duc de Noia mentions TPO experiments of Mr. X. Pinus, but does not admit of a plus in minute electricity belonging to the tourmaline when heated. On the contrary, he lays that both the sides are elerified plus one of them more than the other, and it was the difference between those degrees which led Mr. Dotnus into his mistake. The tourmaline was introduced to the notice of the Anglophilophobbers by Dr. Heberden, who fortunately recollecting to have seen one of them many years before, in the Paphatheon of Dr. Sharp at Cambridge, and it was the only one known in England at that time, procured it for Mr. Wilson, who, though it was but a small one, repeated with it most oft the experiments of Mr. Pinus, so far as to satisfy J.N. de Gager Vizera Glass, satisfy himself that his opinion of its positive and negative power was well sounded. Afterwards, Dr. Heberden, ever desirous of extending the bounds of science, procured some of these stones from Holland, and put them into the hands of those persons who were likely to make the best use of them, particularly Mr. Wilfo and Mr. Kent J. Ea, whose hands they were not lodged in vain. As will appear by the Breeze account, I shall subjoin of their experiments upon them. Mr. Wilsonite observations are too many and too particular to be all inserted in this work. The result of them was, in the main, the same with that of Mr. Pinus, if flying the opinion of the 2 different powers of this stoner. But, contrary to Mr. Pinueha, he asserts that when the sides of the tourmaline are unequally heated, it exhibits that species of electricity which is natural to the hotter side. That is, the tourmaline is plus on both sides, when the pious side is the hotter, and minus on both sides when the minus side is the hotter. Upon this, Mr. Iapinus repeated all his former experiments, and still found the result of them agreeable to his former conclusion, and contrary to that of Mr. Wilson. Mr. Wilfoa also repeated his without any variation in the event, and imagine the difference between him and Mr. Pinus, might arise from the different sizes of the tourmalines they made use of, or from their different manner of making the experiments. And it is evident from B the OIC 372, Mr. Wilson, on the deployment of both their apparatus, that of Mr. Wilson was much better calculated for the purpose of accurate experiments than that of Mr. Japin. Mr. Wilson also used a greater variety of methods of communicating heat to his tourmalines. He both plunged them in boiling water, held them to the flame of a candle, and exposed them to heated, insulated electrics. Though the detail of all Mr. Wilson's experiments would be, as I observed before, much too long for my purpose, I cannot help relating one of them, which is made with the last mentioned method of treating. He heated one end of a glass tube red hot, and when he had exposed what both he and MP Japinus called the negative side of the tourmaline to it, he observed that about 3 inches of the heated part of the glass were electrified, minus though the glass beyond that was electrified GRHJ, and continued so even after the glass was cold. The electric fluid having passed from the tourmaline to the glass, since these were the same appearances that were produced by presenting an excited tube to the heated glass. He then applied the plus side of the tourmaline to the same heated glass, and found that the tube was electrified minus above a foot in length, without the least appearance of Zplui electricity beyond the minus one, as in the other experiment. And this minus electricity appeared when the tube was nearly cold. In this case, he judged that the electric fluid had passed from the glass to the tourmaline. Mr. Wilson imagined that the tourmaline, as well as glass, was permeable to the electric fluid, and that the resistance to its entering the substance of it was less on what he calls the negative than on the positive side. These conclusions he drew from the 2 follow-Wilg experiments. Rubbing the positive side of the stone slightly, he found both sides elioride plus. But, redeeming the negative side in the same manner, box sides were electrified more strongly than before. Several experiments led Mr. Wilson to conclude that the tourmaline resisted the exit and entrance of the electric fluid considerably less than glass, or even than amber, and upon the whole he infers that the tourmaline differs in nothing from other electric bodies, but in acquiring electricity by heat. Examining a great number of tourmalines, he found that a line drawn from the plus part through the center of the FL1 would always pass through the minus part. Almost all these tourmalines he greased over, and whilst they were warm enough to preserve the grease liquid, he tried each tourmaline separately, but found no alteration in the virtue of the stone, except that it was a little weakened, though it is well known, he says, that moisture of any sort readily conducts B the 37 plus Mr. Wilson on the electric fluid. If, therefore, the tourmaline had not a fixed kind of electricity, the plus and minus electricity observable on the 2 sides of the stone must, by this treatment, have united and destroyed each other. From this circumstance, Mr. Whitfin concluded that the tourmaline suffered the electric fluid to pass through it only in one direction, and that in this it bore some analogy to the lodestone J, having, as it were, 2 electric poles, which are not easily destroyed or altered, but he was not aware how imperfect a condiflor oil or grease of any kind is. This induced him to try whether, like the lodestone, the tourmaline would lose its virtue after being made red hot. But, though he kept 2 of them in a strong fire for half an hour, he could not perceive the least alteration in them. But plunging one in water while it was red hot entirely destroyed its virtue, and gave it the appearance of having been fevered in many parts without breaking tea. He observes that when a tourmaline, which he had from Dr. Morton, was held between the eye and the light, and viewed in the diaphragm through which the electric fluid is found to pass, it appears of a darker color considerable than when it is viewed at right angles to the former direction. This appearance, he says, obtains in many other tourmalines, especially when they happen to be as conveniently fly-upped J, not D, the tourmaline, 37G. The most important difficulty relating to the electricity of the tourmaline was referred from Mr. Canting, who in a paper read at the Royal Society in the same month with that above mentioned of Mr. Wilson, viz. December 1759, observes that the tourmaline emits and absorbs the electric fluid only by the increase or diminution of its heat. For if the tourmaline, he says, will be placed on a plain piece of heated glafa or metal, so that each side of it, by being perpendicular to the surface of the heated body, may be equally heated, it will, while heating, have the electricity of one of its sides positive, and that of the other negative. This will likewise be the case when it is taken out of boiling water and suffered to cool. But the side which was positive while it was heating will be negative while EGI is cooling, and the side which was negative will be positive. In this paper, Mr. Canton refers to the Gentleman's Magazine for the month of September before, in which he bade Publioid UIR Seafull to some experiments he had made on a tourmaline which he had procured from Holland. The propositions he there lays down are so few, and comprise the principal part of what is known upon this subject in so concise and elegant a manner, that I shall recite them all in this place. When the tourmaline is not elan rickle or attractive, heating it without freon will be make 376 Mr. Canton on make it so, and the electricity of one side. Of it, diffdingoflied by A will be pofuve, and that of the other IDB me 2. The tourmaline, not being leafricol, will become phobicooling, but with this difference that the Lido will be negative, and the 2-eyed be 2. 3. If the tourmaline in a non-Ella Rickle state be healed and suffered to cool again without either of its sides being touched, A will be positive and be negative the whole time of the increase and decrease of its heat. 4. Each of each side of the tourmaline will be positive by Friedlein, and both may be made so at the same time. These, says he, are the principal laws of the sea cythericity of this wonderful flowing. And he adds, if air be supposed to be endued with similar properties, i.e., of becoming electrical by the increase or diminution of its heat, as is probable, if its state before and after a thunderstorm be attended to, thunder clouds, both positive and negative, as well as thunder dusts, may easily be accounted for. The FSSF. Capital discoveries were made before Mr. Canton had received of Dr. Heberden the tourmalines above mentioned. When those came to his hands, he was enabled to make several new and curious experiments, which I have leave to publish. H put one of the tourmalines, which was of the common color, into the flame from a blowpipe, and burn it white, when he found that its electrical property was entirely derived through it. The electricity of another was only in part defloyed by the fire. 2 other tourmalines he joined together, Vihen. They were made soft by fire without destroying their electrical property. The virtue of another was improved by its being melted at one end, and he found, contrary to what Mr. Wilson had observed of another tourmaline, which he treated in the same manner, that one tourmaline retained its electrical property after it had been frequently made red hot, and in that state pat into cold water. But the most curious of his experiments were made upon a large irregular tourmaline, about half an inch in length, which he cut into 3 pieces, taking one part from the positive and another from the negative end. Trying these pieces separately, he found the outer side of the piece which he cut from the end that was negative when cooling was likewise negative when cooling, and that the outer side of that piece which was cut from the end that was positive when cooling was likewise positive when cooling. The opposite sides of both pieces being agreeable to the general law of the electricity of the tourmaline. In a contrary state, the middle part of the same tourmaline was affected just as it had been when it was in aura. The positive end remained positive, and the negative end continued negative. The same he had also observed of 2 other tourmaliophyi. 378. Mr. Canton on violins, each about the halves of this, which were also cut out of a large one. On January the 8th of 1762, Mr. Canton took the Dollar's large tourmaline, which Mr. Wilson has given a description of, in the 51st volume C, the Philosophical Transductions, p. 316, and having placed a small tin cup of aerating water on one end of his electrometer, which was supported by warm glacia, while the pith balls were suspended at the other end, he dropped it into the water and observed that during the whole time of its being heated, and also while it was cooling in the water, the balls were not at all elified. Till the year 1760, it had been supposed that of all electric Fuftensa, the tourmaline alone left the property of being extincted by heating and cooling, but in the beginning of that year, Mr. Canton having had an opportunity of examining a variety of gems. By the savor of Mr. Nicholas Crisp, a jeweler in Baugh Churchyard, first found the Brazil tops to have the electrical properties of the tourmaline. The largest be met with, he put into the hands of Dr. Heberden, who returned it November the 8th, 1760, and sent with it the tourmalines above mentioned. In September 1761, Mr. Wilson, who had been informed of Mr. Canton's discovery, met with several other gems of different sizes and colors that resembled the tourmaline with respect to electrical experiments, the roost. Beautiful of them were something like the ruby, others were more pale, and one inclining to an orange color. In point of hardness and luster, they were nearly the same with the topaz. From all his experiments upon these gems, he thought it was abundantly evident that the diron of the fluid did not depend upon the external figure of the gem, but upon some particular internal make and coloration of it, and that there is some such natural disposition in all gems affording these appearances may be collected, he says, from another curious specimen of the tourmaline kind, which is green and formed of long slender crystals with fevicaw sides, many of which are foan fitted together and are brought from South America. Tub gems, numbers of which were furnished him by Mr. Manuel Mendes de Gofta. He not only found to be like the tourmaline with RCFF to electric appearance, but that the direction of the electric fluid moving therein was always along the grain or hootings of the Kryftau, one end of it being a lesser L, and the other end minus, and that the fluid is more disposed to pass in that direction than in another, he thought, might be farther cleased from what has been observed on the grain of the lodestone by Dr. Knight, who found that, though the magnetic poles of the natural lodestone might be varied in any direction, yet that the same lodestone admitted of being made much more magnetical along the grain than across it. G8 from 390, Mr. Wilson, and C. From these experiments and observations, Mr. Wilson inferred by analogy that the electric fluid slowed through all these stones and gems, moves in that direction in which the grain happens to lie, and that the reason of this is to the reflance which the fluid meets with in pathing through the gem is left in that direction than in any other. In a subsequent paper of Mr. Wyfan's, re at the Royal Society, December the 23rd, 1763, and March 1764, he recites several curious experiments on the effects of removing the tourmaline from one room to another, in which there was femi-deflorence of heat, the result of which exactly confirms Mr. Canton's discovery that the side which is positive when heating is negative when cooling, and vice versa. Upon a very nice examination, and during some favorable circumstances, Mr. Wilson says he has observed the tourmaline to be feebly electrified. When the thermopity have varied up and down, only 1 degree F section 30, chapter 26, period X, section X discoveries on lightning and electricity, after Franklin discoveries that have been made since those of D. Franklin with respect to the sameness of lightning and electricity. The year 1752 makes Enzera and electricity no less famous than the year 1746 in which the Leyden file was discovered. In the year 1752 was verified the hypothesis of Dr. Franklin of the identity of the matter of lightning and of the electric fluid, and his great project of trying the experiment by real lightning, actually brought down from the clouds, was carried into execution. The French philosophers were the first to distinguish them fives upon this memorable occasion, and the most active persons in the scene were Mr. Dalibard and Delors, both zealous partisans, as Mr. Nollet calls them, of Dr. Franklin. The former prepared his apparatus at Marly-la-Ville, situated 60 or 6 leagues from Paris, the other at his own booth. On fumée of the highest ground in that capital, Mr. Dalibard's machine consisted of an iron rod 40 feet long, the lower extremity of which was brought into a sentry box, where the rain could not come, while on the outside it was fastened to 3 wooden posts by long silken firings defended from the JVG-type side. This machine happened to be the first that was savored with a visit from this ethereal fire. The philosopher himself happened not to be at home at that time, but in his absence he entrusted the care of his apparatus to one coiffier, a joiner. a man who had served 14 years among the dragoons, and on whose understanding and courage he could depend. This artisan had all proper instructions given him, both how to make observations, and also to guard himself from any harm there might be from them. Besides being C.X. Priestley ordered to get some of his neighbors to be present, and particularly to send for the curate of Marley, whenever there should be any appearance of the approach of a thunderstorm. At length the long-expected event arrived. On Wednesday, the 10th of May, 1752, between 2 and 3 o'clock in the afternoon, Coiffier heard a pretty loud clap of thunder. Immediately he flies to the machine, takes a file for Nitchide with a brass wire, and presenting one end of the wire to the rod, he sees a small bright spark flew from it, and hears the snapping that it made. Taking a second spark stronger than the former, and attended with a louder report, he calls high neighbors and sends for the curate. The curate runs with all his might, and the Parafleoners, seeing the precipitation of their spiritual guide, imagined that poor Coiffier had been killed with lightning. The alarm spreads through the village, and the hail which came on did not prevent the flock from fall wilter flyford. The honest ecclesiastic arriving at the machine, and seeing there was no danger, took the wire into his own hand, and immediately drew several strong sparks, which were most evidently of an clerical nature, and completed the discovery for which the machine was The thundercloud was not more than the quarter of an hour in passing over the zenith of the machine, and there was no thunder heard besides that single clap. As soon as the alarm was over, and no more sparks could be drawn from the bar, the curate wrote a letter to Mr. Dalibard containing an account of this remarkable experiment, and sent it immediately by the hands of Coiffier himself. He says that he drew sparks from the bar of a blue color, 1.5 inches in length, and which smelled strong of sulphur. He repeated the experiment at least X times in the space C about 4 minutes, in the presence of many persons, each experiment taking up the time, as he, in the style of a Priel, expresses himself, of a Paffer and an AV. In the course of these experiments he received a roke on his arm, a little above the elbow, but he could not see how clear it came from the brass wire into the file, or from the iron bar. He did not attend to the stroke at the time he received it, but the pain continuing, he uncovered his arm when he went home, in the presence of Coiffier, and a mark was perceived round his arm, such as might have been made by a blow with the wire on his naked skin, and afterwards several persons who knew nothing of what had happened said that they perceived a smell of sulphur when he came near them. Coiffier told Mr. Dalibard that for about a quarter of an hour before the curate arrived, he had, in the presence of 5 or 6 persons, taken much stronger sparks than those which the curate mentioned. 8 days after, Mr. Delore fought the same thing at his own house. Although only a Shiju baffled over, without sither thunder or lightning the same experiments were afterwards repeated by Mr. Delore at the request of the King of France, who, it is said, fought them with the greatest fattest valiant, and expressed a just sense of the merit of Dr. Franklin. These applauses of the king excited in Mr. de Buffon, Dalibard, and Delore a desire of verifying Dr. Franklin's hypothesis more completely, and of pursuing his speculations upon the subject. M.I. Delore's apparatus in Paris consisted of a bar of iron 99 feet high, and answered rather better than that of Mr. Dalibard, which, as was observed before, was only 4 feet high, but as the quantity of electricity which they could procure from the clouds, in these first experiments, was but small, they added to this apparatus what they called a magazine DF electricity, consisting of many bars of iron insulated, and communicating with tile-pointed IRPN rod. This magazine contained more of the LCS matter, and gave a more sensible spark upon the APA. A magazine of this kind Mr. Maziz had in an upper room of his house, into which he brought the lightning. By means of a wooden pole proceeding out of his window, at the extremity of which a glass tube filled, with rosin received a pointed iron rod 12 feet long. But all this while the electrics, which they made use of to support these iron rods, were too much exposed to the open air, and consequently were liable to be wet, which would infallibly defeat their experiments. The mod accurate experiments, the with FC imperfidinalrument, where those of Mr. Monier, he was convinced that the high situation in which the bar of iron had commonly been placed was not absolutely nii fairy for this purpose, for he observed a common F-picketed triumpede suspended upon silk 5 or 6 feet from the ground. To exhibit very evident signs of illyricity, he also found that a man placed upon cakes of rosin and holding in Leah's hand a wooden pole about 18 feet long, about which an iron didier would, that very lively spark he had drawn from him, and that another man handing upon non-electrics in the middle of C.C. a garden, and only holding up one of his hands in the air, attracted with the other hand shavings of wood which were held to him. He says that he often heard a continual diminution of the electricity when the rain came on, though the thunder was too very loud, and though the cake of rosin which supported his conjure was not wet. But he afterwards found that this was not universally true. He once observed that when the conducting wire was surrounded with drops of rain, only some of them were electrified, as was evident from the conical figure they had, while the rest remained round as before. It was also perceived that the electrified and non-elidority drops generally succeeded kati other alternately, which made Mr. Moniker call to mind an angular phenomenon, which happened some years before to 5 peasants who were path ng through a corn 6-field near Frankfurt upon the Oder during a thunderstorm, when the lightning killed the first, the third, and the 5th of them, without injuring the 2nd or the 4th. It was not O'Wilga any want of attention to this subject's eye that the English philosophers were not the first to verify the theory of Dr. Franklin. They happened to have few opportunities of trying experiments. In the few they had, they were disappointed by the onslaught, Paltling 387 rain wetting their apparatus, which was not better construed than that of that French. At length, success crowned the affluity send happier contrivance of Mr. Canton, who, to the lower end of his conducing wire, had the precaution to fasten a tin cover to keep the rain from the glass tube which supported it. By this means, on the 20th of July, 172, he got sparks at the distancy of half an inch, but the whole appearance ceased in the space of 2 minutes. Mr. Wilson, who took great pains, he saw these pursuits, as he did in everything else relating to electricity, perceiving febrile electrical snap-swa on the eye of August Fovey, from no other apparatus than an iron curtain rod, one end of which he put into the neck of a glass phial which he held in his hand, while the other was made to point into the air. Odie, the 2nd of August, observed nearly the Fanny F appearances that Mr. Canton had done before. Mr. Campton afterwards, resuming his observations on lightning with the assiduity and accuracy with which he observes everything, found by a great number CTF experiments that female clouds were in apophytici and some in a negative state of electricity, and that, by this Mia, the electricity of Phil, 10F, volume at 70p, 6 UICTA, NJ diet. I see his conjuror would sometimes change frohe, one state to the other 5 or 6 times in T, and then half an hour. This observation of Mr. Canton on the different edricity of the clouds was made, and the account had published in England before it was known that Dr. Franklin Badd made the iron discovery in America. When the air was dry, he observed that the apparatus would continue electrified for 10 minutes or a quarter of an hour after the clouds had painted the zenith, and sometimes till they were more than halfway towards the horizon. That rain, especially when the drops were large, generally brought down the electric bridge, and hail and stimmer, he believed, never sailed. The last observation he had made before the time of his writing this paper, when his apparatus had been electrified by a fall of the Wilg snow. This was on the 2nd of November, 1753, which, he says, was the 26th day, and the 61st time it had been electrified since it was first fed up, viz., about the middle of the preceding May. Only 2 thunderstorms had happened at London during that whole summer, and Mr. Canton's apparatus was so strongly electrified by one of them that the ringing of the bells, which he suspended to his apparatus, to signify when the electrification was begun, and which were frequently rung so loud as to be heard in every room in the Phil, RMF volume, PTIPSJs, house, hoif, was stifled JJ the almost constant stream of dense electric fire between each bell and the brass ball, which will not suffer it to strike. Upon a farther occasion, he offers that in the succeeding months of January, February, and March, his apparatus was electrified no less than 25 times, both positively and negatively, by FNOW as well as by hail and rain, and almost to as great a degree when Fahrenheit's thermometer was between 28 and 34, as he had ever known it in summer, except in a thunderstorm. Mr. Canton concludes his paper with propofong the two following queries, i.e., may not air suddenly rarefied, give electric fire too, and air suddenly condensed, receive electric fire from clouds and vapors passing through it, 2.1. Is not the aurora borealis the flafting of electric fire from positive towards negative clouds at a great distance through the upper part of the atmosphere, where the resistance is least? Mr. Canton not only observed the different states of positive and negative electricity in the clouds, but also noted the proportion that the one bore to the other for a considerable time. In the viral period, he had observed the clouds had been positively electrical HJ times and negative 10R fruit. In this period, he had NJ Dow, how often the powers had shifted, and the whole time, the apparatus continued to be electrified. But he had entirely neglectful to note the time that each power lasted. But this lawful circuiobuflania he afterwards carefully attended to for about 2 months, viz., from the 28th of June to the 23rd of August 1754, and found the apparatus to be electrified positively 31 times, which taken together lasted 3 hours 36 minutes, and negatively 45 times, the whole duration of which was 2 hours 39 minutes. He also observed that the positive power was generally the Fifruger. This account he wrote the 3-1 theft of August 1754. Dathie observations, which Mr. Canton gives me leave to make public, are extremely curious, and must have required great attention, J., but they are hardly sufficient to authorize a general conclusion. One of the effects of lightning and electricity is the melting of metals. This was first thought to be a cold fusion, but that O.P. Knight is refuted in a very sensible manner by Dr. Knight in a paper read at the Royal Society November 22, 1759. He observes that the annulances most generally given of cold fusion are two, viz. That of a sword being melted in its scabbard, and that of money being melted in a bag, both the scabbard and the bag remaining unhurt. A great number of authors, he says, BV mention of both the facts, but without giving either thereos for the truth of them, or describing any of the other concomitant circumstances. And it seemed to him very probable that lightning might produce effects similar to TGOFA, above mentioned, without our being obliged to have recourse to a cold fusion to account for them. If, says he, the edge or external fiery surface of a sword had been melted, while the main part of the BME remained entire, it would have afforded sufficient ground to allert, in general terms, that the sword was melted. And yet, the scabbard might have remained unhurt, J, because either the edge or surface of the sword might be instantly melted by lightning and cooled so suddenly as to make no impression of burning upon the scabbard. He observes will both heat and cool sooner in proportion as they are thin and slender. That very small wire will instantly become red hot and to then melt and run into a round globule in the same of a common candle. Though it is no sooner removed out of the flame, but it is instantly cold, he therefore concludes that the edge of a sword or even its surface might be instantly melted by lightning, and being in contact with, or rather still united to the rest of the BKD, which might be cold, it would part with its heat too suddenly to produce any appearance of burning. HB was confirmed in this reasoning by examining faux fragments and particles of sea wire melted by lightning, which were sent him by Mr. Montaigne. Amongst them appeared globules of various sizes, which had undergone very different degrees of fusion. The large shaft of them had not been fluid enough to put on an empirical figure, but they approached nearer to it in proportion as they were smaller, so that, in the smallest granulogia, the Euphian was most perfeeful, the globules being very round and smooth. Their sizes continued diminishing till they became invisible to the naked eye, and many of them, when viewed with a microscope, required a third or fourth magnifier to see them distinctly. Some of the bits of wire were rough and scaly like burnt iron, and were swelled those places where they were beginning to melt. Others continued straight and of an equal thickness, but their outward surface seemed to have undergone a perfect fusion, so that there were two or more pieces adhering together, as if joined by a thin solder. In the philosophical Transfadlians, Dr. Knight says, there are two or three relations which seemed at first to savor a cold fusion, but when duly considered proved nothing conclusive. But that there is really no such thing as cold fusion, sither by electricity or lightning, was most clearly demonstrated by Mr. Kinnerfleet in a letter to Dr. Franklin, dated Philadelphia, March 1st, 176-1. Phil TRTBF, Volume UPT, IPIG 4C. He suspended a piece of small brass wire about 24 inches long, with a pound weight at the lower end, and by sending through it the charge of a case of bottles containing above 30 feet of coated glass, he discovered what he calls a new method of wire drawgut. The wire was red hot, the whole length well annealed, and above an inch longer than before. A second charge melted it so that it parted near the middle and measured, when the ends were put together, 4 inches longer than at first. This experiment, he says, was proposed to him by Dr. Franklin in order to find whether the electricity, impelling through the wire, would so relax the cohesion of its constituent particles as that the weight might produce evaporate. But neither of them irradiated the least suspicion that any heat would be produced, that he might have no doubt of the wire being hot as well as Reggie. He repeated the experiment on another piece of the same wire, encompassed with a goose quill, filled with loose grains of gunpowder, which took fire as readily as if it had been touched with a red-hot poiser. Also tinder tied to another piece of the wire, kindled by it. But when he tried a wire about twice as big, he could produce no such effect. 3 KCS, says he, it appears that the electric fire, though it has no sensible heat, when in a state of rest, will, by its violent motion, and the resistance it meets with, produce heat in other bodies. When pulsing through that and prorid they be small enough, a great quantity will pass through a large wire without producing any sensible beat, when the same quantity passing through a very small one being to be, he can find to a pair passage tight particles crowding closer together, and, meeting with a greater refiflence, will make it red hot and even melt it. Hence he concludes that lightning does not melt metal by a cold fusion, as Dr. Franklin and Banfield had F.B. Burley supposed, but that, when it passed through the blade of I-4, if the quantity was not very great, it might heat the point so as to melt it, while the flow depth and the thickful part might not be FC unfably warmer than before. While trees and houses are let on fire by the dreadful quantity which a cloud, or sometimes the earth discharges, muffle not the heat, tie and heat, by which the wood I fearful kindled, be generated by the lightning's violent motion to lure the living combulable matter, FIP lightning, by its rapid motion, produced heat in itself as well as in other bodies, which Mr. Kinnerfleet imagined, was evident from some experiments made with electrical thermometer mentioned before. He thought that it sometimes injuring the hair of animals killed by it might easily be accounted for, and that the reason of its not always doing so might be that the quantity, though sufficient to kill a large animal, might not be great enough high, or not have met with ruins enough to become by its motion burning not. We find, says B, that dwelling house struck with lightning are seldom set on fire by it, but that when it pelts through barns with hay or fire in them, or doorhoofs containing large quantities of hemp or such like matter, they seldom, if ever, escape a conflagration. This, he thought, might be owing to such combustibles being apt to kindle with a less degree of heat than was necessary to kindle wood. All that was done by the French and English electricians with ref to lightning and electricity, fav short of what were done by Signor Beccaria at Turin. His attention to the various feuds of the Atmoa FB fair, his assiduity in making experiments, his apparatus for making them, the extent of his views in making them, the minute exactness with which he has recorded them, and his judgment in applying them to a general field, far exceeded everything through it had been done by philosophers before him, or that has been done by any person since. And though I shall give considerable scope to my account of his experiments and observations, I shall be able to give my reader but a faint idea of the extent, variety, and value of his labors in this great field. Peel, volume 93 TT, Hada 3096 S BCC area. He made use both of kites and pointed rods, and of a great variety of both at the same time, and in different places. Some of the firings of his kites had wires in them, and others had hone. Some of them slew to a prodigious height, and others but low. At Toul he had a great number of affliftants, to note the nature, time, and degree of appearances, expeding as his views required, to keep his kites constantly insulated, and at the same time to give them more or less string, and for many other purposes. He had the siring rolled upon a reel, which was supported by pillars of glass, and his conduit 3, or had a communication with the axis of the rule, to distinguish the positive and negative state of the seal duds, when TXE electricity was vigorops, with more certainty and with more iefity than it could be done by presenting an excited slick of glass, or feeling wax to threads diverging from his conductor. He enclosed a pointed wire and a slat piece of lead opposite to it within a cylindrical glass veftel wrapped in paddleboard, so that the inside could have no communication with the external light. Into this cover and opposite to the point of the wire he inserted a very long TNB of paddleboard, through which he could look from a considerable distance and see the form of the electric light at the end of the Litircidia Aletisa fleck, Pitistis. Id tire I, which is the fural indication of its utility, from Signor Beccaria's extremely exa and circumstantial account of the external appearances of thunderclouds, which he prefixes to his observations on their probable causes. I shall draw a general outline of the most remarkable particulars in the usual progress of a thunderstorm. The first appearance of a thunderstorm, which generally happens when there is little or no wind, is one dense cloud, or more, increasing very fast in size and rising into the higher regions of the air. The lower surface is black and nearly level, but the upper finely arched and well defined. Many of these clouds often seem piled one upon another, all arched in the same manner, but they keep continually uniting, extending their arches. At the time of the rising of this cloud, the atmosphere is generally full of a great number CS separate clouds, motionless, and of odd and whimsical phaepes. All these, upon the appearance of the thundercloud, draw towards it, and become more uniform in their phaepes as they approach, till, coming very near the thundercloud, their limbs mutually fire it towards one another. They immediately coalesce, and together make one uniform mass. These he calls adiapsidious clouds, from their coming in, to enlarge the size of the letter del electricumo. P1F7, 7 Thunder 39 BS, Bikita Thorder cloud. And K, I meantime the thundef cloud vril swallow, an intercafe very fact with oat the conjunction of any adicititious clouds. The vapors in the atmosphere forming THC themselves into clouds whenever it baffles. Some of the adiapsidicious clouds appear like white fringes at the occurrence of the thundercloud or under the body of it, but they keep continually grow darker and darker as they approach to unite with it. When the thundercloud is grown to a great FTC, its lower surface is often raggle, particular parts being detached towards the earth, but still coilanded with the rest. Sometimes the lower surface swells into various large protuberances bending uniformly towards the earth. And Fama Omaz, one whole side of the cloud will have an inclination to the earth, and the extremity of it will nearly touch the earth. When the eye is under the thundercloud, after it has grown larger and well formed, it is seen to sink lower and to darken prodigiously. At the same time that a number of small adiapsidicious clouds, the origin of which can never be perceived, are seen in a rapid motion, driving about in very uncertain regions under it. While these clouds are agitated with the most rapid motions, the rain generally falls in the great fef plenty, and if the agitation be exceedingly great, It comma inanle hails, TLR armor del demasirmopi. 151, wild lie GHT and IND. 3 Wild the thundercloud is falling and extending its branches over a large tract of country. The lightning is seen to dart from one part of it to another, and off deft to illuminate its whole mass. When the seafoam has acquired a sufficient extent, the lightning fritzes between the cloud and the earth. In 2 opposite places, the path of the lightning lying through the whole body of the cloud and its branches. The longer this HJT time continues, the rarer does the cloud grow after less dark is its appearance, till at length it breaks in different places and shows a clear icky. When the thundercloud is thus diffperfed, those parts which occupy the upper regions of the atmosphere are equally spread and very thin, and those that are underneath are black, but thin too. And they vany gradually, without being driven away by Adi wild. Having seen what this philosopher observed abroad and in the air, let us see wit he took notice of at his apparatus within doors. This never sailed to be electrified upon every approach of a thundercloud, or any of its branches, jade and TB stream of fire from it, was generally perpetual, while it was decoction over the apparatus. That thunderclouds were sometimes in a positive as well as negative state of electricity, Signor Beccaria had discovered before he heard of its having been observed by Dr. Lettier del Risolino. P 146.1176, Franklin, 40 OS Beccaria on Franklin or any other person. The same cloud, in passing over his observatory, electrified his apparatus, Ibenetitness positively, and sometimes negatively F. The electricity continued longer of the same kind in proportion. As the thundercloud was simple and uniform in its Darion J, but when the lightning changed its place, there commonly happened a change in the electricity of his apparatus. It would change suddenly after a very violent flash of lightning, but the change would be gradual when the lightning was moderate, and the progress of the thundercloud slow. It was an immediate inference from his observations of the lightning abroad, and his apparatus within, that the quantity of electric matter in an effluent dorm of thunder is almost inconceivably great, considering how many pointed bodies, as trees, spires, are perpetually drawing it off, and what a prodigious quantity is repeatedly discharged to, or from the earth percent. After this summary view of appearance, I Hull, in the same fuxen fat manner, explain the hypothesis by which this excellent Philo Pfeffer accounts for Thero and some other principal and well-known phenomena of deer storms. Considering the vast quantity of electric fire that appears in the most simple thunderstorms, he thinks it impossible that any cloud, doctor number of clouds, field ever contain it, H, G, H, T, N, I, N, G, for or all, so as either to discharge or receive. Besides, during the progress and increase of the storm, though the lightning frequently struck to the earth, the same clouds were the next moment ready 16 make a after greater discharge G, and his apparatus continued to be as much affected as ever. The clouds must, consequently, have received at one place, the moment that a discharge was made from them in another. In many cases, the electricity of his apparatus, and consequently of the clouds, would instantly change from one kind to another several times. An effect which cannot be accounted for by any simple discharge or recruit. Both Mufel have taken place in a very quick Facheflian F. The extest of the clouds doth not leflen this difficulty. For, be it ever so great, still the quantity ought to be leflend by every discharge, and besides, the points by which the silent discharges are made, RE in proportion to the extent of the clouds F nor, is the difficulty lessened by supposing that fresh clouds bring recruits. For besides that the clouds are not ripe for the principal storm, till all the clouds, to a great distance, had agilely coalesced and formed one uniform mass of recruits, bear no sort of proportion to the discharge, and whatever it was, it would fua be exhausted. The fad, therefore, must be that the claret matter is continually darting from the Elcisier dir Eltricifmo, P185, is Tiabid, Arthric, Tiabid Pitaja. DD Clouds 402S, Bacterium clouds in one place at the same time while it is discharged from the earth in another, and it is a feast-fairy consequence from the whole, that the clouds serve as conductors to convey the electric fluid from those places of the earth which are overloaded with it to those which are exhausted of it. To ascertain this fact in the most complete manner, he proposes that 2 observatories be fixed about 2 leagues asunder in the usual path of the thunderclouds, and that observations be made, whether the apparatus be not often positive at one place, when it is negative at the other. That great quantities of electric matter do sometimes fly out of particular parts of the earth, and rise through the air into the higher regions of the atmosphere, he thinks is evident from the great quantities of sand, flies, and other light substances have often been carried up into the air, and scattered uniformly over a large straddle of country. No other known efficient cause of this phenomenon can be assigned, except the willed, and it has been observed when there was no willed fleering, and the light bodies have even been carried against the willed section. He supposes, therefore, that these light bodies are raised by a large quantity of electric matter flowing out of the earth, where it was overcharged with it, and by that property of IC which he had demonstrated, igniting and carrying carrying with it every substance that could serve as a conductor in its passage. All these bodies, being baffled of an equal quantity of the electric fluid, will be dispersed equally in the air, and consequently over that part of the earth where the fluid was wanting, and whither they served to convey it. Had TFC bodies been raised by the willed, they would have been dispersed at random and in heaps. This comparatively rare phenomenon, but of which he had been more than once a spectator, he thinks exhibits both a perfect image, and a demonstration of the manner in which the vapors of the atmosphere are raised to FMM thunderclouds. The same electric matter, wherever it flews, attracts to it and carries up into the higher regions of the air the watery particles that are dispersed in the atmosphere. The electric matter ascends to the higher regions of the atmosphere, being full sick by the less RC15s in FMD is there, than in the common mass of the earth, J, which at those times is generally very dry, and consequently highly electric. The uniformity with which thunder clouds spreads themselves, and for FUQTU into arches, muffled be a willed to their being, affeated by some, because which, like the electric matter, diffuses it EFLF uniformly, wherever it afts, and to the resistance they meet with in ascending through the air, FE. As a proof of this, phlegm, rifling from an elified eolipoil, diffuses itself woodly to lem, Jukokirk Delhi Eltricifmo, P301 F all P degrees DDA, formity forastis. That carry on formormity and in similar arches extending itself towards any conducing substance, the same cause which first raised a cloud from vapors dispersed in the atmosphere draws to it those that are already formed, and continues to form new ones, till the whole collected mass extends so far as to reach a part of the earth where there is a deficiency of the electric fluid FD. Thither, too, will those clouds, replete with electricity, be strongly attracted, and there will the electric matter discharge itself upon the earth. A channel of communication being, in this manner, found a freflifupti of electric matter will be raised from the overloaded part and will continue to be conveyed by the medium of the clouds till the equilibrium of the fluid between the two. Places of the earth be reflowered when the clouds are attracted in their passage by those parts of the earth where there is a deficiency of the fluid. Those detached fragments are formed, and also those uniform depending protuberances, which will be shown to be, in some cases, the cause of waterfalls and hurricanes, J, that the electric matter, which forms and animates the thunderclouds, flews from places far below the surface of the earth, that it buries itself there, is probable from the deep holes that have in many places been made by lightning section. Flalhes of lightning have also been seen to arise from subterranean literae or latukifmo, P, IO6, F, ibit, P, J, fibit, stella, Violent inundations have accompanied thunderstorms, not occasioned by rain, but by water bursting from the bowels of the earth, from which it must have been dislodged by some internal concussion. Deep wells have been known to sail faster in thunderstorms F, and others have constantly grown turbid at the approach of thunder. This very rise, as well as the whole progress of thunderclouds, has sometimes been in a manner visible. Exhalations have been frequently seen to rise from particular caverns, attended with a rumbling noise, and to have sent forth into the higher regions of the air, with all the phenomena of thunderstorms described above. According to the description of persons who lived long before the connect line between electricity and lightning, was FUPI 3E section. The greatest difficulty attending this theory of the origin of thunderstorms relates to the Calathri ion, an insulation of electric matter within the body of the earth. With ref to the former, he has nothing particular to say. Some operations in nature are certainly attended with a loss of the equilibrium in the electric fluid, but no person has yet assigned a more probable cause of the redundancy of the electric matter, which in fact often abounds in the clouds, than what we may suppose de possible IC for a sex SBECRRIOM possible to take place in the bowels of the cart, and supposing the loss of the equilibrium possible. The same cause that produced the effect would prevent the restoring of it. So not being able to force a way, at least one sufficiently ready, through the body of the earth, it would ill to at the most convenient vent into the higher regions of the air as the better passage. His electrical apparatus, though communicating with the earth, has frequently, in violent thunderstorms, given evident sparks to his singing. In the enumeration of the effects of duector storms, he observes that a wind always blows from the place from which the thundercloud proceeds, that this is agreeable to the observations of all mariners, and that the wind is more or less violent in proportion to the fuddenness of the appearance of the thundercloud, the rapidity of its expansion, and the velocity with which the adventitious clouds join it. The sudden condensation of such a prodigious quantity of vapors must displace the air, and repel it o'er all sides. If he, in some measure, imitated even this eft of thunder, at least produced a circular tie-in of all the air in his room by the continued electrification of his changing. Among other effects of lightning, he mentions the case of a man rendered exceedingly stiff, presently after he was struck dead in a form of thunder. But the most remarkable circumstance in this case, Uraz the lightning choofing the best conjurer, having see one particular vein near his neck, and followed it through its minutest ramification, so that the figure of it appeared through the icon finer than any pencil could have drawn it. H.B. cautions persons not to depend upon the neighborhood of a higher, or in all cases, a better conductor than their own body, since, according to his repeated observations, the lightning by no means descends in one undivided track, but bodies of various kinds can do their share of it at the same time, in proportion to their quantity, and conducing power a great number of observations relating to the descent of lightning. Confirm his theory of the manner of its ascent, for in many cases it throws before it the parts of conducting bodies, and distributes them along the resisting medium, through which it will force its pathway. Upon this principle it is that the longest slashes of lightning seem to be made, by its forcing into its way part of the vapors in the air section. One of the principal reasons why those flares make so long a rumbling is their being occasioned by the vast length of a vacuum made by the passage of the electric matter. For though the air coops the Edmodi meet 408 est that carry on meant after it has baffled, and the vibration, on which the sound depends, commences at the same moment through the whole length of the track. Yet if the slash was directed towards the pearlman who hears the report, the vibrations excited at the nearer end of the track will reach his ear much fobnerhan, those excited at the more remote end, and the sound will, without any repercussion or echo, continue till all the vibrations have successively reached him. I must introduce in this place a very curious experiment and observation of Mr. Lone, concerning the production of electricity in the clouds. He PA'd a long insulated pole project from the side of one of the Alps, and, on the 29th of June 1766, observed that when small clouds of vapor raised by the heat of the sun rose near the foot of the mountain, and ascended along the side df it, if they touched the extremity of the pole only, it was electrified, but if the whole pole, and consequently part of the hill on which it flood, VFA as Lift's wife involved. It was not electrified. From this, he concludes that the electricity of the clouds is produced by their pathing through the air, while the fun flies upon them. But to which of these two circumstances, namely the motion through the air or the action of the fun's rays, this was a will he could not determine. Though he made several experiments for that purpose, letter default electricissimo, P.I.J. N.J. glide. One of the most remarkable effects of lightning is that it gives polarity to the magnetic needle and to all bodies that have anything of iron in them, as bricks and sea. And by observing which way the poles of these bodies lie, it may be known with the utmost certainty in what direction the stroke paths. In one case, Beccaria actually ascertained the direction of the lightning. In this manner, J. Since the sudden furors of lightning gives polarity to magnets, he conjectures that a regular and constant circulation of the whole mass of the fluid, from north to south, may be the original cause of magnetism in general percent. This is a truly great thought, and if just, will introduce greater simplicity into our conceptions of the laws of nature. That this ethereal current is insensible to us is no proof of its non-existence, since we ourselves are involved in it. He had seen birds fly so near a thundercloud as he was sure they would not have done if they had been affied by its atmosphere section. This current he would not suppose to arl from one source, but from several. In the northern hemisphere of the earth, the aberration of the common center of all these currents from the north point may be the cause of the variation of the needle. The period of this declination of the center of the currents may be the period of the variation, and the obliquity with which the currents strike into the earth, 4 OSD. Beccaria OK, earth may be the cause of the dipping of the needle, and also why bars of iron more easily receive the magnetic virtue in one particular direction. He thinks that the aurora borealis may be this electric matter performing its circulation in such a late of the atmosphere as renders it viable or approaching nearer to the earth than usual. Accordingly, very vivid appearances of this kind have been observed to occasion a fluctuation in the magnetic needle. Stones and bricks struck by lightning are often vitrified. He supposes that some stones in the earthy, having been trucked to this manner, first gave occasion to the vulgar opinion of the TFPN der Bolt J. Signor Beccaria was very sensible that heat contributes much to the phenomena of thunder, lightning, and rain, but he could not find by any experiment that it tended to promote electricity. He therefore rather thought that heat operated, in this case, by exhaling the moisture of the air, and thereby cutting off the communication of the electric fluid between one place and another, particularly between the earth and the higher regions of the air, whereby its effects were more visible section. Having entertained my reader with the observations of this great Italian genius, I must once more conduct him to France, where he will see several experiments well worth his notice. 411 notice. In this country we have seen that Dr. Franklin's theory of the identity of electricity and the matter of lightning was first verified, and we shall now see it verified in the grandest and most conspicuous manner. The greatest quantity of electricity that wag ever taught from the clouds by any apparatus prepared for that purpose was by Mr. de Romas, a fighter to the prefidile of Nerac. This gentleman was the first who made use of a wire interwoven in the bempoy cord of an electrical kite, which he made 7 feet and feet half high and 3 feet wide, so as to have 18 equerry feet of surface. This coin was found to conduct the electricity of the clouds more powerfully than a hempen cord would do, even though it was wetted, and, being terminated by a cord of dry FDK, it enabled the observer, by a proper management of his apparatus, to make whatever experiments he thought proper, without danger to himself. Be the help of this kite, on the YH of June 175, about 1 in the afternoon, when it was railed 550 feet from the ground, and had taken 780 feet of string, making an angle of near 45 degrees with the horizon, he drew sparks from his conductor 3 inches long and 1/4 of an inch thick, the snapping of which was heard about 200 paces. Whilst he was taking these sparks, he felt, as it were, a cobweb on his face, though he was above 3 feet from the string of the kite, After which H did not think it safe to FENX so near, and called aloud to all the company to retire, as he did himself about 2 feet, thinking himself now secure enough. And not being incommoded by any body very near him, he took notice of what passed among the teapods which were immediately over the kite, but could perceive no lightning thither, there or anywhere else, nor scarce the eye-cast noise of thunder, and there was no rain at all. The wind was west, and pretty strong, which railed the kite 2 feet higher, at least, than in the other experiments. Afterwards, carting his eyes on the tin tube, which was fastened to the string of the kite, and about 3 feet from the ground, he saw 3 straws, one of which was about 1 foot long, a second 4 or 5 inches, and the third 3 or 4 inches, all standing erect, and performing a circular dance, like puppets under the tin tube, without touching one another. This little FP like clack-clack, which much delighted FT Verl of the company, lasted about a quarter of an hour, after which some drops ought rain falling. He again perceived the fanfalion of the cobweb on his face, and at the same time heard a continual rustling noise like that of a small forge bellows. This was a farther warning of the increase of electricity, and from the first instant that Mr. de Romas perceived the dancing straws, he thought it not advisable to take any more sparks even with all his precautions, and he again entreated the company to spread themselves to a still greater distance. Immediately after this came on the last act of the entertainment, which Mr. de Romas acknowledged made him tremble. The longest straw was attracted by the tin tube, upon which followed 3 explosions, the noise of which greatly resembled that of thunder. Some of the company compared it to the explosion of rockets, and others to the violent craflong of large earthen jars against the pavement. It is certain that it was hid into the heart of the city, notwithstanding the various noises there. The fire that was seen at the instant of the explosion had the height of a FP tiny 8 inches long and 5 lines in diameter. But the most astonishing and diverting circumstance was produced by the straw, which had occasioned the explosion, followed the siring of the kite. Some of the company saw it at 45 or 50 fathoms distance, attracted and repelled alternately with this remarkable circumstance, that every time it was attracted by the string, flafties of fire were seen, and cracks were heard, though not too loud, as at the time of the former explosion. It is remarkable that from the time of the explosion TD, the end of the experiments, no lightning at all was seen, nor scarce any thunder heard. A reel of sulfur was perceived, much like that of the luminous electric effluvia flowing out of the end of an electrified bar of metal. Round the string appeared a luminous cylinder of tight, 3 or 4 inches in diameter. And this being in the daytime, Mr. de Romas did not question, but that, if it had been in the night, that electric atmosphere would have appeared to be 4 or 5 feet in diameter. Lastly, after the experiments were over, a hole was discovered in the ground, perpendicularly under the tin tube, 1 inch deep and half an inch wide, which was probably made by the large flaws that accompanied the explosions. An end was put to these remarkable experiments by the filing of the kite, the wind being shifted into the east, and rain mixed with hail coming on in great plenty. Whilst the kite was falling, the Ilwering came soul of a penthouse, and it was no sooner disengaged than the person who held it felt such a stroke in his hands and such a commotion through his whole body as obliged him terribly to let it go. And the siring falling on the feet of some other persons gave them a hock also, though much enquire tolerable. The quantity of electric matter brought by Tleokite from the clouds at another time are really astonishing. On the 26th of August, 1756, the ether cams of fire flowing from it were observed to be 1 inch thick and 10 feet long. This amazing slash of lightning, the effect of which on buildings or animal bodies would perhaps have been equally destructive with any that are mentioned in history. Wawe, Giat said. Magas fought of he I-76P3. Daftly conduced by the cord of the kite to a non-electric body placed near it, and the report was equal to that of a pistol. Mr. Romas had the curiosity to place a pigeon in a cage of glass, in a little edifice which he had purposely placed, so as that it should be demolished by the lightning brought down by his kite. The edifice was, accordingly flattered to pieces, but the cage and the pigeon were not struck. The O.B. Nolet, who gives this account, adds that if a ferox of this kind had gone through the body of Mr. de Roma's, the unfortunate Profelter Richmond had not probably been the only martyr to chlericity, and advises that great caution be used in conduring such dangerous experiments. FD. When we consider how many severe shocks the MoFi cautious and judicious electricians often receive through inadvertence, we all not be for pride, that when philosophers first began to coddle and make experiments upon real lightning, it failed sometimes have proved a little untrattable in their hands, and that they were obliged to give one another frequent cautions how to proceed with it. The Abbé Nogelet, as early as the year 1752, advises that these experiments be made with circumpigeon, as he had been informed by letters from Florence and Bologna, that those who had mad them there had had their 46 experiments of the French their curiosity more than satisfied. High the violent shocks they had few flamed in draw wold, farfs from an iron bar, electrified by thunder. One of his correspondents informed him that once, as he was endeavoring to fasten a small chain with a copper ball at one of its 8 extremities to a great charn, which communicated with the bar at the top of the building, why in order to draw off the electric sparks by means of the oscillations of this ball, there came a flash of lightning, which he did not see, but which eddied the chain with a noise like that of wild fire. At that instant, the electricity communicated itself to the chain of the copper bally, and gave the observer so violent a commotion that the ball fell out of his bands, and he was ruck backwards 4 or 5 paces. He had never been so much shocked by the experiment of Leyden. M.K. Romas received a severe stroke when he all raised his kite, and Mr. Dalabordi, the physician of Saint-Germain-en-Laye, member of the Academy of Sciences at Paris, and Mr. Berthier of the Oratory at Montmorency, a correspondent of the Academy, were both struck down by ferox of lightning, as they were taking sparks from the EGI apparatus F, but the greatest sufferer by experiments with lightning. FMC mankind have introduced so dangerous a subject. Of their inquiries was Professor Richmond of Petersburg, Phil. Transvold P. Juff, before and Ilvitinin 417 before mentioned. He was struck dead the 6th of August 1753 by a flash of lightning drawn by his apparatus into his own tomb as he was attending to an experiment he was making with it. There were 2 accounts of this fatal accident communicated to the Royal Society, one by Dr. Watson, which Q had it from the Heft Authority, and the other translated from the High Dutch F. From both these, the following is extrafold. The professor had provided himself with an instrument which he called an electricae nomen, the use of which was to measure the strength of electricity. It consisted of a rod of metal terminating in a small glass vitel, into which, for what reason I do not know, he put some brass filings. At the top of this rod a thread was fastened, which hung down by the side of the rod when if was not electrified, but when it was, it avoided the rod and flowed at a distance from it, making as angle at the place where it was fastened. To measure this angle, he had the arch of a quadrant fastened to the bottom of the eruptad. He was observing the effect of the eluidity of the clouds at the approach of a thuader stormyi upon this nomen jade, and of course, it standing with Bia's head inclined towards it, accompanied by Mr. Solikal, an engraver whom he frequently took with him to be a fill. Trior, volume XL2 joint 48, the history of Job Abicover of his L9 Arcal experiments. ID order to represent them the better in cuts. When this gentleman, who was islanding Sitofe to his elbow, observed a globe of blue fire, as he called it, as big as his 611, jumped from the rod of the gnomon towards the head of the professor, which was, at that in hand, at about a foot distance from the RD. This slash killed Mr. Richmond. But Mr. Solikal could give no account of the particular manner in which he was immediately affected by it. For at the same time that the professor Wasselruck, there arose a sort of ilium, or vapor, which entirely benumbed him, and made him sink down upon the ground, so that he could not remember even to have heard the clap of thunder, which was very loud. A globe of fire was attended with a report as loud as that of a pistol. A wire, which brought the electricity to a metal rod, was broken to pieces, and its fragments thrown upon Mr. Solico's clothes. Halls of the glass V-fill in which the rod of the gnomon stood was broken off, and die filings, or TRF metal, that were in it were thrown about TBT room. Upon examining the effels of the lightning in the professor's chamber, they followed the door cafe half split through, and the door torn off and thrown into the room. They opened a vein of the breathless body twice, but no blood followed, and endeavored to recover Zeroglac, Professor Richmond. 419 cover sensation by violent chasing, but in vain. Upon turning the corpse with the face downwards during the rubbing, an inconsiderable quantity of blood ran out of the mouth. There appeared a red spot on the sore head from which F. purted some drops of blood through the pores without wounding the Ephesin. The fleo belonging to the left foot was burful, open, and uncovering the foot at that place, they found a blue mark, from which it was concluded that the electrical force of the thunder, having entered the head, made its way out again at that foot. Upon the body, particularly on the left side, were several red and blue spots, refiment blatl, leather ftirunk by being burnt. Many more blue spots were afterwards visible over the whole body, and in particular over the back. That upon the sore head changed to a browny red, but the hair of the head was not FMG'd, notwithstanding the spot touched some of it. In the place where the eho was unripped, the flocking was entire, as was the coat everywhere. The waistcoat only being singed on the foreflap where it joined the hinder, but there appeared on the back of Mr. Solico's coat long narrow eye treats, as if red-hot wires had burned off the nap, and which could not be well accounted for. When the body was opened the next day, 24 hours after he was struck, the cranium was very entire, having no feature, nor 420 DSB history, and C nor cross opening, the brain as abundant as it possibly squalled be. But the trough parent pellicles of the windpipe were excessively tender, gave way, and easily rent. There was some extravasated blood in it, as likewise in the cavities below the lungs, those of the BR calf being quite found, but those towards the back of a browny eye black color, and filled with more of the above-mentioned blood. Otherwise, none of the entrails were touched, but the throat, the glancy, and the thin intestines were all inflamed. The singed, leather-colored spots penetrated the yolking only. Twice 24 hours being elapsed, the body was so far corrupted that it was with difficulty they got it into a coin. Section 421. Chapter 27. Period X, Section 12, Electricity in the Atmosphere, Observations on the Generi. State of electricity in the atmosphere and its more usual effects, electrians. After observing the great quantity of electrical sea matter with which the clouds are charged during a thunderstorm, began to attend to the lesser quantities of it, which might be contained in the Koifman state of the atmosphere, and the more usual EF depths of this great and general agent in nature, FT4. Monnier, whose observations of the electricity of the air during a thunderstorm had been already mentioned, was the first who found that there was very often, and perhaps always, a quantity of electric matter in the atmosphere when there was no appearance of thunder. This he confirmed by decisive experiments made at Saint-Germain-en-Laye and published in a memoir read at the Royal Academy of Sciences at Paris, November the 15th, AG. But more accurate experiments upon the electricity of the air were made by the Abbé Mézières at Château de Montion during the months of June, July, and October 1753, and communicated to the Royal Society. In a letter to Dr. Stephen Hales, the 422 effects of electricity, the Abbé's apparatus consisted of an iron rod 370 feet long, raised 90 feet above the horizon. It came down from a very high room in the castle where it was fastened to a filson cord 6 feet long, and it wanted carried from thence to the steeple of the town, where it was likewise fastened to another silken cord of 8 feet long, and sheltered from rain. And a large key was suspended by the end of this wire, in order to receive the electric fluid. On the 17th of June, when he began his experiments, the electricity of the air was feniably felt every day from sunrise till 5 or 8 in the evening. He accepted mole weather when he could perceive no signs of electricity. In dry weather, the wire attracted minute bodies at no greater distance than 3 or 4 lines. He repeated the experiment carefully every day, and constantly observed that, in weather void of storms, the electricity of a piece of feeling wax of 2 inches long was above twice as strong as that of the air. This observation inclined him to conclude that in weather of equal dryness, the electricity of the air was always equal. It did not appear to him that hurricanes and tempests increased the electricity of the air, when they were not accompanied with thunder, for that during 3 days of a very violent continual wind in the month of July, he was obliged to put some dust within 4 or 5 lines of the conductor, before any sensible attraction could be perceived in the atmosphere. 425. The direct fan of the winds, whether east, west, north, or south, made no sensible alteration in the electricity of the air, except when there were more. In the driest nights of that FPMR, he could perceive no signs of electricity in the air, but it returned in the morning when the sun began to appear above the horizon, and vanified again in the evening, about half an hour after funfunkti. The Feftrojef common electricity of the ETR atmosphere during that summer was perceived in the month of July on a very dry day, the heavens being very clear and the sun extremely hot. The difference of 10 or 12 lines was then sufficient for the approach of the dull to the conductor in order to see the particles rise in a vertical direction, like the filings of iron on the approach of a magnet. On the 8th of June, at 2 in the afternoon, he perceived some stormy clouds rising above the horizon, and immediately went up to his apparatus, and having applied the dull to the key, it was attracted with a force which increased in proportion as the clouds reached the zenith. When they had come nearly over the wire, the dust was so impetuously repelled as to be entirely scattered from the paper. He drew considerable sparks from it, though there was neither thunder nor lightning. When the stormy clouds were in the zenith of his wire, he observed that the electricity was increased to such a degree that Eka 424 effects or electricity enon, the silken thread, attracted light bodies at the distance of 7 or 8 inches. These stormy clouds remained about 2 hours above the horizon, without either thunder or lightning, nor did a very heavy rain dimipy the electricity, except about the end, when the clouds began to be dissipated. Mr. Kinnersley observed that when the air was in its driest state, there was always a considerable quantity of electricity in it, and which might be easily drawn from it. Let a person, he says, in a negative state stand outdoors. In the dark, when the air is dry, hold, with his arm extended, a long harp needle pointing upwards, and he will soon be convinced that electricity may be drawn out of the air jet, not indeed very plentifully, or being a bad conductor. It seems loath to part with it, yet FPMA will evidently be collected. The air near the profan's body having left, then the natural quantity will have none to spare. But his arm being extended, as above, some will be collected from the remoter air, and will appear luminous as it converges to the point of the needle. Now the BT, a person electrified negatively, he lays, present the point of a needle horizontally, to a cork ball suspended by Phil C, and the ball we will be attracted towards the point, till it has parted with so much of its natural quantity of electricity, as to be in a negative state, in the same in the atmosphere. 425, same degree with the person who holds the needle, then it will recede from the point being, as he jumps, attrad the contrary way by eliguricity in the air behind it. But as this opinion, he fairly says, seems to deviate from electrical orthodoxy, he would be glad to see these phenomena better accounted for by the superior and more penetrating genius of his friend Dr. Franklin, to whom he is writing. Whether the electricity in the air in clear D-Phi weather be of the same density at the height of 200 or 300 yards, as near the surface of the earth, he thought might be really determined by Dr. Franklin's old sea excipermist of the kite. The twill, he says, should have thrown out a very small wire in it, and the ends of the wire, where the several lengths are united, ought to be tied down with a wax thread, to prevent their aiding in the tinentup. When he wrote this letter, he had tried the experiment twice, when the air was as dry as it ever is in that country, and so clear, that not a cloud had been seen, and found the twill each time in a small degree elected positively. The preceding observations of Mr. Monnier, Mr. Mazillas, and Mr. Kinnerke fall far flippertcf the extent and accuracy of those of Signor Beccaria, whose observations OA 426 effects or electricity. The general state of electricity in the atmosphere I have reserved for the last place of the section, because they are the most considerate, though they were all made independent of, and many of them prior to those met night before. He observed that, during very high wills, his apparatus gave no signs of being elevated. Indeed, he found that, in 3 different states of the atmosphere, he could find no telephoricity in the azure, in wildy and clear weather. 2, when the flies was covered with diame and black clouds that had a slower notion. 3, in moist weather, not a highly raining in a clear Ike. When the weather was calm, he always perceived signs of a moderate electricity, but interrupted. In rainy weather, without lightning, his apparatus was always electrified a little time before the rain cell, and during the time of the rain, but it ceased to be affected a little before the rain was over. The higher his rods reached, or his kite slew, the stronger finding they gave of their being electrified per cent. Also longer firings or cords, extended and insulated in the open air, acquired electricity sooner than those which were fly otter. A cord 500 Paris feet long, stretched over the river Po, was as strongly electrified during a high hour without thunder as a metallic rod to bring lightning litera Dr. Elettriolino P106 into Goodle in the atmosphere. 427 into his house had been in any thunderstorm, having 2 rods for bringing the lightning into his house, 140 feet asunder, he observed, that if he took a spark from the higher of them, the spark from the other, which while 30 feet lower, was at that instant Le Flen J. But what is remarkable is that its power revived again, though he kept his hand upon the former M. He imagined that the electricity communicated to the R might betimes furnish small sparks to his apparatus. Since the air Peru with the electricity, it has received very slowly, and therefore the equilibrium of the electric matter in the air will not be restored so soon as in the earth and clouds IET. Among the efficacy of a moderate elicity in the atmosphere, Signor Beccaria reckons rain, hail, ANGJ. Clouds that bring rain, he thought, were produced in the same manner as thunderclouds, only by a more moderate electricity. He describes them at large, and the resemblance which all their phenomena bear to those of thunderclouds is indeed very frickin' section. He notes several circumstances attending rain without lightning, which make it very probable that it is produced by the same cause as when it is accompanied with lightning. Light has been seen among the clouds by 7 night 428 effects of electricity nigit in rainy weather, and even by day rainy clouds are sometimes seen to have a brightness evidently independent of the fund. The uniformity with which the clouds are spread and with which the rain falls, he thought were evidences of a uniform cause, like that of electricity. The inlucidity of electricity in his apparatus generally corresponded very nearly to the quantity of rain that fell in the same time per cent. Nor is any idea he inferred to the contrary of this supposition from the apparatus not being always electrified during rain. It has sometimes sailed during thunder. Indeed, it follows from his general theory that the electricity of his apparatus could not always correspond to the electricity of the clouds. FMSC, it must, in some measure, depend upon the situation of the observatory. With reference to those parts of the earth or clouds which are giving or taking electric fire, this was confirmed by an observation which he made upon one thundercloud, which pulted over his observatory. At its approach, his apparatus was verified positively. When it was directly over him, all signs of electricity ceased, and when it was baffled, his apparatus was trifled negatively sectioned. This observation very much savors his general theory of thunder clouds. Sometimes all the phenomena of thunder, lightning, hail, rain, snow, and wind have exhibit PJ7, section abid PJ08. Date Benjager gets you 429 be observed at one time, which shows that Kundi. They all have with some Kamoa cause. Signor Beccaria therefore supposes that, previous to rain, a quantity of electric matter escapia out of the earth, in some place where there was a redundancy of it, and in its ascent to the higher regions of the air collects and conduds into its path a great quantity of vapors. The same cause that collects will condense them more and more, till in the places of the nearest intervals they come almost into contact, so as to form small drops, which uniting with others as they fall, come down in rain. The rain will be heavier in proportion as the electricity is more vigorous, and the cloud approaches more nearly to a thundercloud. He imitated the appearance of clouds that bring rain by infutating himself between the rubber and conductor of his electrical machine, and with a hand dropping colifornia into a spoon fastened to the conductor, and holding a burning coal, while his other hand communicated with the rubber. In these circumferences the smoke spread along his arm and by degrees all over his body, till it came to the other hand that communicated with the rubber. The lower surface of this smoke was everywhere parallel to his depths, and the upper surface was swelled and arched like clouds, replete with thunder and rain percent. This 430 effects or electricity, this math nerd he supposes. The clouds that I will rain defuff see themselves from over those parts of the earth which abound with electric fire to those parts that are exhausted of it, and by letting fall their rain, recalque the equilibrium between them. Signor Beccaria thought that the electricity communicated to the air, which both receives and parts with it finally, would account for the retention of vapors in a clear icky, for small disjoint clouds not dispersed into rain. For the smaller and lighter clouds in the higher regions of the air, which are but little affected by electricity, and also for the dark and heavy and sluggish clouds in the lower regions, which retain more it. The Degrakoff electricity which he could communicate to the air of his room, notwithstanding its being in contact with the floor, the walls, and sea, made this appear to him both possible and probable. He even imagined that some alteration in the weight of the air might be made by this electricity of it. He observed his barometer to fall a little immediately upon a flat lightning, but he acknowledges that this circumstance is no sufficient foundation to theopisia. Electricity will account for much variation of the height of the barometer. But he thought that the phenomena of rain savored the supposition that the electric matter in the air did in some measure lessen its press letter del electricissimo, P348, 349. Sure. In the atmosphere, 41 lure. For when the electric matter is agilely in the air, cool flidge and condenfiat 6 vapors, the barometer is lowest. When the communication is made between the earth and the clouds by the rain, the quicksilver begins to rise, the electric matter, which supported part of the pressure, being discharged. And this will be the case whether the electricity in the air be in positive or negative hail. This ingenious philosopher supposes to be formed in the higher regions of the air, where the cold is intense and where the electric matter is very copious. In these circumstances, a great number of particles of water are brought near together, where they are frozen, and in their descent collect other particles, so that the density of the substance of the hailstone grows less and less from the center, this being formed first in the higher regions and the surface being collected in the lower. Agreeable to this, it is observed that in mountains, hailstones, as well as drops of rain, are very small, there being but small space through which they can fall, and thereby increase their bulk. Drops of rain and hail agree also in this circumstance, that the more intense is the electricity that forms the ale, the larger the aries. Motion is known to promote freezing, and so the rapid motion of the elicified clouds may promote that of feel. In this $8%, you got clouds 43 effects of electriaxy, and clouds of snow differ in nothing front clouds of rain, but in the circuments of cold which freezes them, both the regular diffusion of snow. Agid the regularity in the structure of the parts of which it confifta, particularly some figures of snow or hail, which he calls roftai and which fall about Turin, show the clouds of snow to be actuated by some unil form cause like electricity. He even endeavors, very particularly, to show in what manner certain configurations of snow are made. By the uniform action of electricity F, all these conjectures about the cause of hail and snow were confirmed by observing that his apparatus never failed to be electrified by snow as well as by rain. A more intense electricity unites the particles of hail more closely than the more moderate electricity does those of snow. In like manner, we see thunder clouds more dense than those which merely bring rain, and the drops of rain are larger in proportion, though they often fall not from so great a height %. I shall conclude this Phaeon with observing that Professor W. Ellenthorp found his apparatus to be strongly electrified for several hours, while the snow, which fell the day before, and which had not electrified his apparatus while it was falling, was driven about by a high will, the same he had observed twice, B. Letcredel, Illetensomd, P. Percento, 321, $32. Section R1, Coti TIC, 433, Chapter 28, Period X, Section 12, Unusual Appearances in the Earth and Heavens, to explain some of the more unusual appearances in the Earth, odd heavens, BV electricity. In the two preceding Phaeons of this period, relating to the electricity of the atmosphere, the experiments and observations of Signor Beccaria have made a principal figure, and the materials I have collected from him make a no less considerable part of this. They who may have thought he indulged too much to imagination before will think him absolutely extravagant here. But his extravagancies, if they be such, are those of a great genius, and had he 1,000 more such extravagancies, I should, with pleasure, have followed him through them all. The meteor, usually CSWK3, falling gyre, has hitherto puzzled all philosophers. Signor Beccaria makes it pretty evident that it is a cleftrial appearance, and the fact which he relates as a proof of it is exceedingly curious and remarkable, as he was one time sitting with a friend in the open air an hour after sunset. They are what is called a falling star, direct its course towards them, and apparently grow, J larger and larger till it disappeared not far F from go 5,434, the theory of from them, when it left their faces. Bands enclose with the earth, and all the neighboring objects, fuddently illuminated with a diffift and lambent light, attended with no noise at all, while they were starting up, handing, and looking at one amphitheatre. Surprised at the appearance, a servant came running to them out of a neighboring garden, and asked them if they had said nothing, for that he had seen a light eye high and footily in the garden, and especially upon the streams which he was thrown to water it. All these appearances were evidently electrical, and Signor Beccaria was confirmed in his conjecture that electricity was the cause of them, by the quantity of electric matter which, as was mentioned before, he had seen gradually advancing towards his kite. For that, he says, had very much the appearance of a falling star. Sometimes also he saw an eye sign of glory round the kite, which followed it when it changed its place, but less Fom's light for a small f-pack of time, in the place which it had quitted f. That appearances which bear evident marks of electricity have a very sensible progrophy motion is demonstrated from a variety of meteorological observations. One shall relate ein made by X. Chalmers when he was on board the Montague under the command of Admiral Chambers, the coin of it left Tier del Electrodromo, P. the 3 meteors. 435 was raised at the Royal Society, March the 22 J 749, on the 4th of November 1749. In lat 42 degrees 48 long by 3, he was taking an observation on the quarterdeck. About 10 minutes before 12, when one of the quartermasters desired he would look to the windward, upon which he observed a large ball, a blue fire rolling on the surface of the water, at about 3 miles distance from them. They immediately lowered their topsails and sea, but it came down upon them so fall that before they could raise the main tack, they observed the ball to raise almost perpendicular and not above 40 or 50 yards from the mainsheets, when it went off with an explosion as if hundreds of cannon had been fired at one time, and left so great a smell of brimstone that the eye-hip seemed to be nothing but sulphur. After the noise was over, which he believed did not last longer than half a second, they found their main topmast flattered into above 100 pieces, and the mainmast rent quite down to the heel. There were some of the spikes which dot nailed the fifely of the mainmast drawn with such force out of the mast, and they stuck so fact in the maindeck that the carpenter was obliged to take an iron crow to get them out. There were 5 men knocked down, and one of them greatly burnt by the explosion. They believed that Verhenthy ball, which appeared to them to be of the bigness of a large mill earthy tone, rose. It took the middle of the main top maffy. As the FF2 had 436, the theory of had the master hose, the hounds was not F-plingered. They had a hard gale of wind from the NBW to the NNE. For 2 days before the accident, with a great deal of rain or hail and a large FIA from the northward, they had no thunder or lightning, neither before nor after the explosion. The ball came down from the north-eft and went to the southwest. That the aurora borealis is an electrical phenomenon was, I believe, never disputed, from the time that lightning was proved to be one. To the circumstances of resemblance which had before been taken notice of between this phenomenon and electricity. Signor Beccaria adds that when the aurora borealis has extended lower than usual into the atmosphere, various sounds, as of rumbling and whistling, have been heard. Mr. Bergman says he has often observed the magnetic needle to be disturbed by a high aurora borealis, but that he could never procure any electricity from them, either with pointed metallic rods or by means of a kite. Mr. Canton, besides his conjecture mentioned before PSQ, that the aurora borealis may be the flying of teleptric fire from positive towards negative clouds at a great distance, through the upper part of the atmosphere, where the resistance is leal. Fupafias, that the aurora borealis, which happens illeta sermo initiali naturale, PCB, is the electricity of the heated air above it, and this, he says, will appear chiefly in the northern regions, as the alteration in the heat of the air in those parts will be the greatest. This hypothesis, he adds, will not seem improbable, if it be considered that electricity is known to be a cause of thunder and lightning, that it has been extracted from the air at the time of an aurora borealis, that the inhabitants of the northern countries observe the aurora to be remarkably strong when a Fudsinthu happens after severe cold weather, and that the curious in these matters are now acquainted with a substance that will, without Frisian, both emit and absorb the electric fluid only by the increase or diminution of its heat, meaning the tourmaline in which he had discovered that property. In a paper dated November the 8th, 1754, he says he has sometimes known the air to be electrical in clear weather, but never at night, except when there has appeared an aurora borealis, and then but to a small degree, which he had several opportunities of observing that year. How far positive and negative electricity in the air, with a proper quantity of moisture between, to serve as a conduler, will account for this, and other meteors sometimes seen in a serene fly, he leaves to be inquired into VF7 Signor 1 QGVA 438 TX theory of Signor Beccaria. Take some pair WT a show 2 about water pouts have as electrical origin. To make this more evident, Beaufort describes the circumstances attending their appearance, which are the following. They generally appear in calm weather. The FIA seems to boil, and send up a smoke under them, rising in a hill towards the spout. At the same time, persons who have been near them have heard a rumbling noise. The form of a water spout is that of a F-peaking trumpet, the wider end being in the clouds and the narrower end towards the FIA. The tease is various, even in the same spout. The color is sometimes inclining to lute, and foam amounts to black. Their pouchen is sometimes perpendicular to the FIA, sometimes oblique, and sometimes the spout itself is in the form of a curve. Their continuance is very various, some disappearing as soon as formed, and some continuing a considerable time. One that he had heard of continued a whole hour, but they often vanish, and briefly appear again in the same place. The very same things that water spouts are at FIA are some kinds of WRRs and hurricanes by land. They have been known to tear up trees, to throw down buildings, make caverns in the earth, and in all these cases to scatter earth bricks, blown timber, and sea to a great distance in every direction, T-Great Electridru U9 Rale, P200 Squale Key water spouts. 439 quantititles of water have been lessed or raised by them so as to make a kind of deluge, and they have always been attended with a pure sedituate rumbling noise. That these phenomena depend on electricity cannot but appear very probable from the nature of several of them. But the conjecture is made major probable from the following additional circumstances. They generally appear in months peculiarly subject to thunderstorms, and are commonly preceded, accompanied, or followed by lightning, rainy, or hail, the previous state of the air being fimallar. Whitish or yellow flashes of light have sometimes been seen moving with prodigious FWLs about them. And lastly, the manner in which they terminate exactly resembles what might be expected from the prolongation of one of the uniform protuberances of electrified clouds mentioned before, towards the Phae, the water and the cloud mutually attracting one another. For they suddenly contraddle themselves and disperse almost at once, the cloud rising and the water of the Phae under it falling to its level. But the most remarkable circumstance, and the most favorable to the supposition of their depending upon electricity, is that they have been dispersed by presenting to them flyer-pointed knives or swords. This, at least, is the constant practice of mariners in many parts of the world where these water spouts abound, and he was a fleer ND by several of them, that FF4, the 44. The theory of the method has often been undoubtedly effectual. The analogy between the phenomena of water spouts and electricity, he says, may be modifiable by hanging a drop of water to a wire communicating with the prime conducer, and placing a vessel of water under it. In these circumstances, the drop assumes all the various appearances of a water spout, both in its rise, form, and manner of disappearing. Nothing is wanting but the smoke, which may require a great force of electricity to become visible. Mr. Wilkie also considers the water spout as a kind of great electrical cone raised between the clouds strongly electrified in the Phae or the earth F, and he relates a very remarkable appearance which occurred to himself, and which strongly confirms his supposition. On the 12th of July 1758, at 3 o'clock in the afternoon, he observed a great quantity of dust rising from the ground and covering a field and part of the town in which he then was. There was no wind, and the dust moved gently towards the east, where there appeared a great black cloud, which, when it was near his zenith, electrified his apparatus positively, and to as great a degree as ever he had observed it to be done by natural electricity. This cloud passed his zenith and went gradually towards the west, the dust then following it, and continuing to El Sermo Fidel in Naturale, PSI Thrilkels PF Wilkels P142, rise water steps. 441 rise higher and higher till it composed a thick pillar in the form of a fugerloaf, and at length seemed to be in contafel with the cloud. At some distance from this, there came, the same path, another great cloud, together with a long stream of smaller clouds, moving faster than the preceding. These clouds electrified his apparatus negatively, and verhen, they came near the positive cloud. A flash of lightning was seen to dart through the cloud of dust, the positive cloud. A large negative cloud, and as far as the eye could distinguish fly, the whole train of smaller negative clouds which followed it. Upon this, the negative cloud spread very much, and diltoved in rain, and the air was presently clear of all the dust. The whole appearance laughed not above half an hour. The Signor Beccaria's theory of water spouts and hurricanes, one shall add a description of a hurricane in the West Indies, from the Jicon of the European settlements in America, part of which is transcribed from the Philosophical Transagens. Both were evidently written without the most distant view to any philosophical theory, and least of all that of electricity, and yet those who are disposed to savor this hypothesis may perceive several circumstances which tend to strengthen it. I need not point them out. It is in the rainy season, principally in the month of August, more rarely in July, Remserletter on Dr. Frascinaletto, P340. The theory up in September that they are flawed by hurricanes, the most terrible calamity to which they are subject from the climate. This destroys at one feftrot the labor of many urea, and frustrates the most exalted hopes of the planter. and often just at the moment when he thinks himself out of the reach of fortune. It is a sudden and violent form of willed feign, thunder and lightning attended with a furious swelling off the fia, and sometimes with an urgy quaffs. In short, with every circumstance which the elements can afflemble, that is, terrible and diffusive. First they see, A, and a prelude to the ensuing have of C, whole fields of sugar canes whirled into the jar, and F cattered over the face of the country. The strongest trees of the forest are torn up by the roots, and driven about like stubble. Their willed mills are swept away in a moment. Thight works, their fixtures, the ponderous copper boilers and stills, of several hundred weight, are wrenched from the ground and batter Ed to pieces. Their houses are no protection, the rooster torn off at one blast, whilst the rain, which in an hour rises 5 feet, rooflies in upon them with an irresistible violence. There are signs which the Indians of these islands taught per planters, by which they can prognosticate the approach of a hurricane. It comes on either in the quarter or at the few or change of the moon, if hurricanes. 443, if it will come on FET the full moon. You be in at the change, observe these signs. That day you will see the Ike very turbulent. You will obviously see the fun more red than at other times. You will perceive a dead county and the hills clear of all those clouds and mists which usually hover about them. In the clefts of the earth and in the wells you will hear a hollow rumbling found, like the rough teeing of a great wheel. At Yai night, the stars seem much larger than usual and surrounded with a sort of burrs. The northwest Ike has a black and menacing KXXK, and the feet emits a IT smell and rises into veil waves, often without any will. The wild itself now for fake CP at usual fleety, Ephraim, and hitting about to the weft J from whence it sometimes blows, with incremergens, violent lie and irregularly, for about 2 hours at a time. You have the same signs at the full of the moon. The moon itself is fur-rounded with a great burr, and sometimes the fun has the I-am appearance. The first person who advanced that earthquakes were probably caused by electricity was it. Stukely upon a Cafian of the earthquakes at London on February the 8th, and on March the 8th, 1749, and another which affected various other parts of England. The centre being about Daventry in northern Accadet of the European Seitlem in Amnic 44, 444, the theory of Tonftier on the 6th of September 1750. The papers which the Dodier delivered to the Royal Society on these Acafus, and which were read March the 2nd, 1749, and December the 6th, 1750, well deserve the attention of all philosophers and electricians. I shall here give the substance of both J only abridging, and thoroughly arranging the materials of. That earthquakes are not a wilga to subterraneous wilds, sires, vapors, or anything that occasions explosion, and heaves up the ground, he thought might easily be concluded from a variety of circumstances. In the sixth place, he thought there was no evidence of any remarkable cavernous furore of the earth, but that, on the contrary, there is rather reason to presume that it is in a great measure solid, so as to leave little room for internal changes and fermentations within its substance. J. nor do coal pits, he says, when on fire ever produce anything resembling an earthquake. In the second earthquake at London, there was no such thing as fire, vapor, smoke, smell, or an eruption of any kind observed, though the shock effected a circuit of 30 miles in diameter. This consideration alone of the extent of surface shaken by an earthquake, he thought was sufficient to overthrow the supposition of its being a willed to the expansion of any subterraneous vapors. For it could not possibly be imagined that so immense a force as could act upon that compass of earth, KGJJ 445 of ground instantaneously, should never break the surface of it, so as to be discoverable to the sight or smell, when small fireballs bursting in the air have instantly propagated a sulphurous smell all to the distance of several miles. Besides, the operation of this great fermentation and production of elastic vapors and sea ought to be many days in continuance, and not instantaneous, and the evaporation of such a quantity of inflammable matter would require a long. H.E. thought that if vapors and subterraneous fermentations, explosions, and eruptions were the cause of earthquakes, they would absolutely ruin the whole system of springs and fountains wherever they had once been, which is quite contrary to Sats. Even where they have been frequently repeated, mentioning the great earthquake which happened AD 17 when no less than 13 great cities of Asia Minor were destroyed in one night, and which may be reckoned to have diaken a mass of earth 700 miles in diameter. Yikes. How can we possibly conceive the action of any subterraneous vapors to produce such an effetal so intangibly? How came it to pass that the whole country of Asia Minor was not at the same time destroyed, its mountains reversed, its fountains and springs broken up and ruined forever, and the course of its rivers quite changed? Whereas nothing suffered but the cities, there was no kind of altera 446, the theory of alteration in the surface of the country, which indeed remains the same TD this day. To make the hypothesis of subterraneous vapors and sea being the cause of earthquakes the more improbable, he observes that any subterraneous povager sufficient to move a furious of earth 30 miles in diameter, as in the earthquakes which happened at London, must be lodged at least 15 or 20 miles below the surface of the earth, and therefore must move an inverted cone of solid earth whose basis is 30 miles in diameter, an axis 15 or 20 miles, and CFEC which he says no natural power could produce. Upon the same principle, the subterraneous cause of the earthquake in Asia Minor must have moved a cone of earth of 300 miles in base, and 200 in the axis, which he says all the gunpowder which has ever been made, since the invention of it would not have been able to stir, much less any vapors which could be supposed to be generated so far below the surface. It is not upon the principles of any subterraneous explosion that we can, in the least, account for the manner in which ships, far from any land, are felled during an earthquake, which seem as if they struck upon a rock, or as if something thumped against their bottoms. Even the 50s are affected by an earthquake. The stroke, therefore, must be occasioned by something that could communicate motion with unequivocally greater velocity. Then, and QGKSE 447, then any heaving of the earth under the FIA by the elasticity of generated vapors. This could only produce a gradual while and never give such an impulse to the water, as would make it feel like a stone. Comparing all these circumstances, Itabar Stukely says he had always thought that an earthquake was an electrical shock, of the same nature with those which are now become familiar in electrical experiments. And this hypothesis he thought was confirmed by the phenomena preceding and attending quakes, particularly those which occasioned for his publication. The weather, for 5 or 6 months before the first of these earthquakes, had been dry and warm to an extraordinary degree, the wind generally south and southwest, and that without rain, so that the earth must have been in a state of electricity ready for that particular vibration in which electrification consists. On this account, he observes that the northern regions of the world are but little subject to earthquakes in comparison with the southern, where the warmth and dryness of the air, so ancillary to ulcericity, are common. All the Fiat country of Lincoln Fleuric before the earthquake in September, though, underneath it is a watery bog, yet through the whole preceding timber and autumn, as they can have no natural springs in such a level. The drought had been so great on the surface of the earth that the inhabitants were obliged to drive their cattle several miles to water. 448 TNB theory of water. This, he says, for wait, how fit the dry surface was for an electrical vibration. And also, which is of great importance, that earthquakes reach but very little below the surface of the earth. Before the earthquake at London, all vegetables had been uncommonly forward. At the end of February, in that year, all sorts of garden stuff, fruits, flowers, and trees were observed to be as forward as in other years, about the middle of April, and electricity is well known to quicken vegetation. The aurora borealis had been very frequent about the same time, and had been twice repeated just before the earthquake, of such colors as had never been seen before. It had LFP removed to the south, contrary to what is common in England. So that some Italians, and people from other places where earthquakes are frequent, observing these lights, and the peculiar temperature of the air did actually foretell the earthquake. For a fortnight before the earthquake in September, the weather was serene, mild, and calm, and one evening there was a deep red aurora borealis covering the cope of heaven, very terrible to behold. The whole year had been exceedingly remarkable for fireballs, thunder, lightning, and curvacetions, almost throughout all England. Fireballs were more than once seen in Ireland and Lincolnshire, and particularly observed. And all these kinds of meteors, the Doter says, are rightly judged to precede earthquakes. 449 seed from the electrical state of the atmosphere. In these previous circumstances of the state of the earth and air, nothing, he says, is wanting to produce the wonderful effect of via earthquake, but the touch of some non-electric body which must necessarily be had ab extra from the region of the air, or atmosphere. Hence, he infers that if a non-electric cloud discharge its contents upon any part of the earth in that highly electrical state, an earthquake must necessarily ensue. As the discharge from an excited tube produces a commotion in the human body, so the discharge of electric matter from the compass of many miles of solid earth must needs be an earthquake, and the snap from the contact be the horrid uncouth noise attending it. The doctor had been informed by those who were up and abroad the night preceding the earthquake, and early in the morning that curvacetions in the air were extremely frequent, and that a little before the earthquake a large and black cloud suddenly coated the atmosphere, which probably occasioned the hawk by the discharge of a thiower. Dr. Childrey, he says, observes that earthquakes are always preceded by rain and sudden tempests of roy in times of great drought. A sound was observed to roll from the river Thames towards Temple Bar before the houses ceased to nod, just as the electrical soap precedes fee-shock. This noise, an OBGG for VCR 45 ed DCTA, fear effect cover said, was much greater than any height he ever heard. Others who write upon earthquakes commonly observe that the noise preets the feftiac, whereas it must have been quite the entree if the uncufio had deua pended upon a fluctuaceous eruption. Dit noise attending earthquakes, the Doter thought, could not be accounted for, but be puda the principles of electricity. The earthquake in September was attended with a roof-laying noise, active houses were falling, and people in some places ere so universally frighted as to run out of their hoofs, imagining that their own and those of their neighbors were tumbling on their heads. In Fonge villages, the people, being at divine fertice, were much firmed with the noise, which they said beyond all comparison exceeded all the thunder they had ever heard. The fianche and fulfures ficelles, which are faune times observed during earthquakes, the doctor thought were more easily accounted for from the supposition of their being electrica phenomena than from their being occasioned by the eruption of anything efconi, the bowels of the earth. The impression made by an earthquake upon land and water, to the greatest diligence and is, as wa and observed before, instantaneous, which cowled on fi be affected by an after city in the earthquake in September. The concursive antion was felt through a pace of lumites in length and 40 in breadth, and as far as could be judged, at TLI me jai often, of time that in a young good see tattoo afi. 488, this tract of ground, which amounted to 4,000 square miles loose surface, should be thrown into such agitation in a moment, is such a prodigy, the Dodler says, as we could never believe or conceive did we not know it to be sail from our senses. But if we thiefs the solution of it, we cannot think any natural power equal to it, but that of electricity, which acknowledges no sensible transition, o time no bounds. The little damage generally done by earthquakes, the doctor thought to be an argument of their being occasioned by an f-temple vibration, or tremulous motion of the far face of the earthy by an electrical snappy. The vibration, he says, infighted on the meeting with the solid bottoms of flips and lighters, occasions that thump, which is f-aid to be as felt by them, yet of the millions of ordinary jewels over which it baffled. Not one fell, a consideration which sufficiently points out what sort of emotion this was not. Also, what sort of emotion it was, and whence D.I.F.J., not a convulsure in the bowels of the earth. but in uniform vibration along its surface, like that of a musical string or what we put Kid Drinking Gus into by rubbing one finger on the edge, which yet being brought to a certain pitch, breaks the Glofsgia. Undoubtedly, he adds, an electrical repulsion of its parts. That earthquakes are electrical. P. Benoinina is farther evident, he says, from their chiefly effeing of Fiakov, places along Tivers, and T. may add Emineses. The GG3, Earth 452, the Theory 6 BP earthquake, in September spread mostly Otiki north and south, which the dollar says is the direction of the Spalding River, whereby it was conveyed to the Fee floor, where it was particularly sensible, J thence up Boston Channel, and UO up Boston River to Lincoln. The greatest part of this earthquake displayed its effects along and between the two rivers, Welland and Avon, and that from their sources down to their mouths. It likewise reached the river Witham, which directed the electrical stream that way also to Lincoln, for which reason, meeting the same coming from Boston, it was most sensibly felt that it reached likewise to the Trent at Nottingham, which conveyed it to Newark. The fifth electrical stroke in this earthquake seemed to the dough floor to have been made on the high ground about Daventry in Northamptonshire. From thence it descended chiefly eastward, and along the river Welland, from Harborough to Stamford, Spalding, and the Fee, and along the rivers Avon and Nen to Northampton, Peterborough, Whiffbitch, and the Fiat. It spread itself all over the vast level of the Isle of Ely, promoted by a great number of canals, natural and artificial, made for draining that country. It was still conduced eastward by Maldenhall River in Suffolk to Bury and the parts adjacent. All these circumstances duly considered were to him a confirmation of the doctrine he advanced on this subject. Lastly, Earth, QGJ, 453. Lastly, the doctor adds, as a farther argument in favor of his hypothesis, that pains in the back, rheumatic, hysteric, and nervous cases, headaches, colics, and were felt by many people of weak constitutions for a day or two after the earthquake, just as they would after electrification, and to me the disorders prove fatal. In what manner the earth and atmosphere are put into that electrical and vibratory state, which prepares them to give or receive that snap and shock, which we call an earthquake, and whence it is that this eely rick matter comes. The Dofloyer does not pretend to fey, but thinks it as diesel to account for as magnolifum, gravitation, muscular motion, and many other secrets in nature's ductifications of. I'll add some circumstances which were observed by Dr. Hales in the earthquake at London on March the 8th, 1749, as tending to strengthen the hypothesis of its being caused by electricity, though the doter who relates them thought that the electric appearances were only occasioned by the great agitation which the electric fluid was put into by the shock of so great a mass of the earth. At the time of the earthquake, about 20 minutes before 6 in the morning, after being awake in bed on a ground floor at a house near the church of St. Martbill, Transabridged, Volume XPJ 26, JJJ. AODP 40GG3, Tin 454 TSB, Dere Uplands in the fields, very sensibly felt his bed heave, and heard an obscure ruffling noise in the house, which ended in a loud explosion IPP in the air, H key, that of a small cannon the whole duration, from the beginning TQ the end, seeming to heat about 4 FCC fons. This great noise, the Dauphin EPR conjectured, was a will to the ruffling, or sudden expansion of the electric fluid at the top of St. Martin's spire, where all the electric effluvia, which ascended along the large body of the tower, being strongly condensed and accelerated at telepoint of the weathercock, AHI, the roof light off, made so much the louder expansive explosion. The doctor farther fea that the soldiers who were upon duty in St. James's Park, and 4 other persons who were then up, saw a blackle cloud and a considerable lightning just before the earthquake began. Mr. Hartman, of opinion that electricity 19, the cause of earthquakes, and gives a fuchicute enumeration of all the circumstances for which savored this hypothesis, my reader. We have seen to how great an extent Signor Beccaria has already carried the principles of electricity, will have no doubt, but that he supposes earthquakes to be derived from that cause. And indeed, without any knowledge of what Dr. Stukely had done, he forward supposed them to be electricat phenocina FUT, contrary to the doll, or imagined in Napandlon P.S. Flyric L. Co. Icy Earth QGG at KES 455, detric matter, which occasioned them to be lodged deep in the bowels of the earth, agreeable to his H.J. Pothefus, causering the origia of lightning. It ei certain that, if Signor Beccaria's account of the origin of thunderclouds be admitted, there won't be little de-incultion admitting farther, that earthquakes are to be reckoned among the faults of electricity. For if the equilibrium of the electric matter can, by any means, be lost in the bowels of the earth, eo that the best method of restoring it, hall be by the fluid burr and in its way into the air, and traversing feral miles of the atmosphere to Yaori to the place where it is wanted, it may easily be imagined that T-ent concussions may be given to the earth by the sudden passage of this powerful ache. And several circumstances attending earthquakes, he thought rendered this hypothesis by no means improbable. Volcanoes are known to have a near conedlion with earthquakes, and Flawley's AI light, exactly resembling lightning, have frequently been seen to rui from the top of Mount Vesuvius at the time that a flies and other light matter have been carried out of it into the air, and been dispersed uniformly over large troughs of country. Of these, he produces a great number of loftances from the best authority. El Citer dir Electrosermo, P.I. 6361, and C. G. Vor Aram 456. The theory of a rumbling noise, like thunder, is generally heard during an earthquake at such times. Also, slashes of light have been seen rising out of the ground and darting up into the air. Real lightning hath sometimes occasioned small fakings of the earth, at lead has been attended by them. But the strongest circumstance of resemblance which he observed is the same that Dr. Stukely lays so much stress on, viz. The amazing swiftness with which the earth is hacken in earthquakes. An earthquake, says he, is by no means a gradual heaving, as we might have expected, and from other causes, but an instantaneous concoufulon, so that the fluidity of the water is no security against the blow. The very flips, many leagues off the coast, feel as if they struck against a rock. This admirable Philosophery, having imitated all the great phenomena of natural electricity in his own room, doth not let the earthquake escape him. He says that if two pieces of glass enclosing a thin piece of metal be held in the hand, while a large shock is FCNT through them, a strong vibration or concussion will be felt, which sometimes, as in Dr. Franklin's experiment, breaks them to pieces. Signor Beccaria thinks that there are traces of electrical operations in the earthquake that happened at Julian's attempt to rebuild the Temple of Jerusalem. Liederker del Detricurmo, PJEJ, that earth KGJ at KES 457, that the electric fluid is sometimes eoleciated in the bowels of the earth, he thought was probable from the appearance of igneous Jatuian mines, which sometimes happens, and is very probably an elliptical phenomenon. Which of the two philosophers have advanced the more probable opinion concerning the seat of the electric matter, which occasions earthquakes, I shall not pretend to decide. I shall only prefer that perhaps a more probable general hypothesis than either of them may be formed out of them both. Suppose the electric matter to be, theme way or other, accumulated on one part of the surface of the earth, and, on account of the dryness of the season, not easily to diffuse itself, it may, as Signor Beccaria supposes, force itself away into the higher regions of the air, forming clouds in its passage out of the atmosphere, which float in the atmosphere, and occasion a sudden hour which may farther promote the passage of the fluid. The whole surface, thus unloaded, will receive a concussion like any other conducing substance on parting with, or receiving a quantity of the electric fluid. The ruffling noise will, likewise, sweep over the whole extent of the country, and upon this supposition also the fluid in its DLF charge FQM the country will naturally follow the course of the rivers, and also take the dare electrocern artificials enirale pij advantage foresight anquent electricae. Advantage of any eminences to facilitate its ascent into the higher regions of the air. I shall close this account of the TX2I of lightning and other phenomena of the atmospheric with an enumeration of the principal appearance of natural electricity detected by the ancients, and which were never under flood before the discovery of Dr. Franklin. It will be very cathy for me to do this, as I find them already Q&A'd to my hands by De Watson. A luminous appearance, which must have been of an electrical nature, is mentioned by Plutarch in his Life of Leonardo. He co-fitted it as a retior. Pliny, in his second book of Natura Hilary, calls those appearances GRs and tells us that they settled not only upon the males and other parts of the hips, but also upon men's heads. Exfigient, says that historian. Vidi nos lurnes, militum vigilius, in harere puis provolo fulgorum effigie eve, et antenu endivigantium alfice navium partibus si iuocoti, quodam funo infiunti, iud value ex fede tenutatis, et jam ata falutares et properi erfus pronuncia, quarum adventur fugari, diram illam siminasem appella fam, helen amphron, et ibi bolici et cagior id numina finanti ofque in martial in vici cicant, haminum quoque sigepiti veertinis horis, magna prefagio catitw, tertita fsttt. But appearances 459, but adfors either the things are in surge ration, t in natura magefiat, abdita stars make their appearance b, at land and fiat. I have seen a light in that form on the spears of soldiers, keeping watch by night upon the ramparts. There are fia also on the fail yards, and 4 other parts of ships, making an audible sound and frequently changing their places. 2 of these lights forebode good weather and a prosperous voyage, and drive away one that appears single and wears a threatening half a peat. This die sailors call Helenua, but the Tio they call Castor and Pollux, and invoke them as gods. These lights do sometimes about the evening rest on men's heads and are a great and good omen. But these are among the awful myphoria of nature. Seneca, in this Natural Queeflians chap, takes notice of the same phenomenon. Gillip foi Syracufus patenti visa tfd gela, fupra e piamenzentia. In Romanorum Caphiris visa funt ardere pill, and I ignibus choicit in illis det lapgis. A stack settled on the lance of Gillip Tepus as he was sailing to Syracuse, and spears have seemed to Ege on fire in the Roman camp. In Cr de Bello Africano cap sex sect, we find them attending a violent storm. Paridi tempus, sera cafarius, ersitu iref accidit incredibilis auditu. Nempiver 4.6, ancient electrical Virgiliarum, finio on faboi sursiter oigia, jacunda nozizi nimbus cum faxia grandin fugito, f tortuus dubient. Iam nosi legionis verfi, palorum cacumina, fua, f pone arferent. About that time, there was a very extraordinary appearance in the army of Caesar in the month of February. About the second watch of the night, there suddenly arose a thick cloud, followed by a shower of stones, and the same night, the points of the spears belonging to the 5th Legion seems to take fire. Livy cap 42 mentions 2 similar fasts. In Sicilia militibu, aliqua f pecula, in Sardinia muro circumuanti vegias equiti, f sipiomtri quern in manutenura arrive et libura crebris ignibuc fulfigi et. The spears of IB soldiers in Sicily, and a walking flick which a horseman Sardia was holding in his hand seemed to be on fire. The floors were also luminous with frequent sires. These appearances are called both by the French and Spaniards, inhabiting the coaphus of the Mediterranean, St. Helma's, or St. Telman sires, by the Italians the sires of St. Peter and St. Nicholas, and are frequently taken notice of by the writers of voyages. If some late accounts from France, adds the Douay, are to be depended upon, this phenomenon has been observed at Plazet for time immemorial. And Mr. Bynon, the cure appearances. 461 cur of the place says set that for 25 shekel years, which he has refted there, in great flans accompanied with black clouds, and frequent lightning, the three pointed extremities of the cross of the steeple D. That place appeared surrounded with a body of flame, and that when this phenomenon has been seen, the Ildrum was no longer to be dreaded, and calm weather returned soon after. Modern Bry furnishes a great number of examples of flames appearing at the extremities of pointed metallic bodies, progy and into the air. Little notice was taken of these, while the cause of them was unknown. But since their near affinity with lightning has been discovered, they have been more attended to and collete. Section 46 show.